Hey guys, welcome to the data structures and algorithm using Java course represented by GUVI. So myself, a full stack web developer, I'll be the instructor for this entire data structures course. So we'll see what is data structures and what all the topics which we are going to cover with this specific session over there. So data structures, as you know, it's a huge kind of a data, how we are going to organize and manipulate the data while writing the specific program efficiently. So where the data structure concepts is going to come into the picture, right? So where we are going to manage the data, how we are going to manage the data, how we are going to store it, what is the time complexity, what is the space complexity. So these all the things which comes in insertion, deletion, searching, sortings that's related with the data, right? So that's all the things we are going to call it as the data structures. So the main concepts comes into the data structures. The components are arrays, linked list, tracks, queues, trees, graphs, hash, and heaps. So we are going to cover all these specific concepts into this entire bootcamp. So we are going to look onto the concepts onto the introductions, like we are going to see what is the big O analysis and how the analysis of any program which you are given, you are going to do that. We are going to find the worst case, average case, best case, time complexity using the data structures principles. Then we are going ahead with the concepts of linear data structures, where we are going to see about arrays and array list, linked list, queues, stacks over here. And we are going to see along with the Java coding example with the theoretical part as well. Then we are going ahead with the concept of sorting and searching algorithms, like which is being used, bubble sort, insertion, merge, quick sorts, and what are the things which you are seeing on the screens. We are going to look on to the every concept with the theoretical and practical part on it. Then we are going ahead with the concepts with the graphs. We are going to see how we are going to find the adjacency matrix of the graphs, finding the minimum cost spanning trees, and seeing the greedy algorithms like Kruskal's, Prim's algorithms with the theoretical and practical part onto it. Then we'll move on to the concepts of introduction to the trees. That's a little bit advanced concepts in the DSA. We are going to look on to the trees, what all the representations of the trees, about the binary search tree, and we are going to look on AVL trees with the theoretical and along with the practical part onto it. So then we are going ahead with the concepts of hashing tables. We are going to see how the hashing techniques can be used for solving a given problem, and collision techniques with the coding examples of Java. Then we'll move on to the next dynamic programming concepts, where we are going to see the knapsack problems with the subset, multi-stage graphs, or we are going to traverse from one source to the vertex and coming visit back to the source vertex. We'll see the traversal salesperson using a shortest path, how he is going to traverse with the theoretical and practical path with the Java programming. Then we'll come back to the greedy algorithms, like how we are going to see the Hoffman's coding and greedy methods over there. Then we'll cover up the heaps and the priority queues in the last sections, like along with the min heap, we are going to see how to find the max heap, min heap, and priority queues over there. Then we are going to look on to the last concept in DSA, that is about the backtracking. We'll see the concept of Tower of Hanai and N-Queen's problem, BFS and DFS concepts using Java programming over there. So these are all the things which we are going to cover in this entire section. So thank you guys. I'm eager to wait you to watch the entire DSA course, where we are going to see all much on the practical and the theoretical part end to end over there. Thank you for participation. Take care. Bye bye.
Hey guys, welcome to the section 1, Introduction to Data Structures and Algorithm using Java. So let's understand the basic terminologies of data structures, and we're going to see what all the major terminologies like database, data warehousing, and what is big data. And we are going to look onto the memory allocations of data structures for the stack and heap into this specific session. So let's begin with this specific session. So what are the data structures? So data structures is basically a fundamental concepts, right, that is used to organize and manipulate the data efficiently, so that the retrieval and insertion, deletion, sorting kind of operation is going to be performed in a very convenient way. So majorly it provides how we need to use the specific computer memory storage, or how we are going to perform some such kind of an operations like insertion, deletion, searching, and sorting, how quickly we can do it. This is a major thing that comes into the data structures over there. So data structures has the major components over here. Like the components, if we talk about arrays, linked list, stacks, queues, trees, graphs, hash tables, heaps. These are the very major component that comes into the data structures that we are going to use efficiently for organizing the specific data for insertion purpose, or it can be for the retrieval purpose, or it can be for the sorting, or it can be for searching, or it can be for traversing. So these all things we are going to do with the help of this data structure concept. So every concept we are going to learn very deeply with the correct examples, and we are going to solve with the Java programs as well. So in this entire section 1, we are going to look on to the majorly like what is data structures and how memory allocations happens. We are going to look on how the time complexity is there, how the space complexity works. So we are going to have majorly, we are going to look on to the what is the notations of the data structures like big O, big omega, and theta. So we are going to look how this is exactly it is going to be there, right? So you should not skip this entire section. It is little bit about entirely theoretical part in section 1, and in the next section 2 we are going to work with the arrays, and we are going to work with the specific coding problems as well using the Java, right? So let's begin with the first thing. We need to understand like what is algorithm over here. To write any problem statement, for any given problem statement, if you write a specific solution, so if you are applying a concept of data structures, the first thing is comes into the picture is you need to write an algorithm for it. So what is algorithm is basically a writing a sequence of data using efficiently using a data structures. So how you are going to write an algorithm? If I get to given a given problem, there are n ways to solve a given problem. So if you are using a data for correct data structures and correct data structures concept, by using those concepts, we are going to use a algorithm. You are going to write an algorithm for a given problem. Then we are going to perform like how a good specific algorithm you have written. What is the time complexity of it? What is the space complexity of it? And what is the final output of your algorithm? Whether it is a big O of n or a big O of 1. So it might be a jargon word for you right now, like what is exactly the big O, what is omega, what is theta. And we are going to understand this into a very deeply. So just imagine for a given problem how we are going to solve a specific, how we are going to give a specific solution for it, and which efficient data structural algorithm you have been used. So where we are going to write the algorithms here. The major terminologies here comes, that's the database, data warehousing, and the big data. Let's take an example of an Instagram, right? So if you try to have your own profile, imagine you have thousands of 1000 posts written into your posted into your Instagram account. So the starting 10 data, the starting 10 post or a starting 20 post, that is being stored into the database. The remaining 80 data, what is the 80 posts are there, that is being stored into the data warehousing. That's the legacy data. Okay, that is kind of a data which you are not going to use every day, right? So imagine there is every day there is a millions of posts happens in Instagram. So if they are using a one specific server to store all the data, like the insertion might be a very takes the more time, and retrieval can take more time. So what they are going to do, they are going to balance the load. They are going to apply a concept of kind of a load balancing. So where we'll be differentiating the transferring the data into a different servers. So whichever the latest data will be there, that comes in from the database, and the legacy data which is not been instantly, that comes from the data warehousing. And there can be a big data as well, that is a very complex data, and it will have very big records of data that is not been used, but that will be used at the time of analysis. Imagine you want to analyze a specific data, it will give some kind of a output for it. At that time they are going to make use of the big data that's stored into a different servers over there. So basically here were a major terminologies in the sense like whenever we are trying to run any kind of a Java program, right? So the JVM, we have a JVM, and it compiles the code and it gives the output, right? So there is some kind of a memory allocations happens. So how quickly the memory allocations happens, how much less memory you are using from your CPU, and how much usage, what is the space complexity, time complexity. So in this picture, that comes entirely the data structures comes into the picture over there. So let's understand the memory allocation for the stack and the heap here. So let's go to the theoretical part, then I'll explain you with a specific diagrammatic statement. So the stack is mainly, the stack is something we have basically will have separate concept that we are going to learn. But let's understand the stack is some kind of a RAM. Imagine for every system there will be a RAM, right? So might be 8 GB RAM or 16 GB RAM. So whenever you are trying to run any kind of a specific program, so what happens? It loads the data. The program loads into your RAM. Basically, it's used for the memory allocations. Okay? So for which variables will store into which specific address, and how the static and global variables store. There is one specific code segment will be there. And so basically the stack, let's understand a little bit on stack. The stack is where a method is local variables are stored. So let's take an example. So side by side, let me open my notepad that's here. So imagine, let's take this specific example. Okay, so the memory allocation in this specific stack. So in this memory allocation, we have a majorly will be having this is, imagine, this is basically, this is going to be a RAM over here. Let's imagine this is your RAM over there. Okay, this is going to be your RAM. So inside your RAM, that can be, let's take an example, this is going to be your 8 GB RAM over here. So this is basically, in this RAM there will be a segment over there. So the first segment, it can be something called as code segment over here. So let's tell here this is going to be a code segment. And next we have a static and global variables we are going to store here. So let's imagine this is the block, so where we are going to store the static plus global variables over here, static plus global variables, where we are going to store it over there. So whenever, let's take an example, the right hand side we have one program. So that's fine. So there we have some programs like that has, we can calculate the area of a circle, area of a triangle, and area of a square. So you can see we have a circle area function, and we have a triangle area function, and we have a square area function. So if I try to call area of a circle, it's basically prints me the output like pi r square by applying a formula pi r square. So if I try to call a function that's a triangle, it's basically, again, it's prints. Again, if I try to find what is the square of a area of a square, it's basically returns me the output, that's the side into side over there. So let's take in this example and let's see how memory allocations happen. So right, so here, what is the global variable and static? We don't have right now, we don't initialize any variables here. So imagine if you have any kind of a local variable assigned. So let's take an example. So if you have something like int a is equals to 7 here. Okay, so in this case, what happens here, a value will, it is going to occupy a is equals to 7 here. So it's going to assign one address for this variable, that is a is equals to 7 side over here. So it basically assigns here a is equals to 7 here. So it basically assign one specific data into your RAM over here. So basically it is going to be your main function. So whenever you run the program, your public static void main function is going to run, right? So it's run the program and it loads that into your main function in your RAM over here. So here basically we have a circle area, triangle area, and a square area. So let's try to add the specifics. So let's write here as a circle area function runs. So it's going to allocate a memory for it. And we have something called as triangle. So we have a triangle area. So it is going to allocate the memory for it. And we have something called as a square area. So SQUA or square area. So it assigns the specific three function names over here. Okay, it has been allocating the specific stack over here. Okay, inside this RAM, it is basically allocating over here. So basically this we are going to call it as a stack. Then the RAM will be having and two things, that is a code segment, and will be having a stack, and will be having something called as a heap over here. So we are going to have a heap over here. Okay, so in this case we have a stack and the heap over here. Let's imagine now we have it has been allocated a memory for here. So basically we have called area of a circle, area of a triangle, area of a square here, right? So here let's try to see how it's going to be there. So basically whatever the data will be there in the stack, right? So whenever you run the program, that memory allocations happens into your RAM. So when you stop the program, the memory allocation gets freezed up. Basically it clears the memory once the specific program has been stopped. Okay, so basically whenever what happens, right, normally if we try to have here, we mainly will be having a variables plus constant over here. Okay, so basically after, let's take an example here. Whenever this function called circle of a area, it basically you allocate the memory for here, and whenever it's right for the triangle, it's going to allocate the memory for it. So here in this function, the square area, it is returning the value, right? It is basically returning the value. So once it's how that happens, right, it basically returns the value. So whenever we call a square area of a area of a square, let's take an example. We are giving side is equals to 3. So it will be like 3 star 3, 3 3s are 9. It will return the value 9. And what happens? It's free of this space over here. So what happens here? If I just tell here, it is going to freeze up this specific space over here. I can just mention here, that is free up the space over here. So it is just going to free up this space. Okay, it will be once the value is written, this specific memory, whatever the allocation address happened for it is going to just get free up over there. Okay, so this is how that things happen inside the specific stack over here. The same thing we have specifically said into our PPT, like whenever we are having in the linear stack, you can see the stack where the methods and local variables are stored. Each thread in Java application has its own stack. So I have shown you the how we are going to store the local variable and there over there. When a method is called, a new stack frame is created. Basically, I said, right, whenever there is any kind of a method or a function, basically it creates, there will be a new stack will get created for that method, and a variables and the specific parameter over there. Basically, in the stack frames, like it will be like a small and fixed size. So there will be a fixed size that will be allocated for a specific function, and that will get automatically deallocated. You can see they are automatically deallocated when the method is going to be written over here. That's what I said. If in this case, if we take this example, the square of area, if it is returning, it's written when it return the value 9, and whatever the I have shaded into the yellow color, it will get written and it will get free up the specific space over there. And the stack follows the last in first out, that is a LIFO structure, meaning like basically most recently called method is on to the top over there. So we'll understand in the depth the related with the stack. We have a LIFO over there, how we are going to apply the insert operation and how it's happens. So we'll understand that thing very differently. For right now, you understand stack is kind of a LIFO structure where whatever the last element will be added, that will be stored onto the top whatever the last element will be added, so that will get removed whenever you are freeing up the specific space here. So I mean to say, like in this case we have a 3 functions running, right? So you can see the last function is square area here. So square area is been added here. So if it's try to free up the memory, so whatever the top element will be there, that what is the last element, basically square area, that will get removed for the free up this space. Okay, so that is how the things happen into the stack now. So now let's understand how the heap is going to work, right? So like heap is basically when we create an object, basically when the heap is where the objects are get stored, right? So whenever we store an object, so there we heap is going to get called, and objects in Java are dynamically allocated onto the heap. So imagine if you try to create an object for a specific class using a new keyword, so it's automatically allocates into the heap and it's shared among all the threads into the Java application, basically. Okay, and it will be handled by our JVM, where how objects will allocated, how deallocated happens, that will be handled by our JVM machine, and JVM machine takes the help of the garbage collector to free up the space over there. Okay, so basically it's not like object on heap differently, they are not automatically deallocated basically when if it is no longer needed. Instead it will ask from the garbage collections, and based on that specific signals, it will free up this space over there. And let's compare to the stack, the heap takes the larger and the more flexible over there. Okay, so let's see, this is how the things happen here. So let's understand a little bit more on to it. Okay, so in this program, in this specific program, we have a 3 function here. So mainly what is the method, what we can say about the heap here. So it basically helps for the dynamic allocation, right? Dynamic allocation happens over inside your into the heap over here. So heap is basically takes 2 data here. It is going to take the request or EQEST request plus release here. So it basically takes the request and it's releases over here. So this is major 2 terminologies comes inside the heap. It takes the request and it's basically releases the program over here, right? So majorly when we are using for the objects, it is used when majorly for the objects, and majorly it is going to use whenever there is a lot of return statements over there. So imagine there is something like a function, let's take an example for the finding a factorial. Okay, so if I try to find a factorial where we have a recursion, so there we are going to apply the concept of recursion, right? So if you have a 3 factorial, if we take here 3 into 2 into 1, so for every function, imagine here the 3 times your function is getting called. 3 times the function will get called. Function will get called over here, right? So in this entire statement, there will be function will 3 times the function will get called. So imagine it will allocate a 3 space over here. It will allocate and it will again deallocate. So it will allocate and deallocate. Again it will allocate and it is going to be deallocated over here. So let's take how it is getting allocated here. So for the first finding a factorial of 3, it will call a function. It takes an input of 3 and it returns the value called as 3 here. So allocation is been completed. Again 2 it will allocate, again it will free up this space, 2 will return, again 1 will happen, 1 here happen. It takes the request and releases over here. transport, it takes the request and releases over here. In this, the operation is going to be very faster, and even the memory allocation is very larger here, and it takes the request and releases onto the part over there. Okay, so that's majorly happens in the heap over there. Okay, when you talk about the object, so if you have an object 1 and object 2, so basically it stores the object in this specific way, where we are going to allocate and deallocate the memory based on the garbage collector over here. Okay, so basically it is an activation stack, so which helps majorly we can call it as like that. So this is how the recursion works. So if I take it here, the formula you can know that is just n into n minus 1 factorial, it will be, right? So where n belongs to what is the input size here, right? Basically this is going to be a return statement in this way. So this is how the specific memory allocation in the stacks works. So in this session we saw how the stack works and how the heap works and the memory allocations happens over there. Okay, so this is all about into the day 1 session. So we have completed the session number 1, so where we have discussed about these terminologies. So thank you guys for participating, and it's going to be an amazing premium course for you. So where we are going to learn entire data structure concept with a coding state coding problems using Java. So I'll catch you with the next session. Take care. Bye bye. Hey guys, welcome to the session number 2 on data structures and algorithm using Java. So we are going to discuss asymptotic notations into this session. So first we are going to begin with the big O. Then we are going to discuss omega theta in upcoming sessions. So let's understand what is big O over here. So that is the first concept that comes into the asymptotic notation. So before that, we'll understand what is this meaning over there. So as I said, right, data structure is entirely about having about the what is the time complexity and what is its the specific space complexity, and how efficient the algorithm you have written, and how it is going to take the inputs and how it is going to give you the output. Let's take an example. If I try to sort a 5 numbers, it takes 5 seconds. Or imagine if I try to give a 500 inputs, like 500 numbers to sort it. So I want to find what is the algorithm performance, like how it is going to handle when the size of an input increases, how efficiently your algorithm returns the output, and how much time and how much space it is going to get consumed. So majorly, as I said, like when your specific program scales up, how it is going to take the size of an input and how it is going to take the usage of an algorithm. So it is the majorly things that comes in data structures, and these things, whenever we are going, whatever the things we are going to find, like space and the time complexities, this we are going to understand with the big O, omega and theta notations. So there can be 3 scenarios into any kind of a program you write. So it can be a worst, or it can be an average, or it can be a best over there. So these 3 specific jargon words we are going to use. Okay, this is the best case algorithm, or it can be worst, or it can be an average case. So it can be like we are in the programmatic, in the specific algorithmic way, like in asymptotic way, we are going to tell, okay, this is a big O of 1, or a big O of n, or big n log n, or it is going to be a log n, or n square, n cube, so on, like that, right? So let's understand the first thing, how the big O notation works here. So if we take an example in the big O, if we are going to call, basically it is a of order of, we can call it as what is the order of this algorithm, what is an order of this program. So big O notation describes majorly an upper bound. So in the big case, we are going to tell, okay, it is your upper bound, or a worst case behavior of an algorithm. Okay, so I will tell, okay, this is the worst case of the algorithm. Whenever we talk about the big O, it will be like, and we are going to majorly, it will be an upper bound, and it is a, we call it as a worst case behavior of an algorithm here. And majorly in this worst case as well, we'll differentiate into 3 categories, like it is a good, or average, or a not good one, like that. So it's in upper limit, right? We are going to understand, okay, when your algorithm, when your program scales up, so what is the runtime of your algorithm is basically when the input size increases. So formally, the definition of big O we call here as, if you ask anyone ask you what is a big O notation, you need to give them this specific third statement, like formally a function, if a function belongs to f of n, is said to be a big O of g of n if there exists a constant called like c and n naught initial state, such that where n is greater than or equals to n naught and function, and lesser than or equals to c is your constant, and g of n is going to be a one specific function over there. So you need to give that statement like which is there in the specific jargon way, like n is greater than or equals to n naught f of n lesser than or equals to c and star g of n, where your n naught, what is going to be an n naught is kind of a your first specific, where it can call as a saturation one, where f of n is going to take n, what is the size of your input, and c is basically your constant, and g of n can be another kind of a function over there. So in the simpler way, where we call runtime of an algorithm, basically g of n is basically sufficient for the large inputs over there. Okay. So basically, if your algorithm returns, if I tell this algorithm complexity is basically a big O of n square, it means that is a basically worst case time complexity grows gradually over the input size. That means how the inputs you are going to give it in the, if you give 10 input, it will take 10 seconds. If you give 20 input, it will take 20 seconds. And if you give 1000 input, it will take 1000 seconds. Like basically, based on your input size, your time complexity is also getting increased over there. So this basically comes into the big O over there. So let's understand with a very neat way. We're taking one good example for the big O over there. So I have a specific diagram over here. Let's take an example. We have a library. So we have a library where we are having a B12 books of library over here. I'm taking a very simple example here, right? So a 12 might be, it can be very larger kind of a books can be visually in the usually. If we talk about a library, there can, let's imagine we have a 1000, like 10,000, 1 lakh, 10 lakh of books into a library. Okay, we have a 10 lakhs of books into the library over here. So we have a B12, and I'll just tell here in the last that will be B 10 lakhs over here. So this is a 10,000, right? So it is a 10 lakhs books we are having into a library. So now there can be 3 scenarios here. So in this there can be three scenario. So there can, let's take one first to 2 scenarios. So we have something called as a constant time. So let's take it, there is a constant time, and let's take another scenario that is a linear time over here. Okay, so there can be 3 scenario. I want to find a book over here. So let's take one first example, that is a constant time. So let's imagine the constant time we are going to call as the big O of n, big O of 1 over here. So I'm telling big O of 1 over here. Okay, and for a linear time, I'm just going to call that is a big O of n over here. Okay, so and I'm going to tell another scenario that is a logarithmic time. Okay, so let's tell here as a logarithmic time. So for this, I'm just going to tell this is going to be big O of log n over here. Okay, big O of log n. So we have 3 scenarios to find a specific book. So I went to a library. So I wanted to access the B7 book. So I wanted to access the B7 book. So they imagine there is a specific librarian guard over here. So there will be a librarian. We call it as a librarian, right? So we imagine we have a librarian inside a specific library. So if I just go to the library, I'll tell him librarian, so I want a specific B7 book. So I want a specific B7 book, the name of a book. So librarian will be having a knowledge where which book will be where, and he will be a very thorough knowledge person, right? So that is why we are going to keep, so that I can access the book whichever I want in a very quickly way. So based on the librarian knowledge, so he knows. So if I tell him the B7, it will take, it may take 2 seconds. It may take 2 seconds because he knows, okay, I have here. So he will go exactly, he will give me, and he's going to give me the book over there, right? If I try to say him I wanted a B12 book, and he has a knowledge where the B12 book is there, he will go to the B12 block, and he will just he will go to a specific block wherever he is there, and it will be returning me the book over there. So here it is, he's taking a constant time. So no matter which book you are asking for him, he has a knowledge. So he is taking one constant time, and it is, the time is constant here. So the time is going to be a constant. So that is why it will be a constant time, and it is a big O of n. So what is the time complexity if I talk about here? So the scenario represents a big O of 1. So big O of 1 here, the time complexity will be the big O of n. So here we are going to call, okay, this is going to be your best over here. So I'm just going to tell this is going to be your best case here. So this is going to be a best case because he is taking a constant time, basically, which whatever the things I'm asking, it's taking a constant time to give me the output over there, right? So this is how the constant time is going to be there. So let's take another example now. So the next example comes for the linear time. So where we are having a big O of n. There can be, imagine there is a no librarian here. There is a no librarian to assist you. So you have to manually search through each shelf. So you need to go to each shelf, and you need to search one by one where is your where the specific book is there here, right? So in this case, what happened? The book increases linearly. So the time increases linearly with the number of books in library, because you have to check each book sequentially. This scenario represents the big O of 1 n time complexity here. So basically it takes the big O of n over here. So imagine I wanted to search for the B18 book here. So I am going to start from the self one. I'll just keep on going one by one. I'll be going. So until and unless I found B18, I'll be keep on going it here. So there can be a scenario you are searching for B9999. So you are searching for a B999 book, means it is basically the n size is basically 1 lakh, right? In a 1 lakh, we are searching for the 99,099 books. So the book which you are searching, that is stored into a location that is a B99,999 place over there. In this case, its time gradually increases based on your searching, right? So here it is the worst time complexity. So we can tell, okay, this is going to be your worst time complexity here. Worst time complexity. So for the searching the book over here, because it's the time increases linearly based on the input size over there. Okay, so that is going to be call it as a linear time over here. So the logarithmic time is also we are having, right? So in this case, let's imagine there is a one specific system. There is no specific librarian or nothing like that. There will be something kind of a computerized. So we have something. Let's take an example. So we have here like a computer here. So we have computerized system. So what you are going to do, you are just going to the computer, you are going to sit into the computer, and you are just going to just tell here and enter the book name. So you are going to enter it. So computer knows where it has been cooked. It will just give you the location. Okay, you will reach the specific location and find the book. Basically you are going to find the book which you want to read it over there, right? So this can be another scenario, right? That can be another scenario. So compared to this second algorithm, big O of n, this is little bit better, right? Just it is taking a minimal amount of time here, right? So basically we will enter a book. So whenever it is there, it can be very far or somewhere else. So it will just give it. So what imagine the library has computerized catalog system that allows you to search for the book in this system more efficiently, right? So basically whenever it's give it, so what you go, this approach basically significantly reduces the time takes to find a specific book, especially in the large libraries. Like if you have a large library where we have lots of books, so in this case it's specifically happen. So this is better than the big O of n. So we can just tell big O of 1 is better than, this is better than big O of n. Okay, and again big O of log n is better than big O of n over here. So this is the case that comes over here. Okay, so this is better and this is not good, and even this is also better and this is not good. So big O of n is going to be a little bit a worst case over there. So this is a scenario that comes into the picture when you are searching for the algorithm over there. Okay, so let's take let's solve this into a log with the algorithm. So imagine whenever we are trying to find for the, let's take the first example over here. Okay, so in this algorithm 1, so I'm just going to tell here as a 1 here. Okay, so imagine there is a k1 and there is a n0 plus k2 plus k3 plus k4. Let's take this example. Okay, so in this case, let's imagine what is the constant over here. So n0 is going to be the constant, basically a constant runtime. So basically the time is going to be take what is the first, what if you librarian knows, right? It's a very good complexity. It is a, let's take an example. This is the n0 over there. Okay, and let's k1 k2 k3 are the constants over here. Then let's imagine the k1 with the time that you are just walking and just taking the book, and k3 is about you're talking, like you're just k3 is when you can think like, okay, you're talking to a librarian person, and k4 is basically the time you took to take the book. So this all you can just treat it, this all is a constant over there. Okay, and n0 is going to be a time. So that if you take a k as a constant, so then n0 will remain. So basically we can just call it as a big O of 1 over there. Okay, n0 can be treated as n0 is equals to 1, takes some constant time. So that is going to be a big O of n over here. Okay, so it is going to be the constant here. And let's take an algorithm 2 here. So let's take a worst case algorithm. Let's take here you are just searching one by one over there. Okay, so you are just for finding a L, let's take an B1 Okay, you are just taking a b1 book, you are searching for the b2 and b3 and goes on till bn, you will be going it over there. Okay, so in this case what you are just going to take the constant, the book is going to be remain constant, and basically n divided by b. So basically the time of your algorithm goes based on your input size over there. So in this case you can just tell, okay, b dash plus b2 dash of n over here. Okay, so where L2, basically whatever the B2 is there, right? B2 is going to be your, like it can be like we are going to take a linear time, right? So it can going to be a linear time that takes for the specific algorithm over here. And n is going to be the, basically, and n is going to be the specific constant. So where you are going to find it. So whenever you are talking about this, if I just majorly similize to this program, so in here where the n is going to be a linear time, so based on your time, b is going to take, let's take as the linear time it will take, and b can be a constant if we take it as a constant as a b. So if let's tell b go of n over here, the n will remain over here. So n is basically a size of the input, and it's gradually increases based on the size of input. The time gradually increases if the based on the specific time of input over there. And let's majorly furtherize the, let's take it in this graphical representation over here. So this belongs to, let's take it here, this is going to be your time, okay, and this is going to be your size. So let's take this is your n, that basically describes the size over here. So t is going to be your time and n is going to be your size over here. So imagine if I try to search for a b1 book, so first I'll search b1 book and I'll be going to b2 and I'll be going to the b3 book, and keeps on going, I'll be going to the bn book over there. Okay, so basically big O of n describes this one. So whatever you're seeing, the line gradually increases, this is going to be your linear time. So imagine this line, so this time, whatever the line you're seeing under this right, that horizontal line, so this is going to be your constant time, this is going to be your constant time takes. So this takes your linear time. Okay, this is going to be a linear time. So imagine whatever the book you are searching, you have a knowledge on it. So basically you are going on, you will be having a knowledge where it is there, on spot you are going to find it. So this we can just call it as a big O of 1 over there. Okay, this is going to be the big O of n 1, and this is going to be the big O of n over there. So this can be the specific algorithmic way so to represent this specific equation over there. Okay, so in the more way, if you want to satisfy writing a specific algorithm for here. So let's say, imagine I wanted to write a specific what is the statement for it. So let's try to write this specific a better statement for the big O. Okay, big O, you can call it as a big O, or you can call big O like this. Okay, so in this function I can just say this specific a function f of n. This is a very important statement. Okay, a function f of n is set to be a function that can be a g of n function if and only if the function is going to, if and only if for all input whichever we are having, for all input whichever exists a specific pair of constant c, a pair of constant c, or can be constant c, right, and specific we can just call it as a constant n naught. The constant c is basically a extra thing that takes, and constant naught is the size of an input, such that so this is going to be very important. 0 is lesser than or equals to a function f of n, and lesser than or equals to function c of, that is a g of n, for all when n is greater than or equals to n naught. So this is the major definition for your big O. Okay, so that's how we have understood with this specific program over here. Okay, and if you want to satisfy with the imagine, so let's take an example for we have a specific a function, that is f of m function, can be, we have a formula that is n cube plus n plus 3 here. Okay, so let's take an n value, the n value, let's take it as a 3. So 3 3s are 9, 9 3s are 27. If I just tell here as a 3 cube, let's take it as a 3 square. So 3 square plus 3 plus 3. So 3 3s are 9, right, and plus 3 plus 3. So basically it is going to be your 15 over here. Okay, so let's take another example for the function. This is the function for f of n. Okay, let's take for a another one. Let's take an example of a g of n is equals to n cube here. Okay, so in this n cube, imagine we are giving a value of So let's tell there is a C is a constant. Okay, so there will be a C is a constant and there will be n cube. So the C value, I can just tell the constant value can be 2 and n cube can be like I'll just give it as 3 of 3 cube over here. Okay, so in this 3 cube, so I'll just take it as a 2 as a constant, 3 3s are 9, 9 3s are 27 over here. Okay, so basically it will gradually increase the input based on the size of an input. Okay, so that's how happens over here, right? So this is going to be your equation. You can have an equation like this, so you can understand, okay, based on the equation we can satisfied with this over there. Okay, so in this case, if I just ignore the value of the specific constant, like if we try to ignore the value of the value that is constant, if I ignore it, so 27 will be the, it can be a best case as well. If you try to remove the constant, it can be a best case. Okay, so if I try to answer, it will take the double time of it, right? If we take compound equation over here. Okay, this is going to be your specific scenario into this. So imagine I can just try to write another graph for it. I can just try to write another graph. So let's try to write in another graph over here. If we have a graph over here, so in this lower limit graph, I'm going to write it. So if I just take for this example, so there can be a specific graph going like this, and again it can be a graphical graph going like this. Okay, so this graph is basically always C of g of n will be an upper limit over there, and f of function will be the lower limit over here. Okay, such that the C of g of n is always, it will be greater than function f of n over there. Okay, so basically what I am trying to say here is, it is going to majorly it is going to be our upper limit over here. So for the worst time complexity, so always your C of g of n is going to be greater than the function f of n. That is what we have said here, right? You can see the C of g of n, always it will be greater than f of n over here. You can see the f of n is 15 if you try to validate, and here you can see it is giving you the 27 when there is a added by the constant over there. Okay, if you are not ignoring it, you can see it is always, it will be greater than your function f of n. That's what your specific graph is going to represent, and whatever the meeting point will be, that is a saturation, that can be a n naught over there, right? So this is all about the big O, and I hope you have understood what is big O and what is the linear time and a constant time, how we are going to differentiate. We have discussed with the algorithm here, okay, with an example. So into the next session, we are going to look how the big omega works and big theta works. Take care. Bye bye.
Hey guys, welcome to the session 2.2. So let's discuss the omega in this session and the theta notation, and let's see how the algorithm analysis is going to come into the picture. So we have seen in the previous section what is the asymptotic notation. As I said, it's used for the size complexity and the time complexity, and even we saw how the big O works, and now we are going to look onto the omega notation. So omega notation basically describes the lower bound or a best case behavior of an algorithm. So we saw big O is going to be an upper bound, so big omega is going to be a lower bound, and it is compared to the big O, the omega is the best case ever algorithm can be taken. Okay, it provides basically a lower limit, or you can say it as a lower bound, and here the growth of the algorithm runtime is based on the input size it increases. Okay, and even it is having a very lower limit, and it can be a best compared to the big O. That's it. Okay, and the function f of n is said to be a specific omega of g of n function if and only if basically the constant time n is greater than or equals to n naught function f of n and greater than or equals to c and star g of n. So it's similar to the big O, but here you can see it is basically the function whichever you are seeing, that is going to be a lower limit, and it is going to be a lower bound, and it takes the best case over there as compared to the specific big O. In terms majorly, the runtime of an algorithm is going to be in a constant multiple of some function g of n for sufficiently a large input. So in this case, what happens, even if you provide a very large input, right? So even in this case, the specific algorithm will be a lower bound itself, and it will be time complexity will be a minimal. Okay, and it's same thing if we talk about the theta notation. Theta notation is the provides the tight bond basically. It is a behavior of the both worst and the best cases. We can calculate the most worst case here, and it can calculate the best here as well. And here it is a combination of two, the combination of the big O and the combination of the big omega. It's been taken to be called as a theta notation. It is going to create one tight bond between both the functions. So you can tell this specific function f of n is said to be a theta notation of g of n if both big O of g of n and the specific omega of g of n comes into the picture over there.
Okay, and it's precisely all the not an just an upper limit or a lower limit. It can be both. It can be specific, provide the tight bond over there. If we talk about the algorithm time complexity of big O of n, and it means that the runtime grows linearly with the input size in the both best and worst cases over there, right? So you can get it in the big O of n is better and big O of n is more worst, right? So that's why we tell the specific runtime grows linearly with the input of the size. But in we call about the omega notation, what we say? In this case, basically the algorithm is a least constant of multiple time of a function g of n sufficiently for the large input. Even if there is very large input, the specific time complexity will be minimal over there as compared to the big O of n. That comes over there. Let's understand the algorithm analysis over here. Coming back to my specific one part. So here we are going to see, right? Okay, so here we are going to discuss about the first. Let's understand about the big theta, right? We have a big theta and big omega. So let's understand for the big omega over there. In this specific big omega. So if we talk about the algorithm, how it is going to be, the graph, how it is going to be there. So let me take the graph for this. So in the big omega, let's take an example. So there is a big O of n. So if I just tell here a big O of omega, so I'll write here as a omega here, okay? The function we decided, the 0 is lesser than or equals to function c of g of n constant and lesser than or equals to f of n over there. In the previously, f of n was at the middle and c of g of n at the last, right? Here in the only difference is this is going to be the function f of n is going to be greater than the c of g of n. That's it, okay? For all, the n is greater than or equals to n naught over there, right? If we take the limit over here, so let's take a graph. So it will be a graph that is going to be the f of n is going to be greater. And again, if we take it as a graph, that is going to be a same thing that is going to be here as a c of g of n. So in the previously you saw it was on the top and it was into the bottom for the big O, but here it is going to take the constant time. So wherever the bond is meeting, so that is going to be a n naught over here. So time taken such that the function f of n is greater than the c of g of n over there. Okay, this is going to be a formula for it. And here we are going to describe the lower limit. Previously we saw that is going to be for the upper limit and it is going to be a lower limit. So let's take an example that is can be n cube plus 1 can be there here. If the n value is going to be 1, so 1 plus 1, it is going to be a 1 over here. It is going to be a lower limit over there. So where if I just tell here in the formula, if I evaluate function c of n, so basically this is going to be a c of g of n is a function. The n cube plus 1 is always it will be lesser than or equals to function f of n over there. Okay, so that is how it is going to be there. Okay, so this can be the formula where n belongs to 1 over there. Okay, so if I tell here 0 is lesser than or equals to 1 and it is going to be lesser than or equals to n cube plus 1. So in this case we are going to exclude this one and constant. So when we exclude the specific input, so basically we are going to take the constant times over there. Okay, that is going to be there. So this is going to be a formula. This is going to be for the big omega. And the same way, let's go to the big theta of it. The big theta, when you talk about the big theta over there, in this case the function it is going to be 0 is lesser than or equals to function f of n and lesser than or equals to c1 of g of n. So what is this? This is going to be a big O, right? This is basically a, we can call it as a upper limit. And again, I'm going to take another 0 is lesser than or equals to c2 is a constant g of n and lesser than or equals to function f of n. This is going to the latest one which we saw, that is a lower limit. The lower limit in the sense this is a big O, right? And this is going to be a big omega. Mechanical, this is a big omega. So when a combination of 2 is going to come into the picture, that is I'm going to tell c2 of function g of n is lesser than or equals to function f of n and lesser than or equals to c1 of g of n over here for all n is greater than or equals to n naught. So this is going to be the main formula for it. So this is going to be the main formula. Okay, this is going to be the main formula for the big theta. Okay, c2 of g of n is lesser than or equals to function f of n and lesser than or equals to c1 of g of n over here. So when we try to write the specific graph for it, there can be a one thing, and again I'm just going to tell again there can be another one, and if I just try to tell here, there can be a 3 graphs is going to be there. The first one I can just tell this is a c of g of n that will be greater than, and this is basically a big O. Okay, this I'm going to tell is going to be a big O. And the second one which we are seeing, that is going to be a function f of n, that can we are going to call it as theta, and again the c2 of p of n, it is going to be an omega over here, so this can be an omega. Okay, so this is how the function is going to be there. This is going to be a graph for the big theta over here. Okay, the analysis of the big theta of a function over here. So let's try to write the order of the function. Okay, it's going to be a very good, so that is the order of a function. So order of the function over here. In order of a function, I can just tell here, one is better than log n. Okay, and log n is better than n, and n is better than n log n, and this is better than n squared, this is better than n cube, and this is better than 2 power n, and it is better than n power n over here. So in this case, if I talk about the complexities of here, so whatever you are seeing, this can be a best case. Whatever you are seeing, this can be the best case. And from here to here, you can just tell here it can be a common runtime. So based on the runtime of a thing, that can be a common runtime. Okay, this can be a common runtime. Okay, and if you talk about this one, the last three, the 2 power n power n, like even you can include the n cube. Okay, it is going to be the worst case of here. Okay, the overall output come of this entire thing, the session 2 and session 2.2, is to understand which is the best and which is the average and which is the worst over there. So you can treat this as an average. Okay, this can be an average as compared to this. The best one will be this one, a1 n log n or a log n or n over there. Okay, so this is going to be the specific big data over there. Okay, so thank you guys. So I'll catch you in the next session, so where we are going to discuss the best and the worst case expected case with an example. Take care. Bye bye.
Hey guys, welcome to the session number 3. So let's discuss the best case, worst case, average case time complexity into this session. So what is the best case? As we have discussed, the best case is basically a specific algorithm which is going to take a minimum amount of time to run a specific program in a given amount of a input, right? For a given input, when it provides the most favorable input, I can say. So imagine if I tell I giving a 100 inputs, it takes 10 seconds. In the same way, if I try to give 200 inputs, it takes 12 seconds. And in the same way, if I try to give a 1000 inputs, it takes 20 seconds to run. And it is basically a best case algorithm, basically, right? And it describes when its algorithm perform its peak efficiency, right? So in this best case, I can say, if you talk about, if you denoted using a big O of notation, generally it is going to be a upper bound, right? And if we talk about the big omega, it is going to be a lower bound of an algorithm performance. So we need to tell, okay, what is this specific best case time complexity? So how we are going to tell here? So in interviews, they are going to ask you what is the best case time complexity for a given problem. What is the best case time complexity for the solution which you have given for the interviewer? So you need to tell, okay, it is a big O of 1, or it can be a big O of n square, big O of n cube, or big O of n, or n log n. Like this, you need to give him an answer. So if you want to analyze this kind of an specific what is the best case time complexity, you need to understand, okay, if the specific program increases gradually, time increases based on the size of an input, you can tell it is a big O of n. Okay, and if takes a time greater double multiple times of the given time, then it can be n square or triple times n cube, like that. And it is the whatever the program is there, it takes some kind of a constant time, so you can tell as a big O of 1, like that, right? So let's take one example, like a sorting algorithm, to understand this big O of n. Okay, so for already a sorted input, or it can be unsorted input. So let's take the two example as well into the same session, and then we'll discuss. Okay, and worst time complexity, as I said, right, the worst case is the opposite of the best. It takes the maximum amount of time to run an algorithm or to solve a given problem statement. So for an given input, it can be one time is good, and for a large input, it can be unfavorable for our side, right? And at the same time, the worst time complexity can be, as I said, it can be start from big O of n square, n cube, and goes on to n power n. Okay, and it's basically a poor program which we have to run, and it is not going to work for your large kind of an inputs. It takes a very large time, and it's a demerit for the specific programmer, right? So this can be your worst case time complexity. There can be an average case time complexity, so where we can use the log n, right?
So 0 big O of n log n can be an average time complexity. That's basically depend upon a very few scenarios for writing a program. So if there is a very complex problem, if you are solving with a constant time of n log n, and that can be a best case you can suitable. So this can be an average case, as you know, right? So that's we can denote using a big O of log n, you can say it, right? N log n can be a best than big O of n. So this is the average time complexity. We are going to prove this with an example right now. So let's come back to my one pad over there. So here I have given I've created something here with the like this, right? So let best case and worst case. So let's take one example here. Okay, so let's take an example in this. So let's take an example here. I'm going to give some kind of a values. So let's create some values which is been sorted. Okay, so let's tell here as a 2 3 5 9 12 and 15 over there. Okay, so we have a sorted array here. So we have something a sorted array here. In this case, let's try to imagine I wanted to find the array of a size here. So I wanted to just see what is the best case and what is the best size and what is the average size for this specific comparison. So let's take an array. We have a A1 array. So let's I'll denote this specific array here as a A1 over here. Okay. So in this case, I wanted to find what is the best case and the average case over here. After that, and we know that is if we talk about the best case, we can just note it of I'll just tell big O of n is going to be the best. And if we talk about the worst case here, so this is going to be the big O of n, right? So this we know. So in this case, array size we are having, and I need to just find out what is the specific case of an algorithm for it. Okay, so in this case, what I'm going to do, let's take a best case and a worst case in this example. So let's understand first theoretically, then we're going to write the algorithm for it. So in this case, imagine I wanted to find a element. I wanted to search an element called as 9 here. I want to search an element. Okay, so if we try to give a worst case here, so if I just try to give a algorithm, so imagine I'm just going to make use of one algorithm like I wanted to use the linear search here. So first I'll go one by one. So I'll just start with here. So I'll just start from here, okay, and I'll end it over here. So I'm just going to make use of the linear search here. Let's take an example of a linear search. So in the linear search, I'm going to search for the search node 2 here, and I'll just search for 3, and I'll search for 5, then I'm search for 9. So it is taking the 4 iteration. Takes the 4 iteration, right? It takes the 4 iteration. Imagine if my search was 15 here. So it would have taken how many iteration? 1, 2, 3, 4, 5, 6 iteration. It would have taken the 6 iteration to give me an input. So here the worst case can be what? The worst case for this specific thing can be big O of n. So basically, I need to traverse for the n time. I need to traverse for the n time minimum. So this can be the worst. This can be the worst case for me. So and or else if I get the element in the 9th iteration, basically for the 9 we have, right? In the 9 I'm trying to say I'm getting after some 4 iteration. Or the minimum, the average case can be what? The log n. It can be the log n can be the average case, right? The log n can be the average case over there. So that can be the scenario. And what can be the best for this? If I go into the linear search, I can get, if I search for an element 2, an element, I can just search for the element 2, I can get it into the big O of n, because basically I'm getting in the first iteration. But we don't know, right, whether how many iteration it's going to take. It can be, so we can just overall we can tell it is going to be the big O of n over, right? So if you are going with the linear search. So there's another example. Let's take an example. So let's take it a binary search. And we are going to denote start is going to be this, end is going to be this, and I'm going to have a mid element. So if I take an indexing, that is a 0, 1, 2, 3, 4, and 5. So I'm going to take the mid element as a 0. So that is I'm going to mark it the element 3 as a mid here. So I'm just going to apply one thing here. So there is a something, I'm just going to find the mid element by applying a formula here. So I'm just going to tell mid is equals to start index plus end index divided by 2 over here. So what is the start index? 0 plus end index is going to be here as a 5, right? So 0 plus 5 is divided by 2. I can just tell as a 2.5. I can treat this as a 3 here. I can just treat it this as a 3 here. So imagine my search is equals to 9 here, right? If my search is equals to 9, I'm just going to check whether my search, if the search is equals to mid value. If the search is equals to mid value, then the element is found, right? So it is taking a minimal amount of time. And at the same time, if I try to again, if I just try to run another thing, like my search is equals to 5 here. Okay, if my search is equals to 5, again I am going to take the mid element. So I'm just going to check what is the 9 index of a 3. So if I take an index of a 3, the indexing position of a tree, you can see here in the indexing position of a 3 is the value here is a 9, right? So let's going to tell, okay, 9 value is greater than the value which I am searching for the 5. If it is greater than, I'm just going to search for the left side. I'm just going to look onto the left side. Okay, if the same way, if the search value was 15, okay, in this case the 9 value is lesser than 15, so I'm just going to look onto the right side of the boxes. So I mean to say, whenever we are doing this, I'm just going to validate it over here. So I'm just going to validate it in this way. So like I'm just going to tell, I'll just tell this is going to be your mid value. The mid value was, what is the mid value? So the mid value was here 9, right? I'm just going to tell, okay, the mid value was 9, and the left hand side we had a value 2, 3, 5. So I'm just going to tell, okay, 2, 3 and a 5, and the last box I'm just going to differentiate with the 12 and 15 we had value. I'm just going to tell it is going to be a 12 and a 15. So basically, if the search was 5, right? If the search was 5, I'm just going to match mid element is 9 is greater than 5. So I'm just going to look into the left box. If this was the condition, I was searching for a 15th element, then this is what I was looking for the right box over there, right? So in this case, again, I was applying the same formula. I was saying what is the start and what is the end, and here what is the start, what is the end, and what is the mid value. So this is basically, we are going to, whatever I have explained, that is the for the binary search. Again, we are going to look onto this same thing with the very good example. Just I have given an example. Okay, this can be there. If I take a linear search, I need to go one by one, one by one. If I go with the binary search, I can take this approach, and taking this formula, I can make it this stuff like that. Okay. So now the major agenda was to find what is the best case for it, right? What is the best case for it? Write an example for it. So what can be an average case, and what can be an average case here? Okay. So let's write an example. So if I take in an example, so if I just take an average case for it, if I want to find what is can be an average case, I'm just going to tell here as a sum of all possible runtimes, sum of all possible runtime divided by total number of possibilities. What is the total number of possibilities? Okay, possibilities like this. In this case, if I just try to tell, let's take k is your runtime, and there is a 2k plus 3k, and it goes on till nk plus n over there. Okay, and the n plus 1, the total number of possibilities can be n plus 1. If I have a 10 element, I can go up to, I can search for 11 element, that can be n plus 1. Okay, the element which is not there. So one element which is not there, even we need to have another, right? There can be another possibilities here. If the specifically search is equals to 33, in 33 I need to 1 2 3 4 5 6 iteration is already done. When 7th iteration I go, basically it is not there. It can be called for the basically the element which is not present. So that's why I'm taking one extra n plus 1 here. Okay, and here the k can be a constant, 1 plus 2 plus 3 and goes on in. So I'm just taking k as a constant and I'm going to have a n plus 1 here. So if I just take it to the formula, so it can be a n square plus 2n plus n over here, and it can going to be an n plus 1 if I just further evaluate to the formula. So here in this specific case, here it can be, there will be n, right? N into n square, 2n and 3n, and this goes on till n over there, and n plus 1 will be remain there. So if I just take again k is a constant, if I further evaluate to this equation, it will be n plus 1, and that is a n plus 1. So here it is going to be a deletion for this. Once I delete this, so basically I'll be getting a k of n. So I can just tell here as a big O of n can be the average over. Okay, so average case for this specific program. Okay, so big O of n can be an average case for this program. The worst case can be a program. And if I just talk about the average, basically it's giving an average case in the if I evaluate to this specific equation. So by using a binary search, we can just make it a log n. So I can, if I just use this linear search, if I just use the linear search, the linear search average case can be big O of n basically in the linear search. In the same way, if I go to this approach, if I just go to this specific approach, imagine if this is the approach, it can be a log n. It can be a log for me. It can be the log n. Imagine there is a 4 inputs. The 4 inputs we are having, 4 inputs we are having. The best possibilities, if we go with the binary search, I can evaluate to 2 because log of 4 can be approximately. So imagine we have a 8 elements, it can be go to the up to, we can just reduce entirely half of it. Okay, the average of half of it. Okay, if I have a log or log 12, it can go to the 6 over here, basically a half of it. Okay, when we are using the binary search kinds of concept. Okay, if we take a normally a linear search, then it is going to be the case, the average case can be, minimum average case will be the big O of n. Okay, and it can be treated as little bit it can be treated as the worst, can be treated as a worst, and this can be treated as best over there as compared to. Okay, so this is how the specific space complexity and time complexity happens. So using the activation frames, we can do it more better. So I hope you got the idea how the specific best case and worst case can be evaluated. Okay, so in the next section we'll start with the coding part as well, we'll understand with the coding way. So thank you guys, take care, bye bye.
Hey guys, welcome to the session number 4. So let's discuss the design principle of data structures and algorithm. So what all the design principles are going to be there into it over here. So the first here is we need to choose the right data structure for the specific task. Suppose if I give any example, like if I give any question to you to solve it. So if you are trying, there can be n number of ways to solve this specific problem for a given requirement. So you need to choose the specific right data structure. So which taking the consideration the factor like if you apply the insertion, deletion, searching, or any kind of another operations. So what is the memory usage it is going to take, and what is the time complexity it is going to take, and what is the space complexity. Keeping these two things into the mind, you need to choose the specific right data structures for the specific task. So if I give a specific task to find a specific search operation, so it's like we have a lot of search operation, like we have linear search, we have a bubble search, we have sorry bubble binary search, we are having it. So in based of these two things, so which is correct one, so you need to choose it. Okay, so which gives the most a, a beneficial for your space complexity and a time complexity thing, we need to choose that specific data structure. Then next, we have an abstraction and an encapsulation. So in the abstraction data structures, basically, when we talk about the abstraction and encapsulation, it's basically hiding the internal properties of a specific function, right? The abstraction mean, and in the encapsulation mean, basically implementing the details and which is hiding the specific complexity to it here. So we need to not showcase the entire information to the user and what all the specific attributes are there which needs to be hidden, that we need to well define, we need to make it a well defined structure for that. Efficiency and performance, as you know, the program which you are going to write, that should, the performance wise, it should be a good one, and overall the consideration is to take the efficient algorithm which takes the minimum time and a minimum space over here. So then we have another design principle like memory management. So whenever you are choosing any data structure, we need to make sure that the specific allocations of any variables or functions which we are using, as I have shown you the memory management into the stack and the heap, right? So we need to make sure we are using a correct way for storing the variables, static global variables, the code segment and stack and the heap. We need to make it properly over there. And next is of a use and understandability. So whenever we are using any kind of a code, whatever the data structure we are implementing, that the code should be very neat and clean, and which the users, if some users is your code, he should be able to understand, yeah, this is what they have implemented, this is the specific data structures they have used to solve a specific problem, and the naming convention should be a proper one. Then the modularity and reusability. So basically when we talk about the data structures here, we, if we talk about the code once, think twice, code once, we have some comment, right? So based the thing you can apply over here. So whatever the code you are going to write, that can be reused. Okay, so whatever the code base is there, right, in your project, so make sure that few of the code can be reusable, or rather than writing a multiple functions, we need to write a such a logic that we can able to reuse the code over that. And handling the errors and the scalability. So basically whenever you are writing any piece of code, the error should be handled very neatly, and your program should not get terminated. If there is an error, it should show you the error, this is the error is going to happen, exceptions we need to apply whatever that. And the scalability, as I said, the scalability in the sense your algorithm whichever you are writing it, that should be that should be working fine for the n number of inputs. If the input size increases, even it should work properly. Okay, so these are the design principles comes into the picture.
So thank you guys. From the next session, we are going to see the Java point of view. We are going to start with the concepts of data structures, and we are going to learn one by one each components. We are going to start from the arrays, and before that we are going to install some kind of a modules of a Java JDK toolkit and Eclipse we are going to use. And I'll take you with the next session. Take care. Bye bye. Hey guys, welcome to the session number 5. So let's install the Java JDK and Eclipse software for writing a code. So let's begin with the installation part over there. So coming back to my Chrome, so I'm going to install first called as Java JDK download. Okay, so let's install the latest Java JDK. So we need to go to this website, Java Downloads Oracle. So I know you guys will be knowing Java, so it is a pre-requirement for this course, right? So you should know the basics of Java, how it's work, right? So here we can see I can go to the Windows I'm using. So based on your operating system, you can install it. So I'm going to install this x64-bit installer. So it's getting downloaded. It is of around 164 MB over there. Okay, so it is getting downloaded. And once it is done, so I want to install something called as Eclipse download for Windows 10 or whatever it is. Okay, so you can just go to the Eclipse foundations. This is the website, so where we can download the Eclipse. So you can see it's telling install your favorite desktop IDE package. So x64-bit for this one. Okay, I guess so there is another was link, right? So we can, I think it is a good one, so we can install directly here, or else we have another Eclipse IDE.org. So if I just go to this official website of Eclipse, so here also we are having download 24 into 3 over there. Okay, it's a leading platform. Okay, that's fine. I'm just going to click on to the download over there. So once I click on to the download, it is taking me to this page, Eclipse installer. So here we can download the specific packages. You can see if based on your requirement, you can download over here. So if I wanted to install your favorite desktop IDE package, so I guess the latest one is going to be here. So these are all other builds. So you can download it based on your requirement. So if I just scroll a little bit down, this is the template which I have been shown. So I'm going to do something like I'm just going to click on to this download. Okay, so the whichever it is going to take a default one. So we are going to download that specific thing. Okay, so I guess it is started. All downloads are provided under the Eclipse Foundation. I am going to click again download here. So it started downloading probably. So I'm going to just allow here. So once I allow, it should start downloading it. You can see it is getting downloaded over there. Okay, so you can see the JDK 24. It has been downloaded. I'm just going to click onto the double click onto it. So once I double click onto it, it is asking me the specific allow the specific app to be used. I'm going to click on to the S here. So once I click on to the S, it is going to install it. Okay, so it is asking me for the welcome installation. I'm going to click on to the next everything. I'm just going to keep as the default. I'm not going to change any kind of settings. I'm just going to keep all the default setting. I'm just going to click on to the next button over there. So once it is done, this is in progress. It will get completed. So once it is completed, we will be installing the Java development toolkit for the building the specific Java program, this specific JVM, track this specific JDK, and it runs the program, right? So that's why we are using this one. Okay, so the Eclipse was is it's in progress, so it is getting downloaded. So once it downloaded, we'll install that as well. So yeah guys, so it has been downloaded. So I'm just going to click on to here. So I'm going to double click on to this Eclipse. So you can see it is asking me for the Win application over here. So it is asking me, okay, to buy this, right? So let's do one thing. I'm just going to open this from the download. So this is our file, right? So I'm just going to cut from here. I'll just create one new folder into my E drive or somewhere else. I'll just create the folder name called as Eclipse. So here I'm just going to paste that specific file. I'm just going to right click and extract here. It is going to extract all the specific things of the Eclipse. So once it is done, we are just going to install that specific Eclipse into our system. Okay, you can see it has been done. So now I'm going to just click on to this Eclipse folder here. So the Eclipse will be just have an Eclipse over here, right? So I can just simply click on to this Eclipse here. So once I click on to the Eclipse, it is going to get launched here. Okay, this is where we can install this Eclipse class. So I've kept it into my F drive. So you can, if you want, you can keep it into your C drive. So wherever you feel good, you can use this specific scenario over there. Okay, so you can see it is asking me I'm using C drive user Eclipse workspace. Okay, the workspace, it is creating the into the C drive itself. So you can, wherever you want, you can just extract it. I'm just going to click onto the launch here. Okay, so once I click onto the launch, so you can see the Eclipse is going to get launched into your system. So you can see here it has been giving me the works with this the specific Eclipse template. So in the Eclipse template, so if I just come back to the Eclipse template, it's asking me you can just create a hello world application or create a new Java project. So you can just create the project. So I'm just going to click on to the create a new Java project here. So once I click on to the create new project, so it is asking me the project name. I'm just going to mention here as a GUVI DSA Java. Okay. So I'm just going to keep this as a username, and all the things I'll just keep it as a 4. You can see it is asking, it is just selecting the JS17, use an existing environment for the JRE. It is taking this, and it is asking me some kind of a module name. So I'm just going to keep some module name as something like, I'll just give it here as a GUVI is your module name. I'm just going to click on to the next. Okay, so it has been created. So I'm just going to click on to the finish over there. Okay, so once it has been finished, you can see this has been created. The Java virtual, this can be seen over here. So now I'm just going to right click over here. I'm going to click onto the new. I'm just going to create one package here. The package name, I'm just going to keep it as GUVI DSA. Okay, and I'm just going to click onto the finish over there. You can see this has been created the package over there. So now I'm just going to click on to one new class, that is Java class. So in this class name, I'm just going to keep it as a TEST test over there. Okay, I'm going to create the public static void main, and I'm just going to click on to the finish over there. So once I just finish this, you can see it has been created. So let's try to see whether this is working or not. I will just tell syso syso. So system.out.println system.out.println. Okay, so here I'm just going to print something called as a hello world over there. Okay, let's save this, and let's try to print whether this is working or not. Let me give it double quotes. Okay, so once I save this, if I just try to execute the program, so this I'll be getting as a hello world. Okay, so our Java setup we have been completed. So the Java setup we have completed. So the next session we are going to set up how we can apply the zoom out or zoom in for this, and along with that I wanted to remove this kind of things. I don't need this one. I want an entirely completely it is done. Okay, so it has been done, right? So the next session we are going to look onto the concepts of array, and we'll begin with the first DSA component of data structures, that's Java arrays. We are going to look depth into that. Take care. Bye bye.
Hey guys, welcome to the linear data structure session 5.1. So let's see the first components of data structures, that is array here. So what is array here? So array is basically a specific Java fundamental data structure concept. So where we are going to store the data into it, and we are going to store the elements of same data types here. So that is what array is been there. So in different programming language, it acts differently. In Python, it acts to store the elements with the different data types as well. But in Java particularly, we need to store the same kind of data types. Here in the Java, we are going to see how we are going to declare the specific array. So array declaration is going to be like, if you give the int of my array of a new int of 5, it creates an integer array of size 5 here. Okay, so basically it creates the integer array of 5, and the 5 of the length, where we can store 5 elements over here into the my array. So in the second step, if we see here, we are going to create and initialize an array here. So we are creating the array, initialization is also been done, declaration is also been done over there. So into the top of this, we have again we have declared and initialized the array to 5, but here we have initialized the array with 5 elements over here. Into the above, we have just declared the what is the size it has to be there. So coming back to the array properties here, the array is a collection of similar data types of data having contiguous memory locations here. So in array, we are going to store the element into the contiguous memory location. So in arrays properties, like it always start from 0, that is the first element will be stored at the index 0th position when we try to insert it, and the second element goes to the first index, second index, third index, and so on. The elements is going to be stored here. The size of array cannot be increased at the runtime, right? So imagine if we try to give an int of 5, we have specifically said you can store up to 5 elements, then therefore we cannot
store the fixed size of an element. Once we have created a fixed size of element, we can store only those many elements into the array here. So in the runtime, we cannot increase it over there. Okay, so you can see here, this is the declaration int of marks. It's a declaration. When I tell here give the memory allocation, here we have not declared any kind of what should be the size of it here. But when you tell we need to do the memory allocation here. So we are telling, okay, the marks is equals to new int of 5. That means we are storing the we are giving us 5 elements data to be stored inside the mask. Okay, and line number last, you can see here int marks is equals to new int of 5. That means we are doing the declaration plus memory allocation into the same line here. Okay, then along with that, here you can see here also we have done declaration plus initialization we have done. So here we have done only memory allocation. In the last line, you can see here the initialization also we have done. We have added the elements over here. That means in the marks we can store 100, 70, 80, 71 and 98. So this is the declaration plus initialization. Okay, so when we give int marks of 100, 70, 80, 71 and 98, then this is once we have declared an initialize. We cannot basically we can change the indexing, but we cannot add the element extra over here. So due to the array properties, okay, we cannot increase at the runtime. That's we know. So coming back to an example of an array. So here if we take an example, the 10th element will be always be at the 0th index, and 20 will be at 1, 30 will be at the 20, 40 will be at 30, 50 will be at 40 indexing position over there. So if I want to access an element number 30, so it is present at the indexing position 2. So we can just tell here the array name. What is the variable name? The variable name is my array of 2 is equals to, if I just try to print my array of 2, it is going to give me the output as 30 over there. Okay, so here the things is going to be coming over there. So let's look with an example. So coming back to my Eclipse over here. So I have created, we know how to do this, right? So what I'll do here is I'm just going to create one class file. So I'm going to create a new, I'm just going to create a class. So I'm just going to tell here as a arrays data. Okay, something I'm going to tell arrays data. So inside this, I'm going to tell here as a public static void main. So I'm just going to finish it over there. So you can see it is going to create a array class for me. So once it creates array class for me, we can just see the initialization of the array here. So I'm just going to import the package. So I'm going to tell here import java.util. I'm going to import all the packages util.star over there. Okay, so once I import, let's try to initialize the array here. So let's try to initialize int of numbers over here. So int of numbers. So I'm going to tell here as a new int of 10 over here. So I'm initializing the 10 specific element over there. So if I just try to tell here as a syso system.out.println, that means I wanted to see what is the length of an array now. So if I just try to say here as a numbers.length length. So if I try to execute the program, so you can see it is going to give me the output as 10. Basically, we have created the size of a numbers that can be stored up to 10 values over there. Okay, so now let's try to run a loop and let's try to save the values inside it. Okay, so let's try to run the loop here. So I'm going to tell here as a for, I'm just going to tell int I is equals to 0. Then I'm going to tell I value should be lesser than 10. Then I'm just going to increment the value here. Okay, so I'm going to just tell I plus plus. I'm going to tell here as a I plus plus here. So then I wanted to initialize the values of it. Basically, I'm going to tell the numbers which we are having, right? So the numbers take the indexing position of value I. So first it is going to pass the 0 here. So for that specific value, I want to store some values here. So I'm going to tell here I. So whatever the current value will be there for that specific value, I just wanted to add some element, like let's add some 10 value extra. Okay, so I'll just tell I plus 10. Basically, it will be 0 plus 10. At the 0th indexing position, 10 will get stored. So then I value when it's become 1, 1 plus 10, 11 will get stored at the indexing position 2. So indexing position 1, 11 will get stored. So on it goes up to, it stores all the 10 numbers with the help of this. Basically, it stores from 10, 11, 12, 13, 14, 15. In that way, it is going to store it over there. Okay, so once it gets stored, so let's try to print again the specific loop. By using a loop, let's try to print what is the data we are having it here. Okay, so from that, I'm just going to copy again loop, for loop. I'm just going to paste again. So I'm going to tell I should be text from 0. So now I am just want to print the what is the syso number stored over here. So I'm just going to tell from the specific numbers. Okay, I wanted to access the indexing position from the I. Then I wanted to just print it. Here I'm just storing the values. Here I'm just printing it over there. So once I execute this program, so I can able to see the value output I can able to see here. You can see here I was able to see The first 10 I am printing, this is the length here. Basically it is storing the length here, and after the length you can see I can able to see the 10 11 numbers which has been stored inside the array over there. So this is how the specific loop we can run and we can get the specific values. So if I just show you the declaration again, so I'm just going to tell here from the specific numbers I wanted to store at the indexing position 3, I wanted to store something called as 300. If I just tell here in the numbers of 3, I want to store it 300. If I just try to print the numbers of 3 here, so let me try to print the program. So you will be able to see, you can see 300 has been stored over there. So if I try to add another number, let's try to add one extra number. I'm just going to tell in the numbers of indexing position 11, I wanted to store some value 400 over there. If I try to do this specific scenario, I'll be getting an error. Basically, it gives the error like index 11 out of range over here. It shows me index 11 out of range. Basically, your number can store up to only 10 elements. So it cannot be stored up to over there. So that is what the error we are getting it over there. Okay, so this is how we can store the numbers into the array and we can able to print the elements over there. Okay, so let's say another example over there. So let's take another example which we saw. Let me comment out the print statements systems here. So let's try to have another statement. So let's try to tell here as I wanted to store the int. So I'm going to store the num here. So the number I'm just going to initialize and declare at once. I'm going to tell 10 comma 20 comma 30 comma 40 comma 50 over there. So we are having these many elements over there. Okay, so now if I just try to print the elements, so I'm going to tell for I. So I'm going to tell here as a for specific int x value is equals to 0. Then I'm just going to tell here as a x value should be lesser than num dot length length and x plus plus. So I'm going to tell x plus plus. So here I'm just going to tell syso. So if I just try to print the elements over here, so I'm just going to tell from the number I wanted to iterate the x indexing position. Basically x value will be 0, then it keeps on going. It is 0 1 2 3 4. Okay, so the length is 5 here, so it will be 5 it will be there. When it goes to the 4 is lesser than 5, that's thread, it will print. When 5 value x value becomes 5, when it is incremented, at that case it won't print. Okay, because its condition will get failed, this loop is going to get evacuated. So if I execute, you can able to see, I can able to see the output 10 20 30 40 50 for this specific output. Okay, so this is about the little bit on array over there. So we know over there. So even we can print the data using for each loop as well, you know. Let me show you that as well. So if I wanted to use this specific for each loop, I'm just going to use the for. So I'm going to tell I wanted to iterate the element from the int I. Okay, where from this specific number. So from the numbers I wanted to iterate the value I. If I just tell here syso, if I just try to simply print the value of I, so if I execute the statement, so you can able to see I can get the data element and I can print it in using the for each loop over here. Okay, so the for each loop also we can use it over there. So this is how we can use it, the specific for each loop. Okay, so if you want to print the specific systems into the reverse manner, let's try to print the data into the reverse manner. Okay, so for printing a reverse manner, so let me take here the another let me comment out this code. So if I just try to add the code for this one. Okay, so this is used for printing the using the for loop in reverse manner basically. So let me try to print the numbers here. So if I have a numbers, I'm just going to tell for int is equals to from the specific length minus 1. What happens here? I value will be initialized to the last index element. That means what is the length here? 1 2 3 4 5. 5 is your length of the number, right? So it will be like 5 minus 1 will be 4. So 4 means it is going to point to the element number 50 because it lies at the indexing position 4 here, right? So this is the initialization happened, and condition it is going to check it should be greater than equal to. It can go till up to the 0th indexing position, that is a 0th means 10 here, and we need to decrement it. Okay, so if I try to print the specific num of I, so if I execute it, so you can see now it will be able to print the loop using the reverse order 50 40 30 20 and 10. So it is printing the elements into the reverse order over there. Okay, so this is all about the arrays. So into the next session we are going to look on to the array list and we are going to see the array dequeue. So over why we are going to use that array list and array dequeue when we have array restore here. So there are one demerit here, we cannot increase the specific what is the size at the runtime. So this is the one of the major demerit. To overcome this, we have a array list that comes from the collection. So that we are going to look into the next session. Take care. Bye bye. Hey guys, welcome to session number 5.2 linear data structures using Java for the array list and array DQ here. So we saw in the previous session about the arrays. So now we are going to learn about the array list and the array DQ that's come from the Java collections here. So basically array list is a resizable array implementation of list interface in Java. It means we can reassign the specific size of the array here. Use the help of the array list. That's an interface list in Java over here. So it dynamically resizes itself. So when you try to add an element, it dynamically resizes itself when elements are added or removed. Okay. So when you can easily remove the element from here, you can easily add the element over here, and it gives the flexible storage for you to store the elements into a sequential manner. So this we cannot do it with the normal arrays. So with the list interface, we can use this specific functionalities over there. So what are the implementations over here? The implementation is basically array list is implemented as resizable array, as I said, which it stores the internally it stores the element. So here we can do the insertion or a deletion easily. So basically the insertion and deletion operations are a little bit slower as compared to the normal array, because here we are using this specific array list, that is an specific list interface of Java. They may require element to be shifted. So when it is deleted in some kind of element, the element needs to be shifted over there, right? So when you're inserting at specific end, so at the time the elements need to be shifted. So little bit it is going to be a slower over there. So accessing here. So basically when I try to access an element by an index. So if I try to access a specific element by an index, imagine I wanted to access a specific element by the indexing. It's basically a first here operation, right? So just we are giving an indexing indexing specific address. It's try to get the address of the indexing and it prints the value. So that's why it is going to be a faster. So the time complexity, you can say the time complexity is going to be the big O of 1 over here. That is a good one. And the use cases, if I talk about this, array list is typically used to need the fast iteration and random access to the element, but less for so frequent insertion deletions or arbitrary position. It means so iteration will be faster, so little bit slower for the insertion and the deletion operation over there. So in the same way, if it's see the time complexity for the array list, if I try to access an element, it is a big O of 1. If you try to search an element, imagine I want to search specific an element over there in from the array list. So it is going to be the big O of n. Basically depends upon the size of an array. So it depends upon the size of an array. If for the n size, if the element is present at the last, it is going to search from the starting and it goes till last, right? So it is going to be the search can be the big O of n over here. It is basically depend upon the size of an array. And insertion and deletion at the one end. So imagine you are deleting a specific element at a specific end, or inserting a specific element at a starting position at the starting at the end I am talking about. When you're inserting and I want to insert an element 10 at the last, or I want to delete an element of the last element, that automatized, basically it is a big O of 1. So here we can easily iterate what is the size of an array, and we can just do this specific operation, and we have a inbuilt methods as well. And same way, insertion or a deletion can be at the beginning, and the beginning, if you want to insert and delete, that is a big O of n, it is going to be there. Why? Because we need to shift the elements, right? So here the shifting comes into the picture. So that is why the big O of n comes into the picture over. Imagine I want to add an element at the beginning. So all the element, whatever it was previously, it is present. So that indexing position will get shifted, and this is will be going to be happen over there. So that is where the big O of n here. So let's see about the array DQ here. So the array DQ is also a resizable array. Array DQ is basically an extension of Java array list. So in the array list, even it's similar to the specific thing, but it's implement kind of a double-ended queues here. So queues over here. So we'll understand again what is stack and what is queues. So just for right now, you understand it is a double-ended queue interface in Java, that we can do the insertion and removal at the both the end of the DQ efficiently. So it means you can do the insertion and the deletion at the both the ends in a sequence by using a DQ over here. Okay, so that can be a very flexible ways to manage here. So the implementation remains same. We can resizable it. We can add an element in the both the ends that can be removed from the both the end efficiently. And when we do the insertion and deletion, so our operation at the beginning of the end of the DQ are fast. So basically in the array list, it is slow, right? If you use the array DQ, both the element insertion and deletion is faster here. So that is going to be the give you the access of big O of 1 here. So because it can we can do from the both the ends, right? So rather than traversing to every element, we can have an address stored and we can get the operation done here. The accessing. So when I try to access an element here, so basically it is slower here. So the access is faster in array, but the access in array DQ is slower, because what it does not provide a direct random access to. Basically you can access an element from the front end or end. Basically you can traverse from the front and you can traverse from the end, but you can do it, but it is not the faster way here. Okay, so use cases we know, right? Like if we talk about the use cases by understanding the implementation, insertion, deletion and access, where we can do the deletions or an insertion from the both the end. So it's a basically support for efficiently for storing insertion and deletion of the end. So let's see what is the time complexity of the array DQ. So for the accessing, we can do big O of n. For the search, basically if I want to search a specific element, okay, that I want to do the specific search element, that will be the big O of n here. So as I said, the insertion and deletion are happening at the beginning or the end efficiently, both the ends. So that is efficient more than as compared to the array DQ. So it gives the big O of 1 over there. Okay, so let's look with the example. So coming back to my Eclipse, so I'll be creating another specific class for here. So I'm going to create a new class. So I'll just create a class name as array list. Okay, so I'll just create a public static void main and just finish it off over that. So in this array list, so here I'm going to give one example. Okay, so let's try to implement the specific package, that is a java.util.star. So I wanted to import all the packages into my list. So once I import this, now I can implement the array interface here. So the array interface is going to be look something like this. So I'm going to use as a array list interface. So this is the array list. So that is going to take an integer as an argument. And let's create a1 is equals to new array list. So this is the syntax which we are going to use for the creating a array list over there. Okay, so here the array list has been created. Okay, so a1 as a array list we have created. Now we can try to add an element. How many elements you want to add, you can easily add it here. So let me try to add using a for loop. So I'm going to tell for int I is equals to 0. So I'm going to tell I should be lesser than or equals to, let's try to add 100 elements. Okay, and I'm going to just store, I'm just going to increment the value I plus plus. Then if I do this, I'm going to tell from the a1 specific variable. This basically creates a variable, right? So in this a1 array integer variable, what I'll do here, a1 dot add method. So I'm just going to add the specific add here. So while adding, I'm going to iterate the I value and I'm just going to simply add the specific data for here. Okay, so once I just run the specific program, so you can see the program got executed here without any delay. Okay, so now when I just try to access an element, let's try to do SYSO. So if I try to I wanted to access an from the A1, I wanted to access some 78th index value. So let's do the A1 of 78 index. So basically it gives the, see, it's telling the type of an expression must be an array type. Okay, and type, but it resolved into the array list integer. So you cannot access in this way it is showing you. Okay, so if I try to access, it is not giving me an access to run to get the specific using the array indexing over here. Okay, so this is not possible. Okay, so this is what I wanted to show you. So let's try to get the specific element and print it. Okay, so I'm using a for each loop. So let's try to use here as a for. I'm just going to tell from the int element I wanted to from the a, I am going to iterate it from the a1. Okay, so I'm going to iterate it from the a1. So from this specific element, I'm going to iterate it from the a1. So if I just do SYSO and if I just access then element a, so now I can able to access it. So if I try to execute the program, we can able to see all the element I can able to access it over there. So you can see we have these many elements. Let's try to give a simple element. Let's try to do here as a simply 10 elements and execute the program. So now we are having a 0 to 10 elements here, basically 0 to 10 element. So if I just wanted to access from the 1, I can just tell start from 1 and go till 10. Okay, that's cool. Okay, so we have a 1 to 10 elements we have been stored into me array list, array list, that is a variable here. Okay, a1. So I'm accessing through an instance a. So let's try to add some inbuilt methods here. So we can have an inbuilt method. Let's try to add a1 dot, I want to add an integer. So I'm just going to add some element 78. Okay, so I wanted to add some element that is a 78. So this I'm going to shift onto the top. Okay, I am just going to shift on the top. So when I try to add this a1 dot added the element 78. So the 78 will get added after the element 10 over here. See, after adding it, if I try to use a for each loop and try to print it, so you can able to see this 17. You can see 78 is been added at the last over there. So this is basically provides us where you want to add it. So even I can add some kind of an imagination. So imagine like I'll tell a1 dot add. So again, I'm just going to see. So you can see we have a add and add method. Two add methods we are having. One, we can directly provide the integer, and the second, we can give the which indexing position you want to store a specific element here in the array list. So I'll just tell I wanted to store the indexing position 5. I wanted to add an indexing position 5, the element ID that is 50 here. The number I want to add as a 50, and it is going to be the indexing position is going to be 5 here. So if I try to execute the program, so you can able to see at the indexing position 5, 50 has been added. That's cool, right? You can see 0, 1, 2, 3, 4 and 5. So basically at the fifth indexing position, the element is added here. Okay. So in this case, here the time complexity is going to be big O of n here. So the time complexity will be big O of n here. So that's for your understanding. I'm just showing you the time complexity will be big O of n here. Why? Because when I try to add an element number 50, it has to add the specific indexing position. Already previously for till here, some element was stored at this way. Basically, it was sixth element number 6 was here at right at the indexing position 5. So when I try to do this operation, it has to do shifting manually. It has to shift the data manually for the rest all the positions over there, right? So that is why the time complexity will be big O of n here. Okay, so this is one of the demerit which we saw. So this is why we are using the add method over there. Okay, so along with that we have a remove method. So if I just tell here a specific remove, so if I just tell here a1 dot remove, so here if I just try to tell to remove such element number 50 here. So if I just tell to remove the element number 50, if I just try to remove the element number 50, and again if I just copy, I'll just comment out the above one, and here I'm just going to paste. So after removing the element number 50, what is going to be the output? So here I'm getting an array. So it's telling me the list index 50 out of bond over the element number size is 12. So it's telling me the element number 50 is not present inside the array list A1. So I'm just going to tell the element, okay, here I have added the 50 element, but here we need to give an argument as indexing, not the element number. Okay. First tell I want to remove an element for the indexing position 5 that is been stored as a 50. So if I execute this, here you can see the specific element has been removed, the 5, and even you can see that after removing an element number 5, all the elements has been shifted. Even in this case, the time complexity will be big O of n over here, because if I try to remove an element indexing from the beginning or an end, it is fine. Okay, but if I try to remove an element from the between, then rest all the elements whatever is present, it has to apply the shift method over here. It has to automatically shift to the top of it, right? So that is why it is giving an element number 5 after removing. If I try to print the loop, it is going to give the output in this way. Okay, so now after doing this, so let's try to apply some kind of an inbuilt methods of here. Okay, so I'm going to tell here something like we have an element from 1 to 10 now. If I just tell here as a SYSO, so we are having something. If I just tell from the A1 dot contains, I can just try to check in the A1 dot contains. If I just try to tell here as a 15 here, if I just try to print the element 15, it is giving false because the element 15 is not present into our A1 array list here. We are having only 1 to 10 element. If I just try to print here as something like 9 here, 9 is present, right? If I execute, it is going to give you the boolean value. It is telling me, yeah, this element contains, that is a true value it is giving here. The same way, if I just try to have another inbuilt method, that is if I tell here as equal, so I'm going to tell here as a eq equals. Okay, so what is equals method is going to tell. So I'm going to tell here a1 dot equals with a1. Okay, I'm just creating a1 some elements, so I'm just matching with this thing whether it is equals to equal. Yes, it is returning true. So let's try to create another array list. Let's try to create an array list called as a2 here. Okay, so in a2 we don't have anything. If I just try to give same thing, like if I just try to give here the last one, that is a1 dot equals with a2 here. Okay, if I just try to execute, it is going to give me false because a1 array list is not having similar with the a2 object over there. Okay, so let's try to add some elements here. So let's try, okay, let's try to, even if you add, basically when I am taking, it just checks the data whether it is equals or not equals over there. Okay, so that is if it is equals, it will return you the value. Okay, it is been equal. You can see compare the specific object with the list for the equality. Returns true if only if specified object is also list, both are also a list, both lists have the same size and corresponding the pairs of element of the two list are equal. Basically the length should be same, the element should be same, then it will return you true over there. Okay, that is why we have given this. So then let's try to give the size of it. So we have another inbuilt method that if I just try to tell a1 dot, there is something a method called as a1 dot size method. So what size is going to do? So if I just execute the program, so size returns 11. Basically it's telling me the array size is you are having the 11 over there. Okay, it is telling me the array size is 11 over there. The size of an array is be 11 over here. Okay, so because we have an 11 element over there. Okay, so then along with that, if I just try to get the specific indexing position value, let me try here. Let me try to add. Let's try to add another value here. So I'm going to tell here something like this. Like let me go back. So I'm going to add another element. That is, I'm going to tell a1 dot add. I wanted to add. Then I'm just going to tell I wanted to add some element 12. Okay, also I'm going to tell as a 120. I'm going to add an element 120. Basically, when I try to add, so it will be stored at the indexing position 12, right? So already we have a 10 element. Then here we have added one element, that is the 11. Then we are adding here because one element we have removed from the remove method, right? So now I'm just going to tell a1 dot get method. So in this get, I wanted to get the indexing position of 12. Okay, if I try to execute, so you can able to see I'm getting an error like indexing out of range here. So it's telling me exception range, the index out of range, basically length is 12 here. Okay, so let me give here as a 11. Basically it starts from 0, right? So when it starts from a 0, 11th means the value will be, it will be pointing to the 12th specific box, right? So if I tell I wanted to get what is the element stored into the indexing position 11, so you can see it is giving me the 120 over there. So the length will be 12 itself. The length will be 12. So I mean to say, you know, right? I hope you understand this. Basically, if I just indexing will be start from 0, 1, 2, 3, 4, and it goes on. If we are having right till now, we are having the indexing position 11. That means in this I can able to store the 12 elements here. So I can able to store the 12 element. That means we have an already 10 element here, 11th element here. This is the 12th element. If I want to access the 12th element, I need to give the indexing position 11. So I'm giving this 11 method over there. So then we have another method syso. So I'm going to tell syso system out dot println. So I'm going to tell a1 dot is empty method. Whether your specific A2 array list is empty or not. It will return me true because we don't have anything over here into the A2 array list. So it gives the empty over there. Okay. So then we can convert the specific array list to the string as well. Okay. That is also is there. So let me try to show you that syso. Let's try to here a1 dot. I'm just going to apply a method called as toString method. So toString method. So what it does here is it is going to convert the entire element with the string here. So you can see I can able to, it has been converted and it is just printing it over here. If I just try to tell syso, if I just tell a1 directly, so this I'm just going to save this. If I execute, you can able to see now it is been giving me the, if I try to print a1, it is giving it is a array list now. So if I just convert this to this, it is going to be the specifically what it is going to do. It is going to tell me this is the basically string method over there. So let's tell a1 dot, you can see we have a clone method contains, we saw, so is empty. Even we can get with the last index of and even you can remove the entire remove object we saw, size also we saw here, right? So this is all the inbuilt method that's is going to be there over there. Okay, so we have another method, so you can have a look on it. So we have a clear method. So clear method is going to clear all the entire data from it over there. Okay, so this is what the clear method is. Another important one is do sort method also you help us to sort the specific values from the list over there. Okay, that is what it is been going to be done. So let me comment out this stuff specific method over there. Okay, so here we have another method called as a add all, right? So let's try to use a add all method. So I'm just going to use the add all method. So I'm just going to tell a1 dot add all method. So I'm just going to tell add all. So from the add all, I'm just going to tell a2 here. So basically we had an a2 is in not having any kind of a data, right? We are just applying add all method. What all the elements we are having in a1, I wanted to add everything into the a2. So this is where the add all methods comes. So if I just try to print the syso, so I just try to print the a2 here. If I just try to print the a2, so you can able to see it is giving an empty here. Okay, a1 dot add all to a2. So here, okay, so if I just try to print a1 here, if I execute the program, it is giving all the element that is from the here. So a1 dot add all with the a2 here. So we have done this. So let me try to print in the loop over there. Okay, so basically if I just comment out this, I'm just going to tell for int, I'm going to tell for a in a2. Okay, I wanted to iterate the element from the a2. Then if I just try to print syso, so I'm just going to tell a here. So I'm just going to remove this colon. So here for int, I'll just tell int a of a2 here. If I execute here, you can see it is not giving anything because it is not having anything over there. So what is, and I think I need to tell for a2 dot add all a1, add all the elements we are having. I need to do it like this. Okay. So if I execute now, so now you can see I can able to print the entire output over there. So I can able to get the all the output of it over there. Okay. So basically from the A2, I wanted to add all the element of the collection A1 over here. That is what we are doing it over there. Okay. So this is how you can use the add all method as well. Okay. So I hope you have understood the array list now. So now according to the properties, whatever we discussed into the array list, we have been inserted all the operation and we saw, okay, searching, accessing will be there, insertion will be, so it is the array list, right? Insertion or deletion at the one end will be fine, that is big O of n. If we are doing in the insertion or a middle, that is going to be onto the big O of n over here. So we saw, right, that if I just tell here as a1 dot if add first, we have something called as a add method, and we have another method that is a the specific get the specific, and you can see what is the class of it by printing what is the type of the specific object. Okay, so remove all basically helps us to remove all the data from it. Okay, we can just tell like that, and we have another method to array, we can convert the string with the arrays as well. Okay, this is basically that helps over there. So you can see last index of we can get it. Okay, that helps that is going to be a big O of 1, that gets the basically an element very quick here over there. Okay, so now let's see the another inbuilt method for the array dq now. So let's go to the next. I'm going to create a new class here. The class name I'm just going to tell here as a array dq here. Okay, array dqs. Okay, so I'm going to tell public static void main finish this specific thing. So in this specific array dq, so we are going to check what is the methods we are having it over there. Okay, so that's very simple. Let's keep it as simple. So I'm just going to add the code, already we have written it. I'm going to tell here as import import java dot util dot star over there. So in this I'm just going to paste the array dq. So the initialization, you can see the initialization basically we did here array dq, an integer that's taken new array, and we are just telling here that is going to be the new array. We have initialized the array dq. So even here we have an add method. So using add method we can add 656 9 here. So in this array dq we are having so in this specific array dq, so as I said you, right, in the array dq we have we can resizable over there. The insertion can be done at the in a very minimal way over there. Okay, so if I just come back here, add 56 add, so basically it adds into a very contiguous memory location. If I try to use a method add first, so basically it is going to add the element at the beginning itself. Okay, array dq provides the addition from the both the end. Okay, you can add at the middle, even you can help add first method basically does what, it's going to add an element over here over there. Okay, so add an offer first over here. So what is the add offer set? Basically it inserts the specific element at the front of the dq over here. Okay, so basically insert the specific element front of this dq. So it's basically add the specific element into the specific element that is into the first. It returns true basically when it's try to add it. So offer last is basically is kind of an element that adds at the end of the dq. Okay, it's basically similar. So if I try to see here as a system.out print a, let's see what is the output we are going to have. Let's try to run one by one. Let me comment out this. So I'm just going to execute the program here. So you can see I am having an element that is first here. So add first is added to the 5. So again, if I just remove this one and if I just try to execute, you can see 5 is at the present and offer last is present at the last over there. Okay, so basically it's both the thing is same. Here basically inserts the element at the front of this dq, same thing, and even here the offer first is also gives the same specific functionality to add the element at the first over there. Okay, and it offer last and add last will be returning the element at the last. It adds the element at the end of the specific array dq over there. Okay, so what is meant by pick first here? So if I just execute this pick first, so you can see it is going to tell me the 10 element. Basically pick first returns you the what is the element present at the first indexing position of your array. That basically at the 0th index, what is the value present, that's going to get printed over here. So if I just try to print what is a dot get first here, so what is the a dot get, even get first or a pick first, returns you the first element. How we are having add and add first and the offer first, same like we can retrieve the information pick first and the get first. So pick last and the get last is basically helps to get the data from the array dq, the last element. Basically you can see it is returning 25 and 25 is present last at the array dq, so it is printing over there. Okay, So we have a poll first here. So let's see what is going to do the a dot poll first here. If I just try to print, if I execute the program, so now what poll first did here is it is evacuating the element number 10 from the array list. Okay, the poll first is basically removes the first element from the array list that's present into the 0 indexing position. If I just try to do a dot remove first, so now I'm going to apply poll first. Already 10 is removed. If I do the remove first, the next first element will get removed, that is the 5 here. Okay, so you can see if I execute now, it has been removed, the 5 element is been removed. Now you can see the 656, 9 and 25 will be there over there. Okay, in the same way I can remove the element from the end of the list, even from the starting. So the poll last is removes the element. Now that poll last will remove the element that is the 25th. Again, if I try to apply the remove last, it will remove the element that is 9. Then I'll be left out with the only 2 element, that is a 6 and 56 here. So if I execute this specific scenario, if I execute it over here, you can see the left out element is 6 and 56 over there. This is the concepts of array DQ, and you can see the access will be easily the 0 big O of 1. Searching will be big O of n itself, because it has to traverse if it is not found in the starting in the array list. So if I just talk about array DQ, right? So accessing will be the big O of n. That same searching will be done. But the insertion and deletion is going to be the big O of 1 here, because it provides the functionality from the both the end as compared to the array list. So that is why it is having the complexity better. So thank you guys. I'll catch you with the next session. Take care. Bye bye. Hey guys, welcome to the session number 6. So let's see what is stacks, say linear data structure concept. So stack is basically a LIFO structure, that is mean by last in first out. So it's overall depend upon the concept of LIFO. The last in first out is stack, and next we are going to see queues, that is first in first out. So based on this principle, this specific data structure concept is been evolved. So it's basically help us to add a specific element, basically using two major operation, that is a push and a pop over that. So its stacks are commonly used in every programming languages in compiler operating system for various purposes. And let's see what is an example for this. So if you see this specific diagram, so let's say it is a stack, it is having an empty stack. So if I try to add an element, let's try to imagine an element called as 1. So when I add a push method to an element 1, so it's going to add the element over here into the stack. So again, if I try to add an element 2, basically if I try to add an element 2, again I'm going to put a method called as push here. So it is going to add an element above the element number 1, that is 2 over there. So if I try to add an again element number 3, that is a push, so again it will add after 3. So if I try to apply a pop method for the stack, so it's basically remove the top element from the stack over there. So it is going to be the element 3 is going to be top over there. So in this case the element 1 is going to be at the top. So here it is going to be the top. So in this case the 3 is been at the top. So in this case, if I try to apply the pop method, the top element will get removed from the stack. So then the pointer is going to shift it for the element number 2, that is going to be your top over there next. Okay, so this is how the specific stack is going to work. That is why the name has been given as last in first out. So basically when I try to insert any element, it is going to add at the last, right? It is going to add at the last. If I added 2, it has been added at the last. If I added 2, it is going to add it at the last. So when I try to remove the element from the stack, in the stack, whatever the first element will be there or top, that is going to be at the that is going to get removed over there. Okay, so in this last element is 1. So you can see in this last element is 1, last element is 1, last element is 1. Again, if I try to add, this 2 is going to be at the top, 1 is at the last. Here 3 is at the top, 1 is at the last. 3 is at the after removing 3, here 2 is going to be at the top, 1 is going to be your last over there. So it is how the specific things works. If it is an empty, stack will be empty over there. So it is a last in first out. Okay, so the one who comes at the last, he is going to be removed over there. Okay, so that is how the things happen. So let's see with the stack methods. So we have a push and a pop. For push is for the insertion, pop is for deletion. Search is method is there, peek method is there, and is empty and size method is there. So let's look with an example over there. So coming back to my Eclipse, so I'm going to create a new class. That's I'm going to make the class name as stacks. Okay, stacks over there. I'm just going to give the public static void main. I'm just going to keep the program in this way. In this case, let's try to create one specific stack over there. So this is basically a specific package where we can import the stack. I'm just going to tell from the I want to import from the java.util.star. There is a other, or else there is a java.util.stack is there. You can get this specific thing from over here itself. Okay, java.util.stack method. You can get the stack element over there. So let's see how to create a specific stack. So I'm just going to create the specific stack, that is create the stack over there. Okay, create the specific stack. So I'm going to make use of the stack here. So stack stack. So in this I'm just going to make this is going to be a type string. Then I'm going to tell this is going to be your stack is equals to, that is a new stack over there. So we have initialized the specific stack over there. So once we have initialized the stack, now I can apply the push method. So I'm going to tell as a push method. Let's see how it is going to be there. I'm going to tell here as a stack dot, I'm just going to apply the push method. So I can just insert anything over there. So let's try to insert an element called as, let's try to insert something apple. Okay, so in this way I'm just going to apply the few more methods. That's I'm going to tell 1, 2 and 3. I'm just going to tell apple orange here, apple orange banana. Then I'm just going to tell here as a kiwi. Okay, so these are the 4 elements I have been pushed into my stack over there. So if I take this example, how it is going to be evaluated. So let's try to see how it is going to be there. So if I just create a new here, that's I'm just going to tell it as a stacks. Okay, so in this I'm just going to create insert one specific thing. The insertion I'm just going to do it in this way. Let me take this example. Let's take this is your stack. Okay, this is your going to be a stack. So in this stack, how it is going to be taken. So if I just type copy, I'm just going to paste 2 times. I'm just going to tell here, and I'm going to just paste another time. So let's take to have like this. Okay, so in this specific element that is a stack. So if I try to add an element over here, let's take an example. I'm trying to add the specific element here. So first I have added something called as banana, right? So it is going to add the banana over here. So if I just tell here as a B here, okay, the banana is been added. So then I try to add the orange. Orange is been added over there. So if I just try to add the apple, apple will get added over here. If I added the kiwi, kiwi will get added. It is going to be your last element, and it is going to be your top over there. Okay, so if I just try to push the element, so I am going to apply it over here. So if I just try to apply the pop method, so this I'm just going to push the element here. Okay, so again if I just try to pop the element, so this k will get evacuated, and here the a will be there, and orange will be there, and banana will be there. Okay, so now this is going to point at the top, and this is going to be the again your last element. So again if you try to add an element called as let's try to add something called as let's try to add something called as Mossambi over here. Okay, so I'm just going to try to add the Mossambi here. So first try to add, already banana is there, orange is there, apple is there. So if I try to add the Mossambi, so it is going to add at the top over there. So this time it is going to be at your top, and this is going to be your last element over there. Okay, so again if you try to apply the pop method for, let's try to apply the pop method for 3 times. Okay, so the first your banana this specific Mossambi will get evacuated, then apple will get here in this method, Mossambi will get evacuated, here apple will get evacuated, here orange will get evacuated, then you will be having left out with the only banana. This is how it is going to work. Okay, so you can see the data we have been added. So apple, orange, banana and kiwi. So in this case the kiwi is going to be your top element, apple is going to be your last element over there. So now coming back to the specific displaying the element into the stack over there. So let's try to display the stack. So if I just tell here as a SYSO, I'm just going to tell here the specific current stack is our whatever the stack is there. Okay, so once I execute this specific stack, if I run the program, so you will be able to see the program data, that is okay. So here I need to use plus operator. Okay, so I need to use it here as stack, that like this I'll use this plus here. Okay, if I execute over here, you can see it is going to do stack is apple, orange, banana and kiwi over there. Okay, you can see kiwi is at the last element. So first I have added apple, apple is stored, then orange is stored, and banana is stored, and kiwi is being stored over there. So once I just try to remove this specific popping an element, so let's try to pop the element. Okay, let's apply the pop here. So if I try to pop here, let me try to write an element, that is I'm just going to tell here as a string, whatever the string is there. So I'm just going to tell here as a POPED popped element. popped element is equals to. So now I'm just going to apply a method called as stack.pop method. So when I apply the stack.pop method, it basically returns the value, and I wanted to store it into the popped element. So I want to just try to print and show you. So I'm just going to tell here something like the popped element is the popped element. So I'm just going to tell here in double quotes, the popped element here is the specific popped element over there. Okay, so I'm just going to show you like this. The popped element is popped element. Basically, in this case, the last element which has been added, that is so at the last we have added kiwi. So in this case, the kiwi is going to be at the top. In this case, if you have the kiwi is going to be at the top. If I try to remove, if I apply the pop method, the kiwi should get deleted, right? So now if I just try to execute the program, so you will be able to see the popped element is kiwi over there. Okay, so this is how the things we can able to store it over there. The popped element is going to be kiwi. This is how we can apply the pop method. Okay, if you try to apply two times, if you just tell stack.pop, it will 2 times, it will remove the top 2 element from the stack over there. Okay, so after displaying the stack, after removing the specific element, if I just try to see what is the stack after pop, I'm just going to tell here as a after pop stack. If I just execute, you can see after the pop stack, we are having apple, orange and banana. The last element has been removed. The top element has been removed over there. So it is going to be pop over there. In the stack way, we have something called as picking the top element. So now I wanted to check which is the top element, basically picking the top element over there. So what I'll do here is, again, I'm just going to tell here as a string the top element. The top element is equal to, so I'm going to tell here as a top element is equals to, I'm just going to tell here as a stack from the stack dot top over here. So I'm just going to tell stack dot to peak. So the element, the method which we need to use here is the stack dot peak here. Okay, so what peak does here is, the peak is going to see which is the top element into your stack over there. So if I try to tell sys, so I'm just going to tell here as a top element in stack using peak. Okay, using peak here. So I'm just going to give this space. I'm just going to tell plus, I'm just going to iterate the top element over here. Okay, so once I save this and if I execute the program, you can able to see the top element is stack in stack using peak is banana. So you can see now apple, orange, banana is there. The banana is going to be the top element. You can see in this case apple, orange, banana is was I have added. The apple was added. It is going to be, after removing, the next element is going to be the top element. In the same case, after removing kiwi, the banana is going to be your top element over there. Okay, so that is how the things goes. So I'm going to tell the top element in stack using peak is, this is the top element. Okay, and along with that, I have another method like search method. So we can able to search it whether the element is there or not. So for the search method, let's try to see that searching over there. So I'm going to tell here as a searching. So I'm going to tell here as an int. I'm going to create one variable called as an int index. So this int index is equals to, so I'm going to just tell here as a stack dot search method. In the search method, I am just going to check whether it is a banana or what. Okay, so I'm just going to directly give the value. So I'm going to tell index stack dot search, that is a banana over there. Okay, so I'm just going to check the banana. I'm just going to tell if the specific index value is not equals to -1. That means if the value is present, it is not going to give you -1 over there. It is not going to give the specific -1 over there. Okay, so in this, if index is not equals to -1, then what I will do here is I'm just going to apply the CISO method. I'm just going to tell element is present. Okay, so I'm going to tell element is present. Okay, so else I'm just going to use the else part here, else. In this I'm just going to tell sys. So in this I'm just going to tell element is not present over there. Okay, element is not present over there. So I'm going to use the brackets over there. So I'm going to tell here as a, if the specific index is not equals to -1, it will tell my element is present or else not present. If I execute, you can see the element is present. If I just tell here as a banana 2 is not there. If I execute, it is going to tell element is not present over there. Okay, so this is how we can search the specific element as stack dot search. Again, even I can just search for orange, whether the orange is present or not. If I execute here, you can see the element is not present. So if I just tell here as orange is not present, so if we have in this case we have an apple, we have orange. So you can see it is given as a capital letter O. Okay, so we need to give caps O here. If I execute, you can see it is giving the element is present. So this search method is also present over there. Okay, So then this is how the thing specific search operation is there. So again, we can just check whether the stack is empty or not. Even that also we can see, or else I can just tell here as a stack dot size method. I wanted to check what is the size of the specific stack. If I execute, you can see the stack element is 3 now, because we have popped out the element that is one kiwi. Now we are having only 3 elements, so that's why it's telling the stack size is equals to 3 over there. So again, I can just check whether the stack is empty or not. I can just tell here as a stack dot is empty method. So what is empty does, whether if your stack is empty, it will return you true, or else it is going to return you the false over there. Okay, so that is how the specific push operation we saw, pop operation, peek operation, search is empty, and the size operation, the specific size operation works over there. So I wanted to check what is the time complexity for all these cases. I wanted to see what is the time complexity for all the cases. So if I just take you about the push here, so let's talk about the push time complexity. In the push time complexity, the operation adds an element to the top, right? This operation adds an element to the specific top. So the time complexity of this operation is going to be what? It is going to be, I'm just going to put the comment, that is going to be big O of 1 over here. Big O of 1. Why? Because it doesn't take in much traversing. It can be adding it is going to just simply involves adding an element to the end of the underlying array or a list, right? So basically this is some kind of it array or a list. You can just take it as an array. It's just adding an element at the last, that's all. So pop, even in the pop also the time complexity is also going to be same. That is, the time complexity is going to be that is a big O of 1 itself, because when I remove it, basically removes the last element, right? That's why it is going to be the big O of 1. When I talk about the peak, even peak also is going to be the big O of 1 here, the time complexity. Why? Because even this is peak is basically it points the last element of the array, right? That is why. So the search operation. The search operation here basically depends. If the search element is found in the starting itself, then it is going to be big O of n, or else it can be majorly, if we talk about the correct case, it is going to be what? Guess what it can be. So it is going to be an exactly, that is a big O of n, because if I want to search for an n last element, it will travel the last array till last array it will travel. So that is a going to travel for the n element. So that is why it is going to take the big O of n. So sorry, here I wanted to see for the push, right? So here I want to give somewhere else. Okay, so this is the push here. So if I just tell where is the pop we have applied, so if I just tell it is a pop is the big O of n, and again if I at here top element to peak it, so peak element also the time complexity will be big O of 1. And if I just try to search, what is that? The search operation. The search operation we did it here, so it's going to be your big O of n. So when I just try to check whether your stack is empty or not, even this is going to be your normally, that is a big O of 1 here, because just we are, if there is a, just we'll check if the size is greater, we'll just do it in a very simple way, right? Even if I just try to check the size, so even it is going to be big O of n. So basically we don't need to check, just depends upon the size, what is the elements present on total number of element, will just give the response. So that is going to be the big O of n 1 over there. Okay, this is also about the time complexity and the stack. I hope you got it, all the points. So in the next session, we are going to cover up with the next concept. Take care. Bye bye.
Hey guys, welcome back to the section number 2, session 7, about the linked list over here. So linked list is one of the very important data structure concept which is going to be majorly asked at the interviews. So we are going to see about the linked list end to end. We are going to see what is linked list and why it is used and what all the benefits of it and what its time and space complexity and what all the concepts that comes under linked list over there. So coming back to what is linked list here. So linked list is basically a fundamental data structure concept that used to organize and store the data of collection of element. It consists of series of nodes, like we will be having a 2 part here. Every node will be having the reference of the next link over there. So if you see into the diagrammatic representation over here, let's imagine we are having a 4 nodes here, A, B, C, D. So A will be having the address of B. So B will be having the address of C. C will be having the address link of D over there. So that means if you are at the A node, you imagine a person is standing over here. So he will be knowing who is there at the next place, that is at the address B, because A of next will be having the reference of the next node over there. So now here every node will be divided into the 2 parts. One is there will be a data and there will be something we are going to call it as next here. So the next here
is going to store the address of the next node basically here. So the starting node, we call it as the header node, that is going to be your first node into the linked list. So how you are going to call a specific node is the last node. So if the node of next, a node of next is equals to null, at that case we are going to call this specific node is your last node over there. So in linked list only you need to consider, like, there will be header part, your first node, and for your last node the next is going to be null, and for the rest of the every node it will be having the reference link of the next node over there. So this is how the linked list is going to be there. So let's understand more a better way. If I just see the operations of the linked list, so let's see now how we are going to insert at the beginning. If you want to insert a node, how we are going to do at the beginning, and how we are going to insert the specific node into the between, and insert at the specific end, and insert after the specific node over there. So let's look with the example over there. Coming back to my notepad here, so here I'm just going to show you how we are going to store the specific links over there. So in this case, let's try to see how we are going to have a look onto it. So in this, let's try to take one example here. Let's try to take an example. We are having an element here as a 20 here, and we have this is a data, and imagine there is something an element 30 here, and we have an element 50 and have an element 50 here. Okay, so as I said, this is going to be your next pointer, so I'm going to just mark it as into the dot. So this is we are going to call as next over here. Even this is going to call it as a next here. Even this is going to be call it as a next here, and this we are going to call it as null here. This is going to be null, and this we are going to call it as the header part over there. Okay, so this is how the linked list is going to be there. So let's try to imagine, let's take an example here. Let's try to take an example here, data, and let's take here example as the address. Okay, so let's take an example of a address over here. So imagine we are having a 20 data, the address of it is going to be 1002 here. Okay, and let's take an example of 30. So this address, it is going to be in the specific next, it is going to store 1003, and let's try to take an example here as a 40, 1004, and let's take an example here as a 50. So let's its address is basically, let it can be basically, it will be a null here. Last node we are going to call it as a null. It don't have anything over here. Okay, so it means it is going to be have an address. So basically the 20 of next, this specific next will be holding the address of 10003 here. So if I just tell here, so it is going to have an address of 1003 over here, and this specific address in the reference link, the address is going to be stored here as a 10004 over there. Okay, so in this 40, so sorry, I have done here, so let me remove this. Okay, so remove this over here. Let's try to add it again. Okay, so basically 20 of next will be having the address of 10002, right? So I have given as a 1002, and it's having the 1003 here, and here it will be having the address that is 1004 over there. So what I mean to say here is, see, what is the 1002 here? So 1002 is where your 30 is 100 is where this is the address where your 30 has been stored over there. And if I just tell here what is going to be stored, it is going to store 10003. That is mean in 10003 your 40 note has been stored. You can see it is storing the 40's specific address over there. So in this case, what is 1004? 1004 is basically an address of the next node over here. 1004 is going to be the address of the next node over there. So this is how the things is going to work over there. Okay, so this for your understanding I have just said you over here. So here it is how the address is going to be stored over here. So basically what I mean to say here is, if you in this specific node, there will be divided into the two part, that is the data and the next. So next is basically that is going to store the reference link of the next node here. So here you can see 1002 is which is stored. That means in 1002 the 30 the address of the 30 here. So this is what 1002 is the address of a node 30. So I can just tell here, I'll just tell into the 1002 is the address of node 30 over here. Okay, and same way if I just talk about 1003 is the address is the address of node 40 basically. So it means to say if you are in 30, so you'll be in your 30 of next, you will be having an address of the next node. So with this specific address, you can easily reach out to the next node over there. Okay. So this is what about the linked list over here. So linked list, if I just take another example, so if I imagine there will be having a links over here like this. If you have seen any kind of a chain link, so it is going to look something like this. If I show you in this way, so you can see in this link, this specific link has been changed here. It has been linked. I mean, it is linked. That means if you are in this link, if you imagine this is your first link, it is second link, this is your third link, fourth and fifth. If you are in the first link, you will be knowing the which is your next link, right? You can see because that has been connected over here, that has been linked to the first node. That means you will be having an address of the second link. So if you are in the if you are in the second node, so again you can see here in your second link, there will be another link has been linked here, that is a 3. So you'll be having an address of 3 over here. Okay, so this is how the linked list concept is there. It's very simple, so that it can reach it to the specific pointers over here. So let's try to imagine. Now let's try to imagine I wanted to insert this specific at the bottom over here. This is just one first example. Let's imagine I wanted to insert a specific node. I want to insert, this is your new node over here. Let's imagine this is your new node, and I wanted to, and even let's say this is an insert, this is also your new node over here. So let's take an example for the first one over here. Let's take an example for the first node. So imagine I wanted to insert, this is your new node, I wanted to insert your new node, that the in the value I'm just going to give it here as a 10 here. Let's say this is your node, that is a 10. I wanted to insert into the beginning over there. So how we are going to do this specific task over there? So it is very simple, guys. It's very simple. Let's take, this is your first example here. So this will go basically first example where we are going to the insert at beginning here. Okay, so let me tell here onto the top, insert at, I'll just write it as a beginning over here. Okay, I am just inserting the node in beginning, insert. I'm going to tell here as a insert at beginning over there. So I wanted to insert this specific node at the beginning over here. So imagine I'm just inserting the 10 over here now. So the first thing what you need to do here is, so the new node of next is there, right? So I'm just going to write the agenda over here. So I'm going to tell here as whatever your new node of next. So what basically it will be having the address. This is going to be a next, right? So it's going to be a new node of next is there, right? So for this you need to make it as what is the, so if new node of next is there, right? So you need to make to this connection over here. So just you need to just link it over here. So whatever the header of address variable will be there, I want to just make it over here. I'm just going to tell whatever your new node of next is there, right? I need to point towards the header part, that is your first node. Okay, so once it is done, then again I want to make the header part, whatever the head is there, right? So I wanted to just make the header to the point it towards the new node over here. It's very simple, just 2 lines of code over there, right? So what I'm telling here is whatever the new node of next is there, right? Whatever the new node of next will be there, right? So for that I'm just going to make it your header pointer, and whatever the head, so whatever the head value was there previously, for that head I'm just shifting to the new node over there. So basically here we are going to run something called as a pointer. So whenever we are inserting, so let's take this service, we are going to make it as a one pointer. We are going to run one pointer. So I can just say in the better way, so whatever the new node of pointer will be there, right? So pointer of the new node, I'm going to tell new node of pointer will be there, just point it towards the header part, and whatever the head is there, just point it towards the new node over here. In this case what happens, right? So now this is going to be your header part, and whatever he'll be, so let's imagine this specific address is been at the 1002 here. This specific 20 variable address is 1002. So what it happens here is, with the help of this specific link, this is going to point towards the next node over here. So I can just tell here as in this way. So I'm just going to write it here as this is going to be pointed towards the next node over here. In this way it is going to work now. So just we are doing the new node of pointer, basically the new node of PTR we are just marking as a head. Then whatever the head is there, right, the head is equal to, then we are just making the head, whatever the head was there, that I'm shifting towards the new node over there. So once I just shifted, in this case it is going to be evaluated. This I'm going to mark it into the yellow. Okay, this is going to be removed. Okay, this is going to be removed over there, and this is going to be your new node. This is how the we are going to do the inserting the specific node at the beginning over there. So that was a very simple thing over there. Okay, so now let's take an example of the second node here. Let's take an example of the second node. Second example, insert at last. I'm just going to mention here as a insert the node at last over here. So let's take an example. Here we have a node something called as a 2, we have here as a 3, here we have a 4, and here we have a 5 here. So this is going to be your null value, and this is going to be your everything is going to be next, and this is going to be next, and this is going to be your next, and this is going to be near null. And basically let's imagine this is going to be your header part, right? This is going to be the header part now. So now I want to insert an element at the last. Let's say, for example, I wanted to insert at the new node, that is 6 here. Okay, so let's take this is how it is going to be there. So in this, let's take to example in this specific node over here. Okay, so in this, I wanted to say here, so whatever I'm going to run one specific pointer. I'm just going to run one specific pointer. So this is going to be your PTR. So for it starts from here, it is going to be one pointer. So I'm just going to tell the pointer, I'm going to point the value towards the everywhere the next. I'm going to check if your specific pointer of next is equals to null. If it is equals to null, then what you have done, you have reached to the last node. That means we have reached to the, I'm just going to mention here, we have reached to last node over here. So we have reached to the last node whenever we are running a pointer. Imagine the pointer of next is equals to null, then we already have reached to the last node over there. So then what we are going to do, so whatever I am going to do here is, so whatever the benefit this condition gets satisfied, so there will be a pointer, right? So I am going to tell, imagine now the pointer is at the last node. So for that, what I am going to tell here is the pointer of next is there, right? I'm just going to point it towards the new node. So I'm just going to point it towards the new node where we are inserting. That means what I'll do here is, so I'm just going to remove the value of null. I'm just going to point this towards now here. So I'm just going to point this towards the this specific new node over here. Then what I'll do here is, whatever your new node is there, right? New node of next is there, right? So I'm just going to make it to null over here. So whatever this value was there, so here I'm just going to make it to null value. That's it. Very simple, right? So I'm just running one pointer. When the pointer of next is equals to null, if it is become null, then we have reached at the last node. Then whatever the pointer of next is equals to there, right? So the pointer of next, whatever the pointer of next will be there, I'll be pointing towards the new node. Then whatever the new node of next will be there, right? So I'm just going to make it as the null over there. So this is how we can insert this specific node at the last over here. Okay, so this is what the example of the last node. So let's try to see example number 3, that is inserting. I'm just going to tell insert the node at middle. So I want to insert this specific node at the middle over there. So in this case, let's example we have an element here as let's take an we have an element 11, we have an element here as a 12, and here we have an element here as 14 here, and here we have an element called as a 15. This is going to be your null value, and this is going to be your header part, and here we'll be having we are going to store one pointer, and here we'll be having a next, and here we'll be having a next here, and here also we'll be having the next, and this is going to be the null over here. So let's imagine this is your new node. I wanted to insert it over there. So this is going to be your new node. Okay, I want to just insert the new node. I wanted to insert a node by the name that is with having a 13 over here. Okay, so now how we are going to run it over there. So how we are going to run. So in this case, what we are going to do here. So let's take a simple example. So what I'll do here is, I'm just going to delete this link. I'm just going to delete this specific link. Whatever the link was there, I'm just going to delete it over there. After deleting this middle link, what I'll do here is, this specific next, I'm just going to point it towards this one, and in this specific new node address, I'm just going to I'm just going to store the address of the 14th over here. Okay, so I'm just going to store the address of 14 node into the 13, and whatever the 12th of next was there, right? So I'm just going to point it towards the new node over here. So this is how we are going to insert this specific node at the middle over here. So what are the ways it will be? So what are the ways it is going to be there? So if I just try to insert the specific element into the between, so how it is going to be there? So what can be the logic for it? Okay, so let's see that specific logic. Okay, so here I'm going to tell here what I'm going to run one specific pointer, right? I'm just going to run one specific pointer. So I'm just going to tell keep on reaching the pointer. So there will be at the pointer of next will be there, right? Whatever the pointer of next will be there. So this is, if you imagine the pointer is here. So the pointer of next whatever will be there. So I'm just going to run one. I'm going to keep one specific pointer to the new node as well. So for that, I'm just going to tell whatever the pointer of next is there, that means it will be storing the address of 14. Apparently here it will be having the address of 14 here, address of 14 here. So what I'll do here is the 14th, I'm just going to clear again, so let me let it neatly. So I'm just going to tell whatever the 14th address is there, right? I wanted to make the p of next here. So I want to make the p of next. That means in this I'm just going to tell, imagine there is a something called as a p pointer here. So I'm just going to tell here as a p pointer here. So here I'm just going to store it into the whatever the 14th address we had. So that address I'm just going to store it into here. That means I'm just storing whatever the address was there. I'm just going to store it into the node number 13. So I'm going to just tell store it at the 13th address. Okay, then case whatever the address for the next was there, here we have stored now. So once we have done, now what we need to do, the p of next, I need to just point it towards the pointer over, right? So I'm just going to tell here as a whatever the p of next is there, right? The p of next, the p of next, I'm just going to make it, this is as your pointer over here. Okay, this is going to be your pointer address now. So I'm just going to shift this towards the here. I'm just going to point it over here, then it is going to get linked over here. That's it. Okay, this is how the specific formula is going to be there over here. So let's see what is the time complexity is now. So let's see what is going to be the time complexity over here. Okay, so imagine I'm just going to insert an element over here, inserting the specific element at the last here. If I just try to insert the element at the last, we need to run one pointer, right, to check which is the next of is equals to null. So it means I need to traverse all the nodes. So here the time complexity is going to be big O of n over here. Let's try to imagine what is the time complexity when I try to insert an element at the starting. What is the time complexity if I just try to insert at the beginning? So because as we are inserting only at the one, we are not shifting any kind of an elements here, we are just working with the two nodes here. So in this case the time complexity is going to be the big O of 1 over that. So then if I just try to see when I try to insert the node at the specific at the middle, so what is going to be the time complexity? It is also going to be big O of n, because we need to traverse two pointers here to keep track of the various, which is the new node and which is the previous middle nodes, and we need to do it in this way, right? So that is going to be the big O of n over here. So that is how the thing is going to be happen over there. Okay, that is what the about the insertion. So in the next session we are going to see about the coding part of this specific inserting a node using linked list. So then when we complete this about, so we will be having in the same way, we will be having something called as a deleting the nodes as well. So in this also we'll be having 4 cases deleting, how you are going to delete the first node, how you are going to delete the middle node, how you are going to delete the last node over there. Okay, so thank you guys, I'll catch you with the next session. Take care, bye bye.
Hey guys, welcome to the session number 7.2. So let's see the delete operations in linked list. So we are going to see how we can apply the delete operation for insert deleting at the first node, deleting the middle node, and deleting the specific last node over there. So let's look up with the example over there. So coming back to my notepad over there. So here you can see I have created one specific example for you guys. So let's take this first example here. So let's try to insert some of the values into our nodes here. So let's try to have here, we are something like we are having some value here as a 3, here we are having some 4 here, and the 5, 6 and 7. So we know this is going to be, we are going to have the next here. This is the one thing I have missed it. So I'm just let me add all the specific pointer data and the next nodes to it. Okay, so we have added the specific links over there. So let me give the specific, this is going to be the next part. So I know you will be understanding whatever the dot I have given here, this is going to be your next. And the last node we are going to have the null here, and this is going to be where the header part over here. So imagine this is the first case, we are just applying the deleting the first node. So let's imagine we are just deleting the first node over here. We are deleting the first specific node over there. So I wanted to evacuate this entire node. I wanted to evacuate this specific entire node over there. So let's see how we can evacuate this specific node. That's very simple. So I wanted to evacuate this specific node. Basically I wanted to shift this specific header towards to the next node and just free up this specific space over there.
So for that, what I'm going to do here is I'm just going to create one specific pointer. So I'm just going to tell here as a node. So I'm just going to create one specific pointer that is going to point it towards the head over there. Okay, then what I'll do, I'm just going to tell head of specific next address will be there, right? So just I'm just going to make it the specific next over there. So basically I'm going wrong here. So I'm just going to tell here whatever the head is there, right? So for the head, I'm just going to make it to the head of next, and I'm just going to free up the specific pointer. So I'm just going to free up the specific pointer over here. So what I'm doing here is, so imagine the node of pointer. So I'm running one pointer that is called it as PTR. So this specific PTR that is pointing towards the head. So what I did, this is going to be the address, right? This is going to be your next. So the head is the head, whatever the head is there, right? So right now I'm just going to make a head of next basically. So in this head of next, I'll be having the address of this 4, right? In this specific variable, in this specific node, I'll be having the address of the 4. So what I did, so basically what I did, whatever the address of 4, whatever the header of next was there, for this specific node, I'm just making this as a header over here. I'm just going to tell, just make this specific node as the head. That is what we are doing. The head of next, we are just making to head over here. See, I'm just going to mark it again. The specific head of next is there, right? For the head of next, we are just making the value that is going to be head here. That means the head of next means apparently I am just pointing towards it. I'm just going to pointing towards this head of next, basically points towards this node, right? So for this specific node, I'm just making as a head. Then I'm just going to just free up this specific space over there. So once I do this, it will going to be the first and it has been get freed. So 4, 5, 6, 7 and null is going to be there. This is going to be the node after deleting the first node over there. So then let's take an example, deleting the node in between. Okay, deleting node in middle. Okay, so let's say deleting this specific node in this specific middle over there. So in this, how it is going to be there. So even here, what I am going to do, it is also going to be very simple. So let's try to imagine now we are having an element that is 4, 5, 6 and 7. So it is going to be pointing towards the null, and this is going to be your header part, and this is going to be your next over here. Basically, let's try to imagine, let's try to delete this specific node. Okay, let's try to delete this specific node. Let's try to delete this specific node. So here I'm just going to run specific again, one specific pointer. So I want to tell, right, which specific point, which specific node and a position I need to give. Whenever I deleting at the middle, I need to give what is the position I need to give it. Let's take this as 0, 1, 2. So this is a 0 and it's going to be 1 and 2 and it's going to be 3 index. Let's imagine. So it is, I'm going to pass this and 2 as a input parameter. This is a position I wanted to delete it over there. So now what I'll do here is same as it is. I'm just going to run one specific pointer. I'm just going to run one specific pointer. That specific pointer is going to go till the position. So it will go till the specific position over there. So I'm just going to run one specific while loop. So that specific pointer is there, right? So this specific pointer will go to the specific position. Let's try to, I'm going to give it here. Okay. So this is your first task. So it is going to go till the 1 over there. Okay. So it will go till 1. When it goes till 1, in this I'll be having the address of the 6th, right? So what I'll do here is, so whatever the address, when I go till here, I'll be having what is the address of the 6th. So I can just keep track of this specific PTR. So this is a PTR star and it's only PTR. So what I'll do here is, I'm just going to track the PTR. So this is going to be your deleting node. This is going to be the deleting node, right? So I'm going to keep track of the PTR. So once I keep track of the PTR, what I'll do, so whatever the PTR of the next value will be there, right? So I'm just going to store it into the specific PT double R of next. So I'm going to tell PT double R star of next over here. Basically, this is your main pointer. So imagine this pointer is going to come till here. So in this, after comes till here, I'll be having the address of this. So what I'll do, this specific address, I'm going to store it into the variable called as a PTR, that is a deleting node. Then I'll visit to this node. In this specific node, I'll be having the address of the next node, right? So what I'll do, this specific address in this specific PTR of next value will be there, right? So that I'm just going to point it towards here over there. Okay. Then what I'll do, then when I'm just going to free up this specific, that is the pointer. That is, I'm going to just free up the specific pointer. This is how the code is going to be there. So once it is done, so it is going to be 4 here, and it is going to be 5 and it is going to be 7, this specific node we are going to get evacuated. This specific node we are going to get evacuated over there. So what I'll do here is this is going to be evacuated. So apparently how it is going to be working here is this specific whatever the address of this we had, so this was here. So this I just edit transfer over here. I'll just transferred to here. Okay, whatever the address was present here, this address I just transferred to here, and whatever this specific pointer was there, after passing this address after passing this specific address, this specific will be apparently pointing towards this specific node over here. Okay, then we just with this we have just the free up the specific phase. This is of the deletion of the node is going to come into the picture at the middle over here. So that same way, if I just want to delete the specific node at the last over here, let's try to imagine the last case, deleting the node at last over there. Okay, so now already we imagine we are having a 4, 5 and a 7. So imagine where this is your header now, this is going to be your null. So I wanted to just delete the last node. So I'm going to I'm just going to run one ptr. So in this ptr of next is equals to null. If this condition gets satisfied, the ptr of next, basically when the ptr is here, so when after traversing the ptr comes to here, right? So the ptr of next is equals to null, right? So what I'll do here is, so I'm just going to free up that specific space. I'm just going to so if it is equals to null, what I'll do, I'll just visit to the previous node of it. I'll just see the I'll visit. I need to keep track of these two node. Basically I need to just create, or else I can just simply do, right? So whatever the ptr of next is there, if it is equals to null, I'm just going to free up the specific ptr over here. That's it. Okay, then whatever the last node will be there, right? So whatever the last node will be there, this is going to be your null value. So that's why it is going to be 4 and it is going to y and it is going to be your null value. So this we are just freezed up over there, and this is going to be your header part itself. That's it. Okay, even when I try to delete this specific last node, I need to keep track of this so that I can make these values to null over there. That's it. Okay, this is the simple operation. So now let's see with the coding part of this specific program. Like we have we have seen for the insertion, right? So same things will apply for here as well. So let's see that specific insertion part now. So for that, I'm just going to come back to the Eclipse. So in the same program, we are going to add the operation. So let's try to add. We have already an operation that we have inserting the node. In the same specific stuffs, in the same specific class, now we are going to work for the deletions. So I'm going to tell as a delete operations. Delete operations over there. So let's try to add the delete operations over there. Then a delete operation, same thing I need to write it. So I'll just I have already written the code, so I'm just going to explain you the code. Okay, so I created one specific function that is a public void delete from beginning. So if I try to apply this method delete from beginning, if the head is not equals to null, basically imagine there is only a single node, then it will just return it and it just make the head of the next over there. Okay, so if delete the specific operation from the beginning, so if the head is equals to null, just we need to return it. Then what we are making, head of next is there, right? The head of next, basically imagine when I wanted to delete the at the beginning, the head of next, whatever I said, right? You can see here itself I have said neatly. So whatever the head of next is there, right? Just make it as the header part and just free up the space there. So that is what we have done. Head is equals to head of next over there. That's it. Okay, this is going to be your delete from the specific beginning. So then let's see how we are going to write the operation deleting the specific operation for the end of the list. I'm just going to write it here as a deleting from the end of the list. So I have written one function that's delete from end. So this what it is going to check if the head is equals to null. Okay, and head is not equals to, the head of next is equals to null. That means the head is going to become null. So if there is a single node, that just delete the single node. Okay, if not, I need to traverse to the last, right? So I'm going to tell you as a node of current is equals to head. So I'm going to tell current dot next of next is not equal to null. Basically, I'm to keep on traversing. I'm just going to keep on traversing for the node for the all the nodes. I'm just keep on traversing for the all the nodes. If dot of next is equals to null. Okay, when I travel it, when it becomes null, then what I am doing here is I am just pointing the current node of it. I'm just going to keep the current node into a variable current. Then I'm just going to make that value to null. That's it. I'm just going to make that specific value to null. Then it is going to get freed up over there. It is going to be at the deleting the specific node over there. So when I try to next, let's see the example for how we are going to delete the specific node at the middle over there. So for that, again, I have written out already a function. So already I have taught you for the insertion. So that's why I'm just skipping for the deletion part. So you can type it by seeing the code. I'll be giving you the code as well, right? So the understanding is very important. So here, coming back to the next code, the line of the next function, deleting the node at the middle. Same way how we have done for the insert, same code is going to be position. So basically, when you match this code with the insertion, all the things will be same. Just the thing is, we are just making the value to null. That's it. Okay. So you can see if the when deleting it, if the position is 0 or a null, if it is the node which we want to delete, that is the last node, then what we are doing it here is, if the head is not equals to null, basically if your head is there, if there is a specific one specific value, like at least there is a single node, and that case what we are making, head is equals to head of next over there, and we are just making it return over there. Okay. If not, we are just keeping the specific current position over there. We are just making, I need to reach to that specific position. If I wanted to delete the specific node here, I wanted to reach to this specific position. In that case, I need to run two pointer that stores the address of the this one. I need to track this j and this specific thing, so that I can link the both thing, right? So in this case, it is required to track all these three nodes, right? So that's why we are returning here. I'm running a loop. For the first position is there, right? Go to the previous node of that. So after going to the previous node, in this I'll be having the address of this. So what I'll do, I'll just going to track this data. Then I will visit to this node, and in whatever the next of this specific node will be having, I'll be having the reference link of the 7 here, right? In the node number 6. So what I'll do, this reference link, I'm just going to shift towards the previous node. That is what the code says here. Okay, current is equals to current dot next over there. So again, I'm just checking if there is, I'm deleting, if there is no nodes itself, I'm trying to delete the last node, and and there is no position exists basically, and that case it gives the null over there. Okay, or else I'll be keep on doing this conditioning, and I'm just going to make it to the null over there. That's it. Okay, so now let's try to apply the specific method, run the function. So if I just try to run the function, so if I just try to run the specific function, you can see I have a 0, 1, 2, 3, 4, 5 here. Let me try to, we have a printed here, right? So after inserting a 5, so we have a 5 element basically right now. So I'm just going to tell here as a, for this specific list, I want to delete from the beginning. I want to run the operation delete from the beginning. So if I just try to delete from the beginning, it has to remove the 0th element, right? If I execute, you can see the 0th got removed over there. Okay, then again I wanted to apply another method, that is a list dot delete from the end. I want to apply delete from the end method. That means it has to delete the element number 5. If I execute, you can see I'll be having 1, 2, 3, 4 over that. That's great. So then again, I wanted to delete this specific element here. So I'm going to tell here as a delete from the middle here. So in this position I'll give. So it is now it is recently 0, 1, 2 and 4 here. So sorry, 0, 1, 2, 3. So basically we have a 3 positioning. So I'm going to tell here I wanted to delete the position number 2 here. So once I delete the position number 2, once I execute, you can see the 3 will get removed. So 1, 2, 3, 4 was there. 3 is at the indexing position 2. So the position we have that is getting deleted. So all the operations whichever it has been written, that is working as expected over there. Okay. So the code which we have written for the delete is exactly similar to the insert, but here just we are, rather than creating a new node, we are just pointing everything towards the null over there. So when you point this to the null, it is going to get free up automatically. That's it, guys. Okay, so it's all about the linked list operation. So in the next session, we are going to see about still more on the linked list. We have a doubly linked list and we have a circular linked list. So that we are going to see into the next session. Take care. Bye bye. Hello guys. Welcome to the section 2, session number 7.3. So let's discuss about the circular linked list. So in the previous session, we discussed how the linked list is going to work. And in this session, we are going to look on to the how circular linked list is going to be there. So basically a circular linked list is majorly is going to be like the circular way. Like we saw in the linked list, we have something called as head and we have something called as next, and we saw something like a pointer which is going to point the reference of the next node. But in the specific circular linked list, so you can see if this specific example, we have a data and we have the next element. So basically this is an example for the doubly linked list. So this we are going to look into the next session. But if you take over here, so you can see the last node is there, right? That is again it is going to be pointed for the first specific node over there. So that is why this specific the name has been named as a circular over there. So let's look at with a correct example. So if I just come back to my notepad, so here you can see in this specific example, in this specific way. So let me zoom it over there. So in this, let's take, imagine now we have something called here an element. We have something called as here, we are going to call this as a header, right? This is going to be the header part of our. So imagine if we are going to create one specific an element here as a 20, here we have something called as a 30, here we have some 40 element, here we have something 50. So this is going to be your next pointer, and this is going to be your next pointer, and this is going to be your next, and here it is not going to be the null. Basically the last pointer, right? This is the last of next is again it is going to point for the header over there. If I just take it as a next, next last of next is going to again point it towards the header part over there. So in this condition, it's very simple. It's like simply like a linked list. In the previous session, we saw about something called linked list, right? Even we are going to call the specific term as a singly linked list. Okay, singly linked list. Even the previous example we saw linked list, even you can call it as a singly linked list, because in the next session we are going to look on majorly for the doubly linked list over there. Okay, so in circular it's similar to a singly linked list, just the last node is going to be pointed towards the again header part over here. So here we are going to, there are a few points to be noted over here. We cannot traverse the header part over here. When we create a specific, when we insert a specific node, we're going to declare the first node as a header node, right? So we cannot traverse it. So I'm just going to tell whatever the header is there, right? We cannot traverse it. We cannot traverse the specific header part here. So I'm going to write we cannot traverse. We keep constant here. We keep this specific constant. So imagine if we traverse this specific header part based on the deletion or an insertion, so what happens then? We are going to forget which is your first node and which is your last node. We cannot imagine, right? So when we have a header part is fixed, then only we can imagine, okay, this specific node is going to be your last node, and this is going to be your header node, that is the first node, right? So that is why we are not going to traverse this one over there. So in this case, we can just tell, if we just run one specific while loop, if let's say I can imagine as a pointer, if we create one pointer. So in this tell, if we just tell pointer of a specific next, this will as a ptr of next. Okay, if it is not equals to head. Okay, if the ptr of f next is not equals to head, that is going to be your last node, right? That is going to be your last node. In this case, we can identify basically the specific if the well your ptr of next is there, right? If it is not pointing towards the head, then you can declare that specific node is going to be your last node over there. Okay, this is how the things is going to be there. Or else even you can just tell another equation, you can just tell ptr of next. Okay, if the ptr of next is equals to header part, that is, then it is going to be your last node. In this case, we can tell, okay, we have traversed the entire array, we have traversed the entire specific nodes over there. We can just go back to the header part, and we can run whatever the operations we need it over there. This is basically about the circular linked list, guys. In the next session, we are going to look on to the majorly on doubly linked list. That's a very important concept over there. Take care. Bye bye. Hey guys, welcome to the session segment 0.4. Doubly linked list over here, or you can call as a double linked list or a doubly linked list, anything is fine. Okay, so what is a doubly linked list here? So the name is says like we are having some kind of a double stuffs here. So what is the double thing? The double thing is basically we call it as the two connections over there. Okay, that is basically we can having the access of the previous node, and we'll be having an access of the next node as well. In this example, if you take an example of 3 nodes, so you can see we are differentiating the specific node into 3 category. The middle node, we are going to call it as a data, and the left yellow color which you are seeing, that is going to be your specifically the previous node, and the pink color here you are seeing, that is going to be your next node here. So if you take an example of a node 2, you can see it has a connection of node 1, and it has the connection of next node as well, right? Even if you take an example of the first node, it has a connection of the next node here. If you take an example of the third node, it has a connection of the specific second node here, right? It has a connection of second node here as well. That is, we can have a reference of the previous node, and even along with that we can have the reference of the next node here. That is the concept about the doubly linked list here. So let's look up with an example in the neat way. Coming back to my notepad here, so I'm just going to come back to the doubly linked list. So in the doubly linked list, I have created one example. So let's see how it is going to be there. So let's take here one example. Let's imagine this is going to be your header part, that is going to be a similar for every case. The first node is going to be your header node over here. Let's try to imagine some element. Let's try to add here 40, and here as a 41. Here I'm going to do it as a 42. Here I'm just going to give it as an element node, that is 43. So in this case, we are going to differentiate into the 3 categories. So first category, we are going to call it here as a previous, and here you are going to call it here as a next, and this whatever your thing here we are going to call it as a data here. In the same way here we are going to call it as a previous, here we are going to call it as a next, and this we are going to call it here as a data. In the same way here as well, it is going to be your data, and it is going to be your previous node, and it is going to be your next node over there. So in this case, let's see what it is going to be there. So here also it is going to be call it as a previous node, and here we are going to call the last node, right? Basically this is going to be pointed towards the null over there, right? This is going to be a null over there. So in this, if you have a node 1, node 2 and node 3, so let's imagine this is your node 1, this is your node 2, and this is going to be your node 3, and this is going to be your node 4 over there, right? So in this case, basically this, if you take an example of a node 2, the node 2 has the reference link of the node 1, the node 2 has the reference link of the node 3 as well. If I come back to the node 3 has the reference link of a node 2, and the node 3 has the reference link of the node 4 here as well. So in this case, the time complexity will be better than the singly linked list, right? So because imagine I am in this specific node, if I want to traverse to the previous node, I can easily go one step before, and I can understand, okay, this is the reference link of 41. Suppose I am in the 42. If I want the specific 41, I can just see the previous link. In the preview, I will be having the reference of the previous node, that is the 41th node address. Here it will be stored, right? So I can easily go it over there. And the same way here also I can just traverse with the help of the next by using the next address over here. This is the concept of the doubly linked list, where we can traverse in the both the way over here, right? So in this case, how we are going to be there, points to the whole node. The pointer is there. We are going to create one specific PTR here. That is going to be a pointer. That pointer is going to refer to the entire node. Okay, you can, with the help of the pointer, you can access what is previous, and you can access what is the specific next over there. Okay, so that is how the thing is going to be there in the doubly linked list. Okay, so in this case, if I tell here which is your next node, basically we can tell if the specific pointer of next is equals to next. Next, if I just tell here as a PTR of next is equals to null, then this is going to be your last node over there. And if I just tell PTR of head, which is where it is there, it is going to be your first node over there. Okay, that is how the things is going to be there. And in the doubly linked list, let's write an example. I wanted to apply insert operation, delete operation, like how we did inside the linked list. Same thing over here also, it is going to apply it over there. Okay, if I take an example, if I wanted to escalate the 41, like let's assume I want to escalate the node number 41 here. So if I escalate the node number 41, here I need to update it, right? So let's try to an example here. So let's take in an example. Let me take one example here. So let's take this much example. Okay, so let's take this example. I'll just copy this. Okay, and I'm going to paste it again. So I'm going to Control C, Control V. Okay, yeah, it has been copied. So I'm just going to take it an example of this. So in this case, if I just try to escalate the specific number 41 over here, let's try to escalate this node that is 41 here. So if I just try to escalate the node number 41, let's say what I need to do it over here. If I just escalate it, basically I need to just simply join, right? I need to just simply join this to here, and I wanted to join these specific things to here over there, right? That's what I need to do here. If I just try to delete an element that is 41, so what you will be doing here, if I just tell here, if I just take an example, if I write a algorithm for it, I'm just going to tell here the specific node 2 of previous is there, right? Suppose if I tell whatever your node 2 of previous element, whatever your node 2 of the previous element will be having, right? So I just wanted to make it as the same thing, that is a whatever we are having, I need to make it as a node. If I just say whatever the node 2 of previous element is there, I wanted to make it as node 3 of the specific, if whatever the node 2 of previous element is there, I wanted to make it as a node 3 of previous, node 3 of the specific previous element. That means I am just joining these two here. So you can see node 3 of previous element will be there, right? I am just joining to the node 2 of previous element. And same way I can just tell here as whatever your node 2 of next is there, right? Node 2 of next will be there, right? Just I need to just point it towards the basically whatever your node 2 of next will be there, right? I was just wanted to join to the node 1 of whatever your node 1 of next is there, I need to make it as node 2 of next. I need to just tell here whatever your node 2 of 1. Let me erase this specific one. So I'm going to tell whatever your node 1 is there, right? Node 1 of next is there, right? Just make it as node 2 of next. I'm just going to make it as a node 2 of next over here. So in this case, you will be having a question how you are going to access node 1, node 2, node 3 and all. Because if your pointer is here, right? If your pointer is here, this pointer can access all the information of the node 1, this pointer can access all the information of this entire node, and this pointer can access the information of the node 3 as well. So with the help of one specific pointer, I can traverse the entire whole node as well as the previous node as well as your next node. In this way, I can just remove the specific element. In the same way, if I want to insert any kind of an element here, imagine I wanted to insert any element here. If I wanted to insert at the last, or I wanted to insert it here. So in this case, I need to give what is the position, right? What is the position and the node I need to insert. Here, if I just wanted to insert at the place number here, that means I need to give the position as a node number 4. Node number 4 I need to insert. In this case, what I'll do, I'll just transfer all the node 3 information to the new node, and whatever the previous information of the node 4 will be there, I'll transfer to the previous node. So that already we have seen in the linked single linked list. Same thing will apply for the doubly linked list as well. The little bit complex here is a deletion of the middle node here. So I have said you here, this is how we are going to insert it. Delete it. If you want to insert any node, same thing you need to do it. Create a new node, access the previous node information, access the next node information, and just insert it over there. Okay, this is how the specific things we are going to remove it. If I wanted to delete this specific node from the beginning, if I just imagine there can be a second case, I wanted to delete the header node here, right? So whatever the first node, I wanted to delete the node at the beginning. So whatever the node, whatever your node is there, if your node is not empty, that is should be one condition. If your node having the specific node of prev, if the node of prev is equals to is going to be in your header node, then we can free up this specific space. Then whatever your node of next will be there, right? That I'm just going to point that specific node to the header part over there. Okay, this is going to be the deletion at the beginning over there. So if I just wanted to delete the specific node at the end, I'm just going to tell whatever your node of specific next, if the node of specific next is equals to null, if this condition gets satisfied, what I am going to do, I'm just going to free this specific node. Before free upping this specific node, whatever the node of previous element will be there, right? So with the help of the node of prev element, what I'll do, so that specific previous element, with the help of this node of previous element, I'll be having this specific reference, right? Pointer will be pointing here. So what I'll do for that specific if the specific things happen, for that what I'll do, whatever the node of previous element, node of this specific, if I take this is your last node, this is basically your last node, right? The last node of prev will be having an address of the next the previous node. So for that, I'm just going to make it that specific, make that specific node of next is there, right? Just make it to null over here, null null. That's it. Okay, this is how the algorithm we need to write it. Okay, so now let's understand with the programmatical way, the specific theoretical understanding we got it, how it is going to be there. Now let's understand with the specific problem statement here. Let's come back to my Eclipse here. So I have created an Eclipse. I'm just going to create one specific new class. The class name, I'm just going to create it. The class name here, I'm just going to get it something like as a doubly linked list. Okay, doubly linked list over here. So in the doubly linked list, so I'm going to create one public static void main. Just finish it over there. Once I finish it here, it will be giving me some kind of a data. So let's try to create one specific node over here, and let's try to import the package. I'm just going to tell import java.util.star. Okay, so I'm going to tell java.util.star. So I'm going to just give it as a concurrent. I'm going to remove java.util.star over here. So here I'm going to just create some kind of a classes here. Okay, so let's try to create one specific class node here. So if I just take an example of a class here, so if it is having a node, so in this I need to have it to information. I'm just going to tell we need to have one store the specific data, and there will be a node which is going to handle the previous element, and there will be a node that is going to handle your next element, right? So these are all the three things that's come into the picture over there. So apart from that, if I just wanted to create one specific node, I'm just going to create here as a public node. If I just create a specific public node that takes an integer, that is a data, so it is going to organize, and it is going to set the constructor like this dot specific data. It is going to be the data, right? And what is the first element that is getting inserted. So for that, it is going to store the first dot previous value is going to be your null value, and along with that I'm going to tell this dot next is also going to be your null value over there. Okay, so this is the basically initialization of your node here, the specific node, and along with that we have initialized the specific data here. Okay, I'm just going to tell here as public class, that is a node here. Okay, so I need to remove basically here. Okay, Okay, let's see, there is an issue here. So if I get it, node is equals to this and next, and okay, that's fine. So as I insert this specific node over there, so now what is the next thing we need to do it here? The next thing basically I need to create the one specific another class, like that class basically handles. So let me create one class called as w linked list. Okay, w linked link list list over here. This is going to be another class which we are going to create it. So in this specific class, so what we are going to do, we are going to just create one specific node. We are going to initialize one specific nodes to the header node over there. Okay, this is going to be your header node. And again, I'm just going to create one specific public class called as w linked list. I'm just going to create the same name for the creating a constructor. Like whenever this specific class organized creates this, if it's basically a first node getting inserted, I wanted to make the specific this dot header is equals to null over there. Okay, this is going to be your initialization of it over here. So now let's see how we are going to insert this specific class at the if let's try to an example. Let's see how we are going to insert this specific node at the beginning of it. Okay, so if I type, the video is going to be long, so I'm just going to already I have typed it and tested. So this is the method which we are going to use for the beginning, the insert the node at a new node at the beginning of the list. So what we are getting here, we are just creating a node. Insert at beginning is the method name we created. That's basically a void method, and that doesn't return anything. So we'll take the integer as an data. Whatever the data we'll be taking input, we are going to take it, and we are going to create a new node. If the head is not equals to null. Okay, let's imagine if there is a no data, if there is nothing in the beginning. So I'm going to tell if the head is equals to null, there is no head. Then what I am going to tell, whatever the new node we created, just point that specific node as a new node, and that is going to be your header node. If it not that the case, then what we are going to do, we are just going to, if there is a header part, what we are going to do, whatever the new node of next is there, right, we are going to point that towards as a value of the head. If there is already head, what I am going to tell, new node of next I am going to make it as a header part. Then whatever the head of previous will be there, right, that I am just going to make it as a new node, and head is equals to new node over here. I mean to say, right, if we are inserting any data at the beginning itself, if it is nothing there, then I'm going to normally I'll just store it. If there is something, what I'll do here is the new node. If I just take an example of a new node, that new node of next will be there, right, that I'm going to point it towards the head. Okay, I'm going to point this as a head. Then whatever this node of previous will be there, right, this node of whatever already existing node of previous will be there, right, that I'm just going to make it as the header node. That is what we have said. You can see head of previous is there, right, that I'm just going to make it as a new node, and whatever the new node we inserted for that specific new node, we are just going to make it as your header part over there. This is going to be the insertion at the beginning. So let's write an insert in a specific new node at the end here. So we're going to create another method. That method I'm just going to create here. Let's take an example, public void insert at the specific end here, insert at end. So in this case, if I just tell here as an insert at the specific end, in this case what we are doing already, let's imagine we are having let's imagine we are want to insert at the end here. So at the end, if there is no node, imagine there is a single node which we are inserting. If the head is equals to null, then whatever the first node will be there, that is going to be your node. Else what we need to do, we need to keep on traversing till your last node value is going to be your null, right? We need to check what is your last of node of next is equals to null here. Same way we are doing here. You can see we are just going to run one specific current pointer. If the current of next is not equals to null, then means it is going to be equals to null, right? That means if the current of next is not equals to null, then in this case that condition will get fail. If I just tell here the last node is not equals to null, means I'm saying some false information, right? That at that time the while loop will get stopped here. So once your while loop will get stopped, what we are going to do for after stopping it, then make that specific, I'll be pointing toward the next here. If these values get filled here by saying like previous, the next of next is null, then what I'm going to do, I'm going to stop it over here. Then I'm going to make the current node, whatever the current of node next value will be there, right? I'm just going to point it towards the new node, and whatever the new node of next will be there, I'm going to point it as a null here. That is what we are saying. You can see current is there, right? Just make it the current node, make it a current of next will be there, right? Just make it as a new node, and the new node of previous node is going to be it as a current node over there. That's it. Okay, this is how the insertion will happen at the end. So now if I just try to insert the specific method to display what all the methods or all the data we are having, this is a method to display the doubly linked list. I'm just going to create one method called as a display. In this display, what we are doing it, we are just creating, we are just checking how many data we are having it, and we are just printing it. So I'm just going to point from the header part, node current value, I'm going to start from the head, Then if the current is not equals to null, because it means till last node you need to go it and you need to access the data and keep on updating your pointer to the next. That's it, and we are just printing it over there. Here is how we are going to print the doubly linked list. And in the same way, let's take an example. I wanted to specifically insert this. I wanted to search a given node. Imagine I want to search for a node with the given value, whether it is there or not, whether the specific node is present or not. For that, I am just creating another method, that is a public node search method. I am creating it. In this, I am going to tell the value, the basically data. If I am going to check in the current dot data is equals to value, then I will return it, or else will tell the specific value null, that is basically the node is not found here. And whenever we are doing any operation, we need to update the pointer as well. So we are telling current is equals to current dot next. It's keep on updates the data over there. Okay, this is going to be here. So now let's try to insert a specific node onto a given node. Okay, let's try to an example, another example. Let's see this one. So in this specifically, I'm telling here in this specific method, what we are telling here, we are just telling method this is a specific method that insert a new node after a given node. Okay, this basically takes inserting a new node after a specific given node here. So here, if I tell here the specific previous node equals to null, here we need to provide the what is the previous node value, and I need to tell what is the specific data here. So here one thing I said to forget to said you, whenever I wanted to insert any at the middle, so in this case I need to give the two arguments here. The argument number one here is what is the previous node. Okay, then I need to give the data. So if I have a previous node access, right, imagine I wanted to insert it over here. So if I just take the node 2 of what is the node 2 of previous address? Pre means basically it's going to point it over here, right? So anyhow, if I give an input as a that is going to hold the reference of the previous node, I'll be giving one input parameter. Then the second parameter I'll be giving what? The data. I'm going to give it as a data, so that rather than giving the positions here, we are going to give the specific previous values over here. Okay, when I give the previous value as a position, what we are going to do in this case, we are going to tell previous cannot be null. So imagine there is a specific previous node equals to null. In that case, what I am telling here is there is nothing. If there is nothing, it is not going to be happen. Previous node cannot be null, right? Definitely, that is the one here. So then, or else what we'll do, if there is nothing empty, we create a new node here. Then we are going to point whatever the new node of next will be going to be the previous node of next. Then previous node of next is equals to being to be a new node. So you can say I have written here, right? So whatever we have created, whatever I have written a logic while inserting, so the same thing you can see 1, 2, 3, 4, and in here we are just pointing the values, right? So see in this right, you can see here also they are using the 4 informations here. It's not like exactly we need to use it here itself. Even you can use it by using your own method as well. The thing is, the concept is the data structure concept. You need to understand the concept here. Okay, with the help of the previous and the next value, I can insert anywhere very easily, right? That's what happened here. Not in a code, you need to use the same code here. Even you can write your own code, but the things should work same as we are expecting. Okay, so here basically we'll access it and we'll just point the previous nodes and the next nodes. Then we are going to assign the new node over there. That's it. Okay, that is going to be your inserting a node after it over there. Okay, this is all going to be there. So in this case, the specific things will be there. And let's imagine I wanted to let's try to insert the specific elements over there. Okay, in this side I am going to tell you the delete operation as well in the same program, because already we see for the we have seen for the singly linked list. So this was an optional for you guys to understand, but it will be a benefit for you if we understand this linked list concept very neatly. Okay, because double link is also very important, and it is going to be gives the more feature than the singly linked list. So let's take an example. This is a method that gives the values for the deleting a node. When I try to delete a node here, if I try to I want to delete a specific node, I am just going to run one while operation, while loop, where we'll start from the pointer current head. If it is not equals to null and current dot data is not equals to value, basically we are checking the current dot is not equals to null. Okay, and current dot data is not equals to value. Then there is we are just going to do what? We are going to just send it to the next node over there. Okay, if the current is equals to null, we are going to tell node with the specific value is not found. Basically there is no node. Okay, if it is equals to null, will be no node. Or else we will keep track of the previous node value is equals to null. Then we will just going to point the next node and keep on searching whichever the value will get matched. Wherever the value will get matched, we are just going to delete that specific node over there. Okay, so if it is null, previous is equals to null, we are going to make it next. If the next of next is equals to null, then we are going to just make it to the previous node. We are just going to traverse in this specific way. Okay, now let's try to evaluate this specific program over here. Let's try to initialize one specific node here. So in our things, I'm just going to initialize one specific node, right, by saying doubly linked list DLL is equals to new doubly linked list. Here I'm getting one specific error here. So what is the error we are getting it here? That node type is already defined, it seems. So this specific last node is already defined. So I'm going to tell here as a node 1 here. Okay. So I'll be giving here as a node 1 and I'll be giving here as a node 1 here. So wherever we are having a node, I'm just going to press Ctrl F. Wherever we are having this specific node, I'm just going to replace with the node 1 over here. Okay. Node 1 here. Okay. Because I want, because it is in the same package, right? So it is just I'm replacing all over there. Okay. So it has been replaced all. So let me save this. So here, what is again issue? The node 1 cannot be resolved, it seems. So wherever I have, where is it? Okay, so we can do another thing here, right? So I can just tell here another thing. So let me control X. So I'm just going to save here. So where is the class node we have declared here? I have declared somewhere here, right? Here we have declared it. So what I'll do here is I'm just going to comment out this entire program. I'm just going to comment out this entire program. In the same package, it is WordFi is giving error. You can see now it is been went. Okay. So you can uncomment and comment when I give you the code. Now let's try to insert this specific program. Let's try to insert this specific, we have just initialized this specific data here, right? So what I'll do here is I'm just going to create one D1 and I wanted to insert a specific element that is 5 here. So this is going to get inserted at the beginning. Okay. So again, I wanted to insert this specific element node that's called as a, suppose I wanted to insert some 15 here. So after inserting, I wanted to display it here. So I'm going to tell here as a D11 dot specifically, I'll just tell here I wanted to display. So I'm going to call the method called as display here. Okay. So I'm going to just call the method that is a disply display. So it is DLL. Okay. W linked list DLL dot disply display method. So if I execute the program, we can able to see into my terminal, I'll be getting the two specific 15 and a 5. I can see the 15 and the 5 has been inserted over here. So we are inserting at the beginning. When I inserted at the beginning, the 5 was there. Again, if I just try to insert at the beginning, it has to come at the beginning itself, right? That is what here. I'm just going to call again DLL W linked list dot insert at the specific end here. So if I just try to insert the end, I wanted to insert 25 here. After inserting, I wanted to just again display the what is the linked list data we are having it. If execute, you can able to see 25 is inserted at the last here. Okay. These are the things we can insert it over there. Okay. So I can just tell again, I am going to call again one more method. So I'm just going to tell here as a doubly linked list dot insert after a node. I wanted to insert after a specific node. I wanted to insert after the element 5 here. Okay. So I'll just tell insert after the that is a 5. For the 5, I'm going to pass it here some value called as 30 here. I wanted to insert after the node. I wanted to pass it as an element that is 30 here. So basically, I need to give another method here. So I wanted to give here an doubly linked list is there dot head dot next here. So I'm just going to tell after the head of next, you need to insert the 30 here. So after inserting the specific 30, let's try to see how it is going to be there. If I just save this and execute the program, so you can see the 30 has been inserted over there. Okay, so I'm telling doubly linked list of head dot next is there. After you need to insert the 30 here. Basically, it will be pointer will be here. Here we are inserting at the after a specific node over there. Okay, after the node 25 that is going to be pointed here. So after the head of next is there, right? Let's insert it as a 30 over there. That is how we are going to do it over there. Okay, this is all the things we are going to work it over there. Okay, even we can just search this specific node also. Let's try to specifically search this specific node here. So imagine if I just tell here as a node is equals to node search is equals to d11 dot search 20. I wanted to search an element 20. So let's try search for the 30 here. So if the 30 is not equals to null, basically the 30 is not equals to null. Basically, if the data is present, it will tell the node found with the value 30 dot data. Okay, if it is not, it will tell node is not found. If I execute the program, you can see the node found with the value that is 30 here. Imagine if I give it here as a 130 and if I try to search it here, it is going to give node is not found over there. Okay. So this is all the things is going to be involved over there. Okay. Then again, I'm going to tell again, I wanted to delete a node here. So I'm going to tell here DLL dot, I wanted to apply delete. So I wanted to delete an element that is 25 here. So after deleting this specific node value, so I'm going to tell DLL dot display method. So you can able to see the 25 will get deleted. You can see the 25 has been deleted from the node here. So it is just basically calling the node value. We are passing the value. It keeps on check if the value is been found. What will, if the value will get found, if I wanted to delete, if I wanted to delete imagine as a 41, whatever the value, if value is found, we are just going to do like whatever this next is there, we are just setting to this next, and whatever this previous value will be there, we are going to set for the next node of the previous value. Then we are going to just free up the specific space. Okay, so this is how this specifically doubly linked list works. So it's an extension for the your singly linked list. So in that you are going to understand into a more better way, and this is how about the specific things is going to be there. Okay, so I want to give an one specific assignment for you. I wanted you guys to find what is the time complexity and space complexity for the specific inserting at the beginning, inserting at the end, insert display, search, and the or inserting a node after a specific node. And I wanted to show you I wanted you know to understand what is the time and space complexity for the delete operation over there. Okay, thank you guys, take care, bye bye. Hey guys, welcome back to the session 7.11. So we are going to see the example of the linked list using Java over here. So let's begin with the coding part. So I have opened the specific Eclipse over here. So let's begin with the coding part of it. So I'm just going to create one new class for it. So I'm going to create a new class. I'm just going to create a new class. And that's okay. I need to just create it inside this DSA. So I'm going to just create on the new class, and I'm just going to create it something called as a linked list over here. Okay. So I'm not giving like exact name because it will mismatch with the keyword. So just give some double duplicates time. Okay. Just that's why I given. Just finish it. So the linked list has been created over there. So in this, I'm just going to import the all the Java package. I'm going to tell here as a import java dot util dot star over here. Okay. After importing it, so let's try to create one specific class here. So as I said, we in every node there will be a two specific information. That if I take in every node there will be two information, that is the data and the next, right? So I need to initialize these two values for the one specific class. So I'm just going to tell here as a class. I'm just going to create a new class by the name node. So in this node, I'm just going to initialize int data here. So inside int data, I'm just going to create one thing, something called as a node of next over here. Okay, so node of next over here. So node is basically treats as an entire node, and we are just initializing the next part is that is going to for every data there for every node there will be something called as a node. So they will be creating one something called as a next over there, that is going to be the node of next year. Okay, that is a node of next year. Okay, in this way we are going to define in the Java. So inside this I'm going to create another public node over there. So I'm just going to create another something called as a public node. So inside a public node function, that is going to be an int method, that is going to tell here as a node in a node. I'm just going to initialize the data over here. Okay, and I'm going to initialize the value of it as well. Okay, so for this node I need to initialize the data, I need to initialize the next here. So in this specific function, I'm just going to tell here as a the specific node. So whichever the node it is pointing. So for that specific data, whatever the data will be getting from the argument, that initialized to that, and this dot next, this dot specific next is there, right? That for initially just initialized to null over there, for initialized to null value over here. That's very simple. Okay. So what we did, we created a node, and for the first node we just created a data, and we are just initializing to null over that in this case. Okay, for a specific node whenever it is created, if it is not null. Then once we create it, when I'm just going to create it another class now. So I'm just going to create another class called as a linked list class here. So in this specific linked list class, I'm just going to point the node towards the header over here. Okay, I'm just going to initialize the whatever the first node will be there, that is going to be your header part over there. So I'm just going to tell node of head over there. Okay, so once it is done, once we have initialized to node dot head, I'm just going to create one more function, that is I'm going to tell here as a public, that is a public linked list. I'm going to tell public linked linked list. Okay, so in this specifically public linked list, I'm just going to tell for this specific this dot header is there, right? This dot header is there, right? So you need to initialize if there is no node. Imagine there is no node, there is a single node into your, or it is an empty node. So whatever the node you are inserting, the first node, initialize the data and initialize the next to null over there. And whatever the this dot head is there, right? We need to initialize to null. If there is a no node, imagine there is a zero node, or the first time the header part will be having a null over there. There won't be anything. Okay, that is going to be your first part over there. So now let's try to insert the first node now. Let's write a function to inserting. I'm just going to write one function, that is a insert at the beginning over there. Okay, I'm going to write the comment insert at the beginning of linked list. So inside that, I'm just going to write one more function, that is I'm going to tell here as a public void. So I'm going to tell here as a public void. I'm just going to tell here as a insert at beginning, beginning over here. The function name I'm giving as a insert at the beginning. So it's basically takes the int of data, and once it takes the int of data, I'm just going to initialize the node. Now I'm going to make use of the node class and initialize it. I'm going to tell here by using a node, I'm just going to create one new node. Okay, so I'm just going to tell it as a new of a specific node. In this node, I'm just going to initialize the data. So whatever the data I will get, it will get pass, and for the data and the next it is going to get initialized. Okay, so once it is done, I'm just going to tell it as a new node of next. I'm just going to tell new node dot next is there, right? Just new node of next is there, right? Just make that towards the value of the header part. Just make that specific node to head, and whatever the head is there, right? So for that, initialize with the new node. Very simple. Okay, so imagine there is a no node here, so we are inserting at the beginning. What we need to do, new node of next is there. Let's, if I take this example, new node of next, this is a new node of next. I need to just make it to the header part, whatever the previous is there, and make it this specific node as a header. That is what we did. The new node of next, we did it as a header, pointed towards the header node, and whatever the head is there right now, we are just making it towards the new node which we have inserted. That's clear, right? So you can see we have just verified whatever we have, I have taught you. Same thing we have written in the coding point of view as well. Okay, so it's going to be at the inserting at the beginning. So let's take at the inserting at the end. Insertion at the end of linked list. So let's write another function that is going to be a public. I'm just going to write it as a public void. I'm just going to mention here as a insert at end. I'm just going to insert at end. So here I'm just going to take same value that is going to be taken as a int of data. So in the int of data, in this specific function, how we are going to insert at the end over there. So as I said, right, I need to first create a new node over here. So let's try to create a new node. Let's copy the same thing, and I'm just going to mention it here. So node is equals to new node is equals to new node over there data. We have created a new node. I'm just going to check first one condition. If your header is equals to null, then imagine there is no node here. So imagine that is there is a no node itself. Then what we are going to tell, we are just going to point it that specific new node as the header node. That is your header node. It is going to be, that is going to be your first node, and I'm just going to stop the program here. I'm just going to return it over there. Okay, I'm just going to tell return here. Okay, that is going to be your node. So if this condition is not getting satisfied, so what I'll do here is I'm just going to run one pointer. So I'll be using here as some current pointer. So I'm going to make track of a current pointer is equals to head over there. Okay, so I'm just going to make it one current pointer towards the head. Then I'm just going to keep on traversing. I'm going to keep on traversing. I mean to say, if it is a first node, I'll insert the first node, and that is going to be that is going to stop it. If it is not there, I'll be keep on traversing to all the nodes until the node of next is equals to null value. Okay, if that condition is getting satisfied, there I'm going to stop it. I'm going to tell here as for the specific current pointer, that is a specific current pointer. So I'm going to tell if the current of next is not equals to null. Okay, apparently I'm just going to stop the while loop if current of next is not equals to null over here. So if I just traverse here, if I just come to the line number 4, if I just tell here this node of next, line number 5, so this node of next is equals to null, then it is a true condition. So when I tell apparently it is not equals to null, means I'm just going to tell here as a false, right? If this condition, while condition become false, it is going to stop it. So meanwhile, I'm just going to keep track of the header here. So I'm going to tell head is equals to new node over there, head is equals to new node, and I'm just going to, okay, sorry, not head is equals to new node. So I'm going to run a loop here. So I'm going to write the specific current. current. So I'm going to tell make that specific pointer as a last node. So how? I'm going to tell whatever the current dot next is there. Okay, current dot next is there. Just make it as a current node, point it towards it. Then you need to just do what? So if this condition is getting satisfied, that's basically if this condition not equals to null, it is going to tell current is equals to current dot next. Okay, or else I'm going to tell after if this condition gets fail, we'll be storing the value in the current. That means when I traverse till here, then in the current, I'll be having the value of this one, the 5. I will be having the address of this specific node, and imagine entire data of this specific node number 5. When this while condition gets fail, at the last time, the current will be pointing towards your last node of the specific linked list. Okay, so then what I'll do for the specific current, so whatever the current node is there, so basically I'm just telling current current dot next is there, right? So what I'm going to tell here is what are the current dot next, that basically it is pointing towards the last node. Now what I'll do for this node of next, rather than having null, I'm just going to point it towards the new node. That's it. So see, I'm going to write the same code here. So let's tell current dot next is there, right? Make it as the new node over here. That's it. Okay, so this is how the specific things is going to work over there. That's it. Okay, so it's going to be at the insertion at the specifically at the beginning, we saw at the end. So now let's see how we are going to insert the specific data at the middle over there. Okay, I'm going to tell it as a insertion at the middle middle of linked list over here. Okay, so here I'm just going to create another function. I'm going to tell here as a public void. So I'm just going to tell her as a insert at middle over there. Okay, so it takes two arguments. The first takes as in what is the data we need to insert and which position I need to insert it. I need to just point it which position I need to insert it over here. So when I'm teaching, I didn't tell about the position, right? So basically we need to know, right, which position we need to insert it at the middle. So that will run the two pointers, right? We have 1 2 3 4 here, and after second position I want to insert, means I need to traverse two position, basically two position linked list. Then I'm just going to do this operation whatever I have said you over here, right? So that is the one thing. So yeah, that's why we are taking something called as a position over there. So when I take it about to position, so let's try to take here. So let's try to create a node here. This is going to be the same thing to creation of a node. I'll just copy from the top. I'm just going to paste it here. We created a new node. I'm just going to check if the position is equals to 0. Basically imagine if the position is equals to 0. I wanted to insert at the starting itself. I can even using this operation, I can insert at the starting also. Okay. So if it is equals to 0, there is no node. Basically I want to insert the as a first node, and along with that whatever your header part is there, right, that is equals to null. Basically there is no node over there. Imagine there is no node here. So in that case what I will tell, whatever the new node is there, right, that is going to be your first node. So just make it new node of next is there, right? New node of next is there, right? Just make it to that is as a header node, and just make your head is equals to new node over there. Just make it your head is equals to new node. Okay, then I'm just wanted to just return it over there. I wanted to just return this specific node. So imagine now there is a nodes over there. Now I wanted to insert at this specific position. If these conditions get satisfied, so I'm just going to run one specific pointer by the node current is equals to head over there. So imagine if your current node is basically a head, I'm going to start from beginning. I'm going to run one loop over there. So I'm just going to tell int I is equals to 0. I wanted to reach to the position. What is the position? Where is the position I need to reach? So if I want to reach to that specific position, I need to do with the -1, right? So I'm going to tell you as a position minus I here. So whatever the position value of I. Along with that, I wanted to check one condition. If your current dot next, imagine when I reach to the specific position at that time, the current dot next, it should be not equals to null. Okay, it should be not your last pointer. Okay, and I'm just going to increment the node over here. So in this I'm just going to tell if this condition satisfied, then I'm going to tell make it as the current is equals to current dot next over here. So we are just going to make it whatever the current node we are having, right? So for that current we are just making current dot next over there. So we reach to the specific node where we need to start inserting it. So what I'll do here is current is equals to current dot next over there. Okay, we are just storing, we will be having one variable. In this we will be having an address of this. So we are just storing the address of whatever we are having here. So now what I'll do, this address, whatever the address we had previously for this, now this address I'm just going to shift towards the new node over there. Okay, so this address I wanted to shift it over to the new node over there. So it is the thing I need to do it over there. Okay, so I'm just going to check again one condition. If the specific I'm going to tell if the specific current, whatever the current is there, right, it should be not equals to null. Basically it should be not your node, new node. Okay, if we have reached at the last node, imagine in this case if I have reached at the last node, then there is no point of doing this, storing the address of it, that I can just make it over right directly, right? So that's why we're checking one more condition. The current should be not equals to null. If it is equals to null, I'm just going to throw an exception. I'm going to tell here as a throw a new illegal exception. I'm going to tell here as a illegal. So if I get an argument, illegal argument exception, I'm just going to throw this illegal argument exception, as I can just tell here as a position is out of bound. Okay, position is out of bound over there. Okay, so I'm going to try to give some wrong information, imagine over there. Okay, if the current is equals to null, this will get this is going to be throwing you the error over there. Okay, if this condition is not equals to null, then what I'll do here is I'm just going to tell whatever the new node dot next is there, right? New node of next is there, right? So as I said, what I said in the previously, whatever we store the address of over here. Now what I'll do, in the new node of next, I'm going to store the specific address which previously it was holding the address of the 14. So I'm just shifting this to here. That's it. Okay, so that's what I'll tell in the code as well. So new node of next is there, right? Just make it as the current of next. That is a current dot next over here. Okay, so I'm just going to make it as a current dot next over there. Then whatever the current dot next is there, I'm just going to point it that is going to be your new node. Okay, so I'm just going to tell current dot next is there, right? Just make it towards the new node over there. That's it. Okay, so this is how the things is going to work over there. So if I tell here as a current dot, okay, I need to give it as a double equal. That's why it's showing an error. Okay, so now you can see we have written this specific code for inserting at the beginning, inserting at the last, and inserting at the beginning over there. Now let's try to see how we can specific print the list as well. Okay, so let's try to create one function that's going to print all data. Imagine it's going to print all the data. So I'm just going to tell it as a public void. I'm just going to tell it as a print the list. So I wanted to print all the what is the existing list we are having it. So for that I'm just going to tell while current is not equals to null. So there should be no empty values. Okay, if this condition is getting 5, I'm going to tell SYSOC. So I'm just going to tell whatever the current dot data is there, right? I wanted to just print it, and along with that I wanted to just give some space over there. Okay, that's it. Okay, so once it is done, I'm just going to tell here as a current is equals to, I'm going to increment it, current dot next, COURNT current dot next next over there. Okay, so I'm just going to print it over there. I'm going to write it into the double quotes. I'm going to just close the closing brackets over there. Okay, so I said here public void print list. I'm going to write one condition like while current is not equals to null. So I wanted to tell what is the current, right? So I'm just going to initialize that node here. So I'm just going to tell here as a current is equals to, basically it is going to be the header part. Take it from over there. I'm just going to print all the data over here. That's it. Okay, so if it is done, it is going to print it, or else I'm just going to tell SYSO print the simply one new line over there. That's it. Okay, so once it is done, it is this specific function just prints the value of the all the nodes whichever we are having right now into the linked list over here. Now let's try to create one linked list here. So for creating a linked list, so to apply the concept of linked list, we need to use the concept of that is a linked list as a data from the collection. So let's say linked list is equals to the specifically new linked list over there. Okay, so it is going to initialize the linked list. So let's try to add the node now. So let's try to add the specific node. I'm just going to tell it as a adding the nodes now. We are just going to add the specific nodes here. So in this I'm just going to use the concept here. So I'm going to tell you as a list dot, okay, list dot, I'm just going to tell insert at the beginning over here. So it is not an inbuilt functions. Okay, we have written these specific functions for everything, insert at beginning, insert at end, okay, insert at middle, like that. So I'm going to tell insert at the beginning. Let's try to insert an element 1 here. Okay, I'm just going to insert the element here 1. So after inserting at the 1, it has to insert it over there. So let me try to write insert dot insert at end over there. I wanted to insert this specific element at end. Imagine I wanted to insert an element that is 4 over here. So after inserting, let's try to print what is the list dot print list over there. Let's try to print this. So I need to have an element 1 4. Wow, we can say I'm able to see that is a 1 4 at my list over here. So this is how the things works. Okay, 1 4 is been stored into my list over there. Now let's try to insert after inserting here at the end. I wanted to insert the list at the middle. So I'm going to tell list dot insert at the middle. So I wanted to insert the middle over there. Let's try to imagine I wanted to insert an element called as 3 here. I wanted to insert an element that is 3 at the indexing position 0. Let's insert the position at the 3 at the indexing position. Let's try to insert something called as a 3 at the indexing position. Already we have 0. So 0 1 2. I wanted to insert this specific at the indexing position 2 over there. So after inserting, if I try to print, so you can see I am getting as a 1 4 3 here. So basically already we are having a 2 element, okay, 0. So at the indexing position 3, it is been stored as a 3 here. So let's try to insert, and again one more time, let's try to insert an element that is let's try to insert an element that is 2 first, okay, at the indexing position first. Okay, imagine now I wanted to put this value number 2 at the indexing position 1. Already we are having yeah, we are I wanted to insert this 2 at the indexing position 1 now. After inserting, if I try to print, you can see I was able to print 1 4 3 1 4 3 2. I'm getting it right. So this is how it is getting it. So let's try to check whether this is working correctly or not, or if I have done any mistakes. So let's try to insert an element, that is a list dot insert at the middle. Okay, so I'm going to want to insert at the middle, that is a 2, and at the indexing position 1 over here. Okay, so if I execute now, we have inserted 1 0 1 2. Okay, it is not in 0, yeah, 0, it has to insert the element 2 and the position should be 1. It is not inserting basically. Okay, so there is some issue. Let's see what is an issue over there. So the issue was here I have given as a position minus I. Basically, I need to go till the I wanted to go, if there is a position, if I try to tell to go to that 3, I mean I need to go to the, basically I need to go to the indexing position 2, right? So for the position, I not to do with the minus I need to do with the minus 1 here. Okay, that is one of the issue. Now let's try to see if I just try to, after doing this, if I try to execute, you can see first I had 1 and I had at the 4. You can see after inserting the element 2 at the middle, 2 got inserted over there. So again, if I just try to insert at the another place, let's try to insert an element that is a 3 in the indexing position 2 now. I'm just going to insert the indexing position 2. So you can see I'll be getting as a 1 2 3 4 over here. You can see I was able to get the 1 2 3 4 over here. So it is going to be there. Now let's try to insert again. I'm just going to tell here as a specific list dot insert. I'm going to tell here as a list dot. I'm just going to insert at the beginning. I want to insert an element that is 0 now. So if I try to insert at the beginning 0, you can see the 0 has been added at the middle at the starting point of it. That is basically as a header node. So let's try to insert at the last node. Let's try to tell insert at the end. So I wanted to insert an element end, that is I'm going to insert the, that is a 5. So now the 5 has to come after 4 here. So if I try to execute the program, so you can able to see that is I'm going to have 0 1 2 3 4 5 over here. The output I am getting as a perfect. Okay, so this is how about the linked list, guys. I hope you got an entire overview of the linked list and we saw all the operations of the linked list. In the next session, we are going to see all the delete operations over there. Take care. Bye bye. Hello guys, welcome to the section 2, session number 8, the very important concept of linear data structure, that is queues here. So what is queue here? A queue is something, a concept of a data structure which follows the FIFO principle. FIFO in the sense first in, first out principle over here. So let's assume if you went to a specific movie and there are 10 people standing in a queue. So you would have heard about if there are 10 people is already standing, the people will be telling please stand in the queue. Please stand in the queue, right? So what is meant by that? Stand in the queue. That means whichever the person is coming first, he has to take the ticket and he is going to get evacuated. Then the next persons will repeat, so on. So that is what the meaning of queue. So in the real time, we saw please stand in queue, stand in queue, stand in queue. That is nothing but they are following a concept of data structure, that is the first in, first out principle over there. In this case, there will be a very two majorly jargon words that we are going to call rear or a tail or a back or a front or a head. So what is meant by rear or a tail or a front or a head? These are the two jargon words that is going to be used for following up the FIFO principle. It means in order to collection of an element where the additions of the new element is done at the one end, that is rear or a tail. So that means wherever we are going to add any kind of a new element, that specific position we are going to call it as a rear or a tail. And the removal of an existing element, and if you want to remove a specific element from the other end, that is going to be called as a front or the header part. This makes the queue suitable for the tasks that require for the processing element, right? It's basically help us to remove and add the element over there. These are the two major operations we are going to call it into the queues, that is NQ and a DQ here. So what is meant by NQ? NQ is basically tells like adds the items to the queue. So NQ is what? It's basically adds the item to the queue, and if the specific queue is full, imagine there is a queue is full in a specific queue, like imagine in the movie theater there are 300 tickets and 300 people are standing in a queue. Then imagine that means 300 tickets are available and there are 300 people can evacuate those seats. It means there will be, and the specific queue is full. That is, it is going to call this kind of situation, we are going to call it as overflow condition. The time complexity of it is going to be big O of 1 here. Imagine what is DQ. DQ is basically removing an item from the specific queue. That means we are just popping out the specific items from the queue in the same order how we have been inserted. Imagine the 10 people are going inside one in a line. The first person who came first, he will be going first. The second who came, then he will be going. Then keeps on third, fourth, and this way respectively it will be going on, right? Then what is front? Front is basically gets the front item of the queue here. What is meant by front? Front tells the which is the front item from the queue, which is standing front from the item from the queue. And a time complexity is going to be big O of n, and gray is going to tell which is the last item from the specific queue. That's the time complexity. Again, it's going to be big O of n over there. So if we take in this specific example, let's imagine this is your specific shop where the people have been coming inside a queue here, and you are going to be standing here, right? So let's imagine there are an element there are been getting inserted. Imagine there is an element that is a front or a head that basically holds your specific front or a head. What's the front or a head is going to store? According to the definition, the front is basically gets the front item from the queue, right? Who has came first, he is going to see who is the front item from the queue, and rear is going to tell who is the last item from the queue has came last over there. In this specific front item, one is came at the front, right? So it will be going to the front here, and second and third and fourth and the five, this is going to be queue, and these are the items that's come from the queue. So addition is going to happen at the NQ end, and the deletion is will be happen from the DQ end over here. NQ is basically tells who is the first specific element is coming inside from the queue over there, that is going to be there, and the second element who is going to come, and third, four, five. Basically in this specific way we are going to happen. So NQ is basically tells which is the specific elements are getting inserted over there. In DQ will happen who came first, he is going to get removed first, right? So that is how the DQ is going to happen over there. Okay, so let's understand better with an example over here. Coming back to my writing pad, let's imagine it's your shop here. Let's try to imagine this is basically if I zoom out here, this is going to be your SHOP shop, and imagine in this is your ticket counter shop, and we are having some tickets here. So imagine there is a person 1 came here, and there will be, and again there is a person 2, and there will be a person 3 here, and again he will be the person 4 here. So in this case the specific person came first, right? He will be coming first, and he will be going at the last over there. So in this case this P1 came first, okay, P1 came first and he is going last over. Again P2 came, again P3 came, again P4 came, and so on it happens over there, right? So he came first. Imagine if this specific person is coming first, he is getting get evacuated, then second person will get evacuated, then person 3 will get evacuated. So this is how the things will happen over there. So let's try to insert some kind of an values, and let's see what all the things is going to be there here. Okay, so first and foremost, in this specific size of what is the size, if I tell it as 0, 1, 2, 3, 4 and 5 and 6 here. So the indexing positions will be 6 here. And what is the size of the queue? Let's imagine the size of the queue is going to be the length. The size is going to be 7 over there. Okay, in this specific 7, now I wanted to apply some kind of an NQ operation and a DQ operations over there. So in this NQ, imagine we are inserting some kind of a data here, and we are holding it the values here. In this array, in this specific an array, I wanted to NQ and I wanted to delete it. I wanted to NQ and I want to delete. So basically if I imagine I wanted to insert the element here 1 here, I wanted to NQ 1, 2 here. Okay, I'm just applying the NQ operation here. So basically in the first condition there will be a something like a front. So front will be there. Okay, FRONT front. So front or a specific back. So front or a rear. I'm just going to make, I'm going to use front, means this is going to, you should take it is like this. I'm going to use it as a rear. You can use anything, front or a head or a rear or a tail. So I'll just tell in the first position front and rear is going to be, we are going to point it to the -1. Simply we'll tell it as a -1 over here. If the front and the rear is equals to -1, then means your specific queue is empty. Okay, if the specific front and equals to rear and is equals to -1, then we need to understand queue is, so I'm going to tell queue is empty. So we are going to tell the specific queue is empty. If it is queue is empty, it is going to be the underflow condition, right? It is going to be underflow condition here. Now if I want to insert an element 1 and a 2, so what happens when I try to insert this specific element 1 and a 2? So I'm just going to increment when I try to insert, right? When I try to apply the insert operation, when I try to insert the operation in this, what happened? The specific rear is going to get incremented. Rear is going to get incremented, or rear is, I'm going to tell rear is going to be incremented. This is what the basic algorithm we are going to use. Okay, rear is going to get implemented. Now if I just try to insert 1 and 2, basically 2 will be here and 1 is going to be here, right? 2 is going to be there, 1 is going to I wanted to tell like this. So basically 1 is been inserted, so rear is going to get incremented when I try to insert an element. That is 1 and 2. Basically imagine if I try to insert a specific element 1 and 2, how it is going to be there. It is going to get incremented, right? First basically it will get, rear is going to get incremented. I'm going to tell now rear is going to point it over here. R is equals to R plus 1. When I try to increment, R is going to come here, then R is going to be here. So imagine I'm going to make use of the red color here, okay? So let's tell now rear is going to be incremented over here. Then I'm going to insert the value. First I'll increment, then I'm just going to insert the specific value over there, okay? That is what it is going to be there, but your friend will be lying over here itself, okay? Then imagine I wanted to insert and again an element. Let's set an insert and again element. I wanted to include an element, and I'm going to tell here as a 3, 4, 5 and 6 here. I wanted to increment the again element here. So I'm going to tell here again the indexing point friend will be here itself. So already 1, 2 is there, right? So I wanted to insert an again element here, okay? So here basically when I try to insert 2 we have inserted, so basically it will be something like this, right? So here I need to tell like this. Basically it will be first an element will be here 1 and it will be 2 inserted, okay? When I try to insert 3, 4, 5, 6 over there. So what happens, this element will get shifted, right? So I'm going to tell here, let's imagine here will be 1 already will be shifted here, it will be 2. So first after 3 we have inserted, it will be here and it will be 4, and I have inserted the 5, then it will be 6 over here. So basically whenever I am trying to insert, so I'm just going to be like this, or rear is going to be here like this, okay? So then let's imagine I wanted to insert, and again, so here we are done the insert here. This is the first and this is going to the second case. Again I want to just tell here as a insert the element, that is a 7 here, okay? So already 1 will be get shifted here, 2, 3, 4, 5, 6, 7 will be inserted here. The front is going to tell who is the last element has been found, and this is going to be your rear, okay? This is going to be front end, right, which is all going to be inserted. So when I tell here that when is your specific element is going to be empty or a full. So when we said that the front is equals to rear, your q is going to be empty. When I can just in this condition I can just tell here as a q is specifically full full. I'm just going to write it very neatly because we are maintaining very neat structure here, right? Yes, so I'm going to tell your specific q is specifically, I can just tell full when your specific rear, when your rear is equals to size minus 1 here. So what is the size? Size is 7 minus 1, basically 6. So if your rear is at the indexing position 6, you can see my rear is at the indexing position 6 here. So it's just 6 and it's going to be a 0. Then you can tell your q is specifically full over there. Okay, this is how the things happens now. Now if I just try to remove an element, so basically nq is happening in this end. Basically in this case nq is happened at this end, and in this case the dq should happen from this specific end now. Now if I try to remove the element, basically now if I try to dq the operation, the first one will get removed, okay? So after removing one, suppose n1 will get evacuated. In this case what I need to do, in this case we need to do, when q is evacuated, I need to tell here whatever your front is there, right? In the case of deletion, I'm telling, in the case of deletion or dq, in the case of a deletion or a dq process, what will be happen? Front is going to be front plus 1 over here. The front is going to be what? Front is going to be front plus 1, and here rear is going to be what? Rear is going to be your this specific element. Rear is going to be your specific element. Let's imagine if I remove this specific element, so front is going to be pushed towards here. The front is going to come here, and rear is going to be there itself. Rear is going to be your back end. I'm going to tell rear is going to be your back end element, basically, okay? So once it is removed, this element will get shifted. 2 will come here, then 3 will be here, 4 will come here, 5 will be here, and 6 will be here, 7 will be there. Now rear is going to point for the previous element of it, okay? This is how happens here. Now imagine again if I just try to remove 2 element. Now I'm going to remove this 2 element. This 2 I'll be removing, and I'm going to remove this specific 3 element. So after this, again rear is going to, front is going to be front plus 1 for this, again front plus 1, 2 times it will shift. So front will be going from here to here. So front will be here. So after rear is going to be here itself. So I'm just going to tell here, and I'm going to tell here 4 is present, 5 is present, and 6 is present, and 7 is present now, okay? Now let's try to NQ again. Now let's try to add an NQ operation. I wanted to NQ an element, that is 8 here. So when I again if I just try to NQ an element, again I need to apply the same. I need to, whenever I'm inserting, I need to use rear is incremented. So whenever I incremented, rear should be get incremented, right? So what else? Sorry, the front should be decremented. Rear is incremented. In the other way, I can just tell the front should be also decremented, right? So I'm going to tell, okay, 4 will be here, 5 will be here, 6 will be here, 7 will be here. Now I wanted to insert 8 will be here, the front is going to be here, the rear is going to be there itself. Okay, for this, when your array is specific, in this case, when is rear is incremented, if your front and rear is equals to 1, at that case this will happen. In this case it won't happen like that. Okay, so this is all the logic we need to write it for writing the program. So in this, how this specific things happen, you can see whenever these specific things happen in this specifically, it is going to be happen over there in this way. Okay, this is how the things happen. So whenever the insertion will be happen at the enqueue process, and the deletion will be happen over here. Okay, when I delete it, all the element will get shifted in this process. If I just tell the time complexity is going to be big O of 1, if I try to apply the DQ, or if I try to apply the NQ, in that case it is going to be big O of 1 itself. When the shiftings happens, right, at that case it is going to be big O of n over here, because it needs to shift the elements and keep track of the front and the rear over there, right? So that is why the queue is going to be the queue is going to work in this specific way. Now let's imagine with the specific whatever we have seen about the queues, let's see the programmatical way now with the Java program. Okay guys, I have opened my Eclipse program here. So I'm going to create one specific new class. I'm just going to create a class by the name called as QUESS queues over there. I'm going to inherit the public static void main class. So once I have created, it will be like this. So I'm going to import the import java.util.classes inside the queue here. Okay. So once we have inserted, so let's write the specific program for it. So this very simple kind of a program, let's understand in the more clear way you will be understanding about while writing the program. So let's type it into it. So let's create a specific class. We are going to create a specific class by the name called as queue here. Okay. So this specific class is going to have a queue class. Now what I am going to do here is I'm going to initialize one maximum size of the queue. So we need to initialize what is the maximum size of the queue will be there. Okay. So imagine I'm just going to create a specific private static, and I'm going to tell as a private static final. It can be int of the specific. I'm going to tell as a max size as your variable name. I'm going to tell here as a max size is equals to, imagine I wanted to create the maximum size of the queue should be 10 here. Okay, this is going to be what your maximum size of a queue. So I hope you understand this, right? What is meant by max size is going to be your maximum size of the queue. I'm just going to write it, maximum size of the queue over here is going to be the maximum size of the queue, maximum. Okay, so then I wanted to declare other things, like I'm going to declare another private. So I'm just going to create one array. So it's going to be storing all the array data. I'm going to tell one specific int of array here. Then I'm just going to tell same way I wanted to initialize the rear and the front here. I'm just going to tell private int, that is for and initialize the front here. Then I'm just going to tell here as a private int, I'm going to initialize the rear, rear over here. Okay, basically it is going to be the front of the queue and is going to be the rear of the specific queue over here. So in that case, I'm going to initialize one specific constructor, that is public queue. So this public queue is going to initialize the array is going to be, that is going to be int or new int of maxes. I'm going to initialize the array. Okay, this is the array size should be maximum size whatever we have declared. Okay, this is going to be the maximum size of the specific array over there. Okay, array is equals to new int of max size here. Now first I'm just going to initialize the front and rear is going to be at the -1, right? So that is what we have said in the beginning. Front and rear we are just going to point it towards the -1. In this case, what is meant by this? In this case, your queue is empty here, right? In this case, the queue is empty. So I'm going to tell front is equals to -1, and I'm just going to tell rear is going to be -1 over here. So we have initialized the value for the front and the rear over there. Now I want to just create another method to check whether I'm just going to create one specific method to check the queue is empty or not. Queue is empty. So this method checks the queue is empty or not. So it returns the boolean value. I'm just going to tell it as a public boolean value is empty. I'm just going to declare one function called as is empty ty function, is empty method. So this tells whether your queue is empty or not. Whenever I call this specific method, it will return the value, that is what is the value of the front will be there. So I'm going to tell if the queue is empty only if the front value is equals to -1. Okay, I'm going to tell if your front is at the -1, if front value is equals to -1, returns true here. If the friend is not equals to -1, then it will return false. If it is matching this condition, it will return true for me. If it is true, then what is mean by that? It means your queue is empty over there. Okay, that is the method we are going to check. Now again, in this case, the condition will be underflow condition. So I wanted to check another method, that is the method to check if queue is full. Queue is full. It is going to be your underflow condition. So again, I'm just going to create a public method. Even it will be returning me the boolean value. So I'm just going to tell is full here. Is full method full. So this specific method is going to return, basically if it is returns what. So I'm going to tell return whatever your rare is there, right? Rare plus 1. Okay, again I'm just doing to the percentage of the max size. I'm just going to tell percentage of the specific max size equals to front friend over here. This is how the formula we are matching it here. The same thing what we have written it here. So you can say I've said you the size is going to be, here you can see the size is going to be full. The rare is equals to size minus 1, right? So if I wanted to get what is the size minus 1, I can just tell whatever the rare value is currently at that, just what I can divide with the maximum size. Imagine if your rare value position, imagine let's take an example. In this case your size is 7 and your rare is where? Your rare is at the indexing position 6 here. Your rare is at the indexing position 6 and the size is 7 here, right? So rare is at the 6 and the size is 7. 6 divided by 1, 6 ones are 6, it will be remainder will be 1, right? So in that, along with that, I am just going to tell equals to friend. So that means if it remainder is going to be what? 1, right? So in this case, let me verify this specific thing for you. Imagine in this case we said size value according to this formula, rare plus 1 max size here, right? What is the rare plus 1? Rare plus, what is your rare? Rare is value is present at the element 6. 6 plus 1 will be 7. So 7 divided by, what is your size? 7 divided by 7. 7 divided by 7 is going to be, remainder is going to be 0, right? So it will be 1 here. The value is going to be 1. The output will be, remainder is going to be, the quotient will be 1 and remainder is going to be 0. If the remainder is 0, equals to friend here. So what is the friend value? In this case, imagine if your array is full in this specific condition, whatever you are saying here in this condition, if your array is full, where is your friend is lying? Friend is lying at the indexing position 0, and whatever the equation we evaluated, that is the size plus 1, that is 6 plus 1 divided by 7, that 7 by 7 is 1, remainder is 0. 0 is equals to 0. In this case, I will be returning the value as full here, right? So that is what we are using here. You can see this specific condition we have verified. Okay, how to come this one, and we have written the correct one. Now let's try to add the specific. So I'm just going to add the enqueue here. I'm not going to write anything. I'm going to tell you as a enqueue. Enqueue means adding an element into the list. So I'm just going to tell here as a public. I'm just going to tell here as a public void. Doesn't written anything. I'm just going to write the method called as enqueue. EUENQ. So this enqueue basically takes the data, int of data. In this specific function, we are going to check first condition. If the specific is full, I'm just going to tell if the condition is empty or a full or like that. So I can just tell first if the specific is is full, is empty. Let's check an example. If it is empty, I'm just going to tell friend is equals to 0 over there. So okay, so if I'm going to tell friend is equals to 0. The same way, I'm just going to tell here the friend is equals to is if I'm going to tell if it is full. So I'm just going to tell if it is full. If your if condition, if it is full, I'm just going to tell it is going to be queue is full, cannot enqueue. I'm going to just write the brackets here. Okay. So I'm going to tell one condition. If the specific is full condition happens, I'm just going to tell here as a SYSOC. So I'm just going to tell in condition like I'm just going to tell queue is full. So your queue is FULL full. I'm just going to tell simply queue is full. Okay. If it is empty, I'll be telling empty value is going to be initialized to 0 over there. Okay, if this condition is also get satisfied, now let's try to add another condition here. So in this condition, let me put these things into the brackets so it should not collide anything. Okay, so if this condition, both the conditions are getting filled, then I'm just going to increment the value of rare. So that's what we have said in the formula, right? I'm going to tell rare is equals to rare plus 1, increment the rare value, and percentage with the max size, that's basically percentage with the maximum size, that's we have incremented, and whatever the array, whatever the empty array we initialize of the specific index, whatever the indexing position will be there you just add up the specific data. That's all we have said it, right? So that is a very simple code we have written it here, right? So that is what we said even in the writing time. And if it is not equal, just we'll increment the rare is equals to rare plus 1 and we'll increment the data into it. And friend will be remaining at the same place. We are not going to change the value of friend here. That is what we did it here. This is going to be for the element for adding it. So let's try to see another method. Let's try to add another method like if I try to add it in another method. So again, I'm just going to tell another method. So this method is basically for the DQ. So I'm going to mention as a DQ. DQ, you know, DQ is basically for the removal purpose. I'm just going to create another public method int of DQ. I'm going to tell int of DQ. So this DQ is going to take again a lot of argument. Again, it is going to take the same thing. I'm going to check either it is empty or not. I'm just while removing an element. First, I'm just going to check whether if it is empty or not. If it is empty, what I'll do here, right? I'm just going to, rather than making friend to 0, what I'll do it here, I'm going to just tell as a SO. I'm just going to tell here as a Q is empty. I'll just mention as a Q is empty empty over here. After that, I am just going to return -1. I don't want to evaluate the further loop. I'll just tell return -1 here. Okay, just save it. So if it is not evaluating, this condition is getting failed, then what I'll just tell, I'm going to initialize the int data is equals to from the array, whatever the front value will be there, I'm just going to remove it. So you know we are going to delete the from the another and DQ method. Whatever the front value will be taking the which is the specific first item has been inserted. It will keep track of the front. So whichever the data will be having array index data will be there. We are going to point at that specific data that we are going to evacuate it. Again, we are just going to check one more condition. If the specific front value is equals to rare. Okay, if this front value, imagine whatever the element you are removing from the queue, whatever the element you are removing from the specific queue, there is a single element. Imagine there is only one element which you are present into the queue. In this case, what you need to do, you need to evacuate it, then you need to make your front end rare should be equals to -1, right? That is what we are going to do here. If it is front is equals to rare, we are just going to make here a for int front is make it to the -1 and then make the specific rare is also equals to -1 over there. If it is not the condition, then we need to just simply decrement the value. We need to just increment the value of friend. If it is not the case, what we need to do, we need to just simply make the friend to the next position and we need to insert the value, right? Sorry, in a DQ, right? Okay, we are getting a message. The message, okay, we have not written anything, right? That's why. Okay, if it is a condition, we need to just increment the value of friend over there. Let me come back to the Eclipse. Yeah, so if this condition is done, if not, we'll just come back to the else condition. What we need to do, whatever the friend will be there, right? So we need to just increment the value of friend, that is a friend plus 1. Okay, and maximum size. That's why I'm just going to initialize the max size of it. That's it. This is going to be the friend plus 1. Now whatever it will be there, I'm just going to return that specific data. Whichever the data we have removed, this data will point that specific value. After doing this condition, we are just going to return this data. That's it. Okay, that's it. This is how the DQ operation is going to be there. So again, the same way we can understand which is the specific value is going to be at the top. So I'm just going to see which is the specific values present at the peak. Peak means the method gets the element of the front of the queue without removing it. Okay, it will just tell me if it is empty, it will tell the queue is empty, no element at the peak, or else it will tell which is the value at the present at the event, that is going to be the peak element. So peak is basically will tell which is the value is lying in the top of your stack. Okay, that is in your queue. Okay, that is what it is going to tell. So let's try to evaluate, let's try to execute this program. So now I'm going to come back to the public static main void. So I'm going to create one queue here. I'm going to tell one initialize one queue is equals to queue eq, that is going to be your new queue. Okay, that is going to be your new queue. We have initialized the queue here. So after initialization of the queue, let me enqueue it here. So I'm just going to apply the enqueue operation. Enqueue means I wanted to add some kind of an element here. I'm going to tell as a queue eq dot enqueue. I'm going to use the enqueue here. So I wanted to insert some 10, 20 and 30. So let me copy. I'm just going to insert 10, 20, 30. So I'm going to just tell 10, 20, and 30 here. So once I just submit this specific value, so once I just submit this specific program, I wanted to print what all the elements over there. So let me to print, where is it? Here, right? I'm just going to remove these extra spaces from here. Imagine I wanted to specifically pick what is the, I wanted to check what is your specific element is there into the peak over here. So I'm going to tell pick this specific front element. So now I wanted to pick which is the front element. So q.pick tells you which is the value present at the front. If I just execute, it should give me the value as what is the value I need to get. You can see it is going to give the element that is 30, because 30 is the element which has been inserted at the last. Okay, 10 is one who has come first, 30 is one who has coming at the last. So it is a front element. Peak is basically tells which is the value will be there at the front element. If I just come back here, which is the front element, you can see last element which will be inserted, that is going to be treated as the front element. Same way, if I just try to come back to my Eclipse, if I just try to see what is the specific DQ there, let's try to delete the element now. So I'm just going to tell now, I'm just going to delete the specific DQ element. So I'm going to apply the DQ elements over here. I'm just basically trying to remove the element from the queue. If I do this, system.order DQ element is equal to q.dq. That means I am applying the DQ method. It will tell which is the element should get popped out. When I apply the DQ method, the 10 should get popped out, then 20 should get popped out, right? If I execute, you can see I'm getting the DQ'd element is 30, the queue is empty, the QQ element is -1. Okay, so here there is some kind of an issue here. The front element is giving 30, that's correct. But when I try to DQ the element, basically it has to remove the element who has come at the first, that it has to give me the value 10 here, but it is giving the DQ'd element is 30, then DQ'd element is 1. Something it is giving me the wrong information here. Let's evaluate what is the condition, what is the changes we have, we need to do it here. So here we have just array of friend, we are doing it, that's friend whenever I apply the DQ method. So basically the problem is into the DQ here. So when I did tell DQ, first we are checking if it is empty, we need to return -1. If it is not, we are just getting the array of friend. If the friend is equals to rare, we are making it, or else we are making friend is equals to friend plus 1 and percentage with the maxes, and we are just returning the data. This is also correct. And if I just come back to the NQ here. So in the NQ operation, let's see. NQ is correct. Basically, if it is full, Q is giving full and empty for a 0. This is also correct here. Basically, all the things is correct. So I guess there is some mistake with the specific operation with our DQ here. So here we said in data array of friend value, if the friend is equals to rare, we'll do it, or else friend value is equal to friend plus 1 percentage with the max size here, right? So here it is giving me some error. Let me check what is the issue. So yeah guys, so basically that program had some issue. So what I did, I just tested over there. So let me create a new class. Again, I'm going to create a new class. I'll just make it as a use DSA. So I'm going to create a public static void main class here. So here I'm going to import the specific element over here. Let's try to import. I'm just going to import the java.util.star java.util.star over there. Okay. So once I import this, let's try to create one new class over there. I'm not going to type it. I'm going to tell you with the explanation over there. So let's create one specific public class over here. Okay. So let's create one specific public class q, and which takes the value of what is the size of it. So t is basically a kind of an array, and where we are having. So let's create normally a class here. Okay. So class is equals to q of t. So let's try to initialize the specific capacities of this. Like I'm just going to initialize the what is the array size, and what is the friend, what is the rare size, and the capacity. I'm keeping track of the specific 4 variables over there. Then I'm just going to check one more condition. So I'm just going to check create one specific class inside the queue. So I'm just going to tell here the queue class here that tells the which initializes the capacity of the queue. Okay, if I want to initialize for the 5, or I wanted to initialize with the 6, or like this, I can initialize it over there. So I can just add one specific annotation here, that is we have something suppress warnings. So if it is not checked, I wanted to check these specific things. Okay, that should be as unchecked over there. Okay, so like this. I'm just giving this annotation so that it will be initialize this specific capacity. It will run this specific constructor and set the specific t values to it. Okay, what is the size of the array? Then I'm just going to create one specific method for the add an element, that basically an NQ operation. So the same thing, we are just creating an NQ operation. Here we are checking the first condition. If it is full, we are checking an exception, that is a queue is full, or else we'll just use the same code, but we are using the size plus plus. Okay, previously it was having some issue with the max size, so we are just using this over there. Okay, then along with that, the same method I'm just going to copy that we have done for the removing an element. If the queue is empty, we'll throw the exception, or else we'll just remove the element from the element's front, and we are going to increment the specific front, and we are just going to make the size is equals to minus minus, and we'll just return the removed element. You can match with the previous code. It's exactly similar which we have done it, but we are just remodified the specific initialization of the constructor. Okay, then I wanted to add those specific method who's going to check what is the size of the queue and whether your size is full or not, if is empty or is full, or is what is the size of it. It returns this specific scenario. This already we have typed it, and I've just we revamped it over there. Okay, I'm just going to check another method, like which is the value that's presented as the peak. So peak value is basically tells which is the, if it's empty it will tell, or else which is the last element has been inserted, that is going to tell which is that is going to be your peak element over there. Okay, now let's try to initialize the values of the queues over there. So let me try to add some values over here. So I'm going to tell I'm initialize the queue object array. We are inserting 10, 20 and 30 over there. So let me try to apply the DQ operation over here. So I'm just going to apply the DQ operation. In this case, the element 10 should get removed, right? If I just execute the specific data, you can see the dequeued element is 10 because 10 was inserted first, so 10 is getting removed at over here. So if I try to again pop the element 10, if I execute now, you can see again the 20 is get popped out over there. 10 is get executed removed and 20 got removed over there. Now if I try to see what is the peak element, so now we are having an only one element, that is the 30, and even our last element also should be 30, right? So if I just try to execute now, the front element will be 30 now. What should be the size? The size should be basically 1 now. If I execute it over here, you can see the size is going to be 1 over there. So again, if I just try to apply the NQ operation, like I'm just going to tell here as 40, if I just tell it here as 50, if I just tell it as 60. So after that, if I just try to execute it, if I just execute, you can see now it is there. So now 3 element I have executed. After executing the 3 element, if I try to see what is the size of it, I'm just going to copy again. If I try to see what is the size of the queue, if I execute, you can see it is going to give you the size is equals to 4. Again, if I apply the DQ operation, if I try to apply the DQ operation, now where we are having a 4 element, if I try to execute it, if I execute, you can able to see here the 30 got removed first, then 40 is executed because 30 was inserted before 40, right? So 30 got removed, and again next element which was there, 40 got removed. Now all the operation is working perfectly and this code is working fine, right? So thank you guys. I'll catch you with the next session. Take care. Bye bye. Hello guys. Welcome to the section 2, session number 8.2. So let's discuss about the circular queues into this session. So let's begin with the specific writing pad. So coming back to my writing pad here. So let's take an example into one specific circular queue over there. So what is meant by circular queue? So the name itself saying the word that's called as a circular, right? That means we are having something to a cylindrical, like kind of a circular kind of a thing. So which is going to point towards the first node kind of stuff, right? So let's take an example. Let's take this is your example in normal queue. So let's try to insert some values here. 2, let's insert 5, 8, 10, 15, 25 and 30. So we're inserting some kind of a values into our circular queues over here, right? So if I just try to do this one here, it will be going to be your front here, it will be there, and it is going to be your rear inside if you take an example of a queue. So let's try to imagine, let's write an example, let's try to imagine I wanted to delete some kind of an elements here. So I wanted to delete some kind of an element. So who has been inserted first, that specific element will be that is going to get deleted, right? So first will be it will get deleted, and imagine the next there will be 5 will get deleted, and imagine next 8 will get deleted, then 10 will get removed, then 15 will get removed, then 25 will get removed, and then 30 element will get removed over there. So in this specific case, at specific scenario, there will be something, there will be front and rear is going to point at the same position. The front and rear is going to point at the specific same position. Suppose if I want to insert anything, suppose let's say if I want to insert in some kind of a thing here. So I was like doing something like this, right? So imagine we had something, let's take an example. Let's take 2 example here. So we had 1, 2, 3, let's tell 2, 3, 4 and 5. 5 was inserted 5. It was removed, then we were shifting all the elements here, right? Like 4, 3 and 2. So we were shifting, this box was empty. Then again we were doing something like if 2 was removed, 3 and 4 was there. Then 3 was removed, then only specifically there will be 1, 2, 3, 4 was there. Then all the elements were removed. So then it was something like front and rear is going to point at over here. Suppose in this time, if I wanted to insert something, I wanted to shift this specific front to the, I need to specifically reset. I need to just do what? I need to reset Reset the specific front. Okay, then I need to reset the specific rear to what? To -1, right? To -1, we need to reset it. So this was the demerit when we were talking about the queues. This was the demerit was happening. We were taking the kind time complexity of big O of n over here, right? So it was taking a time wasted. So basically, in this specifically, the space was getting wasted here. The space was getting wasted. Okay, this was the space was getting wasted in the normal queues. So they have come up with the concept of the circular queues over here. So we have one specific formula which we are going to evaluate, and based on that we are going to do. So let's take an example. I is equals to I plus 1 and percentage divided by the specific size of it. Okay, so I'm going to tell modulos of the specific size. This is a formula which we are going to evaluate for circular queues over there. Okay, let's take an example over here. Like imagine we had an elements. Let's take here we had some elements, right? That given here as 1 2 3 4 5 6 7. So we had element 7 over here. So once all the elements were remitted, so if the 7 was getting removed and all the things was getting shift, and at last imagine there was only one at the last element. Let's take an example. We were removed this and we were removing this, removed and removed, and only the specific element 1 was there. So in this case, even if I remove, so basically we were removing from here, right? So after removing all the element, our rear and front is going to point at the same position. So in this case, whatever the element we are having here, this was getting wasted here. Wasted space. This was the wasted space. So in that case, what we need to do, we need to have to apply the concept of the reset. So where we will make it r is equals to -1, front is equals to -1. So this was the thing we were happening. So this won't happen in the case of a circular queue over here. Now circular queue, what we are going to do, let's take an example. This indexing 1 0 1 2 3 and 4 and the 5. So imagine this is your size. This is basically is your index here. So let's take an example. We have an element something here as 2. Okay, then we had here as a 3 4 5 6 over here. Okay, if we have an element 6 over here, we had an element 6. Suppose if your front is if your specific rear is over here, and imagine your front is going to be there here. So imagine I wanted to insert. Suppose I wanted to insert the element 9. So I was inserting the element 9 here. So the rear was getting removed. So rear was going to point it over here, right? So now after that, in this case, the circular is full here. The specific thing is getting full here. Suppose if I want to remove some kind of an element here. Suppose I wanted to remove some kind of an element. If I just remove, so the first value which was inserted, that will get removed. So 2 will get removed. Let's example, I wanted to remove 2. Then I wanted to remove the specific element 3 over there. Okay. So now what I'll do, so this in this case, the front is going to lie out over here. Now the front is going to be presenting over here. So in this case, these two specific specific memories are empty now. So now what we are going to do, we are going to use this kind of a formula over there. This is the formula which we are going to use it over there. Okay. So what we'll do, so I is equals to, so what is your rear value? Rear position is 5, right? So I'm going to tell rear indexing position is 5 and plus 1, that is going to be 6, right? So it is going to be 6 here. So basically rear is 0, 1, 2, 3, 4, 5. Okay, this is the 5. And what is the value of your specific size? If I tell here as a size 1, 2, 3, 4, 5, 6. 6 is your size. If I tell I is equals to 6, so it is going to be 6 divided by 6. Basically, we are doing here as a modulo operator. 6 divided by 6, the remainder is going to be 0. So at the 0th indexing position, we need to insert the value now. Suppose imagine I wanted to insert a new element that's called as 22. I wanted to insert a new element 22. So based on the rear formula, what is the rear indexing position? We'll use this formula, and whatever the specific indexing position it gives, it will be empty, right? So if it is empty, what we'll do, we'll insert the value to the 22 over here. Same case now, this is full. So now imagine this is full. I wanted to insert again. I wanted to specifically insert an element 30. Okay, now what is the rear position? So now rear is going to point at the here. The rear position is 0 plus 1. The size is 6 here. So if I just tell here as a 1 modulus 6. So in this case, if I cannot divide the numerator with denominator in the modulo operation, whatever the numerator value will be, that is going to be the final output. So at the indexing number 1, we need to insert the element that is 30. So we'll be adding over here. So this case, the things will be keep on going on, okay, even if it is there. So in this case, we are saving the specific memories over there, okay. So this is how the space will be used efficiently here. So I can just tell here, the space will be used efficiently over here, okay. This is what this final outcome I can give it for the circular queue. Thank you guys. I'll catch you with the next session with the double-ended queue. Take care. Bye bye.
Hello guys, welcome to the section 2, session number 8.3. So let's discuss about the double-ended queues over here. So what is double-ended queue? We know what is the queues and we saw about the circular queue, and even now we are going to look onto the double-ended queue. So let's look up with a specific example. So coming back to my notepad over there. So in this example, let's take an example. We have an queue here. So let's take an example. We have some queue here, 2, 3, 4, 5, 6, 7, 8. Okay, in this case it is going to be your friend, and it is going to be your rare. Okay, this is going to be your friend and it is going to be your rare. And in this case, imagine we are having some kind of a data, so where we are having some this is basically, it is specifically the queue is full here. So in queue we are having some agenda, right? So from rare we are going to insert, from friend we are going to eliminate the specific element. So this is the things that comes into the queue, but double-ended queue. So I'm going to tell here as a double-ended queue. So I'm going to mention here as a DEQ. So they are having some kind of a property. So it does not follow FIFO structure, not FLOW, follow FIFO. So what is first in first out structure? It is not going to follow it over there. Okay, it is not going to follow the first in first out structure. And imagine the insertion. So in the specific insertion is there, right? It can be happen into the rear, and deletion, we know normally insertion happens with the rear and deletion is going to happen at the front. Okay, this is what we have been learned so far. Insertion will happen at the rear and deletion is going to happen at the front here. But in specifically in DQ, if I just talk about the DQ, DQ is double-ended queue, not DQ. Okay, double-ended queue. Don't get confused with this. Okay, so I can write it the full name itself. In the specific double-ended queue, so we can just mention here whatever the insertion is there, it can be happened with the rear, it can be happen with the rear, or even it can be happen with the front. It can happen with the rear or it can be happen with the front as well. Even deletion, if we talk about the deletion, even it can be happen from the rear, and even it can be happen from the front as well. Okay, so here we are having a two types. Here having some kind of a two types. Here we are having two types of the double-ended queue. What is the type number 1? So the type number 1 here is a restricted. So I'm going to mention here as a restricted input DQ. Okay, double-ended queue. Okay, DEQ, I'm going to write it, restricted input double-ended queue, and we are having restricted output double-ended queue. So if we talk about the restricted input double-ended queue, here the insertion from the front is not allowed. So when you are using this methodology, insertion, I'm going to write here as a insertion from front is not allowed. Okay, I'm just going to tell insertion from the front is not allowed over there. Okay, so if we talk about here, deletion from the rear is not allowed. So I'm going to tell deletion from the rear is not allowed over here. Okay, so this you can have a note on it. Okay, this is about the double-ended queue. So imagine if I take a look at a real-time example. Okay, so imagine there is a one specific theater. This is a ticket counter. Okay, so there are a few people standing in the queue. So imagine there is a queue 1, 2, and 3, and 4 people are standing here. So some 2 people are coming. So there are some kind of a we can just tell there are some kind of a we not a normal people. Okay, so they have habit of just coming at the center. This person, what he does, simply he will directly jump from here to here. Okay, he will be jumping from here to here, and this person will jump from here to here. Okay, so what happens, this person is coming directly, he joined and he came over here, and this person is standing here, and there is another person, he is a good person, right? He is a good person. So what he did, he will just come and stand at the proper place over here. So in this case, we can see the insertion is not happening properly. Sometimes it happened at the middle, sometimes it happened at the rear, sometimes it happened at the front, like that, right? So now what happened, this person directly jumped, he took the ticket and he just evaporated, right? In this case, he came, he went. So in this case of queues, we can call it as a double-ended queues over here. Okay, so this is how the things happens in the double-ended queue. Okay, the concept will remain same, but the concept is the whatever coding part will be there, that is going to remain same, but the majorly we talk about the queues. And I wanted to give you an understanding. There are a circular queues as well and a double-ended queue. So we have seen the specific two theoretical part into these sessions. Okay, I hope you got this specific entire overview on queues. Thank you guys. I'll catch you with the section number 3. Take care. Bye bye. Hey guys, welcome to the section 3.
So let's discuss about the sorting and searching algorithms into this section. And this section is going to be an amazing section. So where we are going to learn about how to sort a specific values from a given array. And we are going to see the different methods of it. And along with that, we are going to see apply the searching algorithms. So we are going to see what all the sorting and searching algorithms are present in data structures. And the first specific concept, we are going to look onto the bubble sort over there. So basically, what is meant by sorting over here? So let us take an example of an array if you want to sort it. So there will be different methods, right? So like you can sort one by one, or you'll apply some kind of a logic and you are going to sort it, kind of a things. So basically in this specific sorting, we are having like bubble sort, we are having it, insertion sort, we are having selection sort. So we'll discuss one by one very neatly over there. Bubble sort is basically compares the two adjacent elements. Okay, like one or the another adjacent element it is going to compare, and if it is greater than, it is going to just swap it, and this will be going to be applicable for the entire specific list. But it is not a good practice for the large number of element. Again, we are going to look onto the one by one very neatly, but just for your understanding, just have a definition like swapping the adjacent element. Insertion sort is basically like insertion sort final builds the final sorted list one item at the specific time. So basically what we are going to do at the insertion sort, we are going to add one specific element into the list and remove the element from the list by the correct position, and it performs the specific partially sorted list over there. Okay, so we'll see how it works basically. And we have some kind of a selection sort as well. So we'll see what is selection sort as well in the coming session. Just understand is all the sorting algorithms are there, and we have a very good sorting algorithm, that is the merge sort and the quick sort and the heap sort as well we are having it. Okay, so that takes an specific concept divide and conquer, and much better than the other algorithms over there like a bubble sort, insertion and a selection. The quick sort and merge sort is going to be a better as per the specific scenario. Okay, and we have a specific heap sort as well. So then these are the sorting algorithms. So let's begin with the specific first algorithm, that is bubble sort over there. Okay, so coming back to my specific noting pad over here, I'm just going to expand these stuffs. So let's take one example over here. So let's take an example of an element. So here I'm just going to take an example like 7, 6, 4, 5, 3 and 2 over here. Okay, so this is the specific algorithm which we have taken. So we have 7, 6, 4, 5, 3, 2 we are having it. We need to just sort this specific numbers in the array. Just imagine this is your array and we need to just sort this specific array now. So this is the first thing. So first what we are going to do here is we are going to create one kind of a pointer, like we are going to swap the two adjacent element, right? So we are just going to swap this first two adjacent element. We are just going to compare. If it is greater, the first element is greater than second element, then we are going to just swap it over there. So once I just compare, okay, 6 is greater than 7, so 6 is going to come, 6 is lesser than 7. So 6 is going to come at the left hand side, 7 will be there, and 4 will be there, 5, 3, 2 as it is will be there. So now the pointer will be lying here. I'm just going to swap these two things because 7 is greater than 4, right? So I'm just going to swap 6, 4, 7, 5, 3 and 2 over here. Now the pointer will be lying here. So I'm going to compare these two elements. 7 is greater than 5. Yes, 7 is greater than 5. So I'm just going to swap this. So 6 will be already here. So 4 will be here. 5 is going to come here. 7 is going to come here. 3 is going to be there as it is, and 2 is going to be as it is. Now the pointer will be lying here. So it is greater than, yes. Yes, this is also greater. So again, I'm just going to swap it over there. So before swapping it, I'm just going to copy this another thing, like I'm just going to keep the another copy of this specific box. Okay, fine. So once I'm just going to do here, so I'm going to tell again. So as it is, like I'm just going to tell this is going to be like this. So I'm going to tell here as a 6 will be there as it is, 4 will be there, 5 will be there. So 3 is going to come here, 7 is going to get swapped, and 2 is going to be there. So now I'm just going to swap these two elements because 7 is greater than 2. So now the first specific loop is completed. So I'm going to swap this 3 to 7 over there. Okay, so now we have reached the last element. So this is entirely, we can just call it as a one specific loop over here. This is a one specific loop which we have done. Okay, so until and unless all the elements are not get sorted, we need to keep on applying it. Okay, if the adjacent elements are not greater than the previous element, right, then your specific array has been sorted. Okay, so this is how the specific things works. Now let's begin with the second iteration over here. So in the second iteration, let's take an example of the last one. So this we have a 6, 4, 5, and we are having a 3 here, we are having a 2 here, we are having a 7 here, right? So I'm just going to tell again. So I'm going to just swap it here because 4 is lesser than 6. So 4 is going to get left, 6 is be here, 5, 3, 2 and 7. Okay, so now 6 is greater than 5. Yes, just swap it. 5 will come here, 6 will be coming here, 4 will be as it is, 3 will be as it is, 2 will be as it is, 7 will be as it is. Next here, so 6 is greater than 3. Yes, we need to just swap it over there. So once we just swap it, so I'm just going to create another box here. So I'm just going to paste it here or here. I'm just going to tell 4 will be coming here, the 5 will be as it is. So 3 is going to come here, 6 will be here, 2 will be here and 7. So 6 is greater than 2. Yes, swap it. So I'm going to tell here is a 4, 5, 3, 2, 6 and 7 over here. Okay, so this has been getting swapped over here. Now 6 is greater than 7. No, 6 is not greater than 7. So it is no need to swap and it is the last element. So this is going to be your last row, last iteration for the second specific row over there. Okay, so now let's begin with the third specific row over there. Okay, in the third I'm going to copy the last element here. I'm going to take it here as a 4, 5, 3, 2, 6 and 7 over here. Okay, so last two element has been sorted over here. I'm just going to compare here. 4 is greater than 5. No, it is lesser than 5 is greater than 3. Yes, it is there. So we need to just swap it over here. Okay, these two elements we need to swap it. So 4 will be as it is. 3 we need to come here. 5 will come here. 2 and 6 and 7 over here. So 5 is greater than 2. Yes, just we need to swap this one. So 4 will be there. 3, 2, 5, 6 and 7 over there. Okay. So now 5 is greater than 6. No, 6 is greater than 7. No. So this has been swapped over there. So now let's take the fourth iteration over here. Okay, let me take the specific fourth iteration. So I'm just going to keep it aside of this. Okay, let me keep it more clean. I'm going to terminate it as a control X. So I'm just going to paste it over here. Okay, let it be. I'm going to paste 2 or 3 times. Okay, so let's have a 3 times for this. So I'm just going to tell here this is going to be there. So I'm going to just little bit. I'm going to make it a little bit at the bottom. Okay, so now this is going to be the fourth iteration. So let's take an example. This is going to be your fourth iteration now. Okay, so in this I'm going to take the previous of last 4, 3, 2, 5, 6 and 7. Okay, yeah, so now we are going to see 4 is greater than 3. Yes, it is greater than. I need to swap it. So 3 will be coming, 4 will be here, 2, 5, 6 and 7. So now 4 will be greater than 2. Yes, we need to swap it. Okay, so 3 will be there, 2 will be coming over here, 4 will be there, 5, 6 and 7. So this is the last iteration. You can see 4, 5, 6, 7 is already sorted. Okay, now we need to stop it. So let's see at the fifth iteration over now. So in the fifth iteration, basically we are having an element. Now we are having an element for 2 times. So whatever the last elements are there, just take into the box. So I'm just going to take the last element into the box. So in this, I'm just going to tell something like 3, 2. So whatever the last element we are having a 3 here, right? We're going to tell 2. We are going to tell here as a 4, 5, 6 and 7. So just compare 3 is greater than 2. Yes, we need to swap it. So 2 will be coming here. 3 will be here. 4, 5, 6 and 7 over there. So now to talk it about here, you can see now all the things have been sorted. So once it is all the things has been sorted, we need to stop. So here we are going to stop the specific loop. So it took 4 complete iterations, and inside the 4 complete iteration, it took some number of iterations as well, right? So this is how we have been done. So we have been started from here, and it is if I want to sort 7, 6, 4, 5, 3, 2. So it is going to take almost 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 iterations it is taking, 19 loops it is taking it over here. So for this only 6 element it is taking 19. Imagine if there is a large number, so at that time it is going to take more, right? So parallelly if there is something, so it is taking a square of it basically, right? So if there are 2 element, it's taking like a 2 to the 4. So that is why the time complexity. If I talk about the time complexity, so if I talk about the time complexity of it, it is going to be big O of n square over there, because it is taking the n square times to perform the sorting over there. And we talk about the space complexity. If I talk about the space complexity, in this space complexity is good because we are just using one specific array, so it is going to be big O of n over there. Okay, big O of 1. This is of the space and time complexity for this specific bubble sort over there. I hope you understood with the example, and we have seen about how the things is going to be there. So now let's understand with the specific example with the Java program over here. So coming back to our Eclipse, I'm going to close this and let's take the same example and let's come back to the Eclipse over here. In the Eclipse, so we are going to create one new specific class for this. I'm going to create in the GUVI DSA. So we are going to create one new class here. So the class name, I'm just going to keep it as the bubble sort. So let's see, little bit it is getting stuck. Okay, so you can see we'll just create. Okay, so let's create a new class. Right click and click onto the new. I'm just going to click onto the class. So I'm just going to give the specific class name as bubble sort over there. Okay, so okay, so I'm just going to create a public static void main. I'm just going to click onto the specific finish over there. Okay, so it is going to create the specific bubble sort class over there. Now let's see how this specific program is going to be there for the bubble sort. So coming back to the program coding part over here. So we need to create one specific array and we need to store some kind of a value and we are going to pass it over there, right? So that way we are going to write it over there. So let's try to create one specific class here. So I'm just going to create one specific class. So let's create something called as okay. So I'm going to create something called as a public static void. Okay, I'm just going to create it the specific public static void, that is a bubble sort. So bubble sort over there. Okay, I'm going to tell bubble sort as the specific thing. So this takes some kind of an argument, like it takes the array list over there. So I'm going to tell int of arr array it is going to be taking over there. Okay, this is going to be taking the array. So in this specific, I'm just going to initialize the length of the array. So whatever the n is equal to, the will be like I'm going to store the value. What is the array length here? Whatever the array I'll be passing as an input, I'm just going to store the length of it. Okay, I'm going to just store the length of the specific array over there. arr dot length, right? Length, not ht. Array dot length over there. So once we store the array dot length, now I need to run the specific loop over here, right? So I need to run the, basically we are running the two loops over here. If you see in the example, we are running the two loops. This is going to be one loop, so one second loop, third loop, fourth and fifth loop. And inside one loop, there are a number of iterations, right? Same way, we are going to run the main loop here. So for int, I wanted to run for a number of elements over there. If there are 5 elements, I can have a main file loops, I can run it, okay? So I'm going to tell int I is equals to 0, start with I, and I value should be lesser than the value of the array length. Okay, array length minus 1, then increment the loop over there. So inside this, I need to run another inner for loop over there. I'm going to tell int of for, I'm going to tell for int of j is equals to 0, start from j is equals to 0, and j value should be, j value, whatever the j value is there, right? J value should be lesser than n minus 1 over there. Okay, basically the n value is 5 minus 1, 4 times it should run. Okay, inner loop it should take 0 1 0 2 0 1 0 2 0 3 like that. Okay, so j value should be lesser than n minus 1. So along with the n minus 1, I need to minus with this 0 also. Okay, I need to minus with the 0 as well. So I'm going to do n minus I minus 1 over there. Okay, this is how I'm going to write the loop over here, and I'm just going to increment the j value over here. So inside this inner for loop, inside the specific inner for loop, we are just going to swap it, right? So first, before swapping, what we are checking? We are checking the two element, whether it is greater or lesser, like that. I'm going to tell if the specific array of j, okay, if the specific array of j, the inner element is greater than, is equals to, basically if it is greater than array of whatever the next element, the next adjacent element, if I want to get the next adjacent element, starting will be 0, then it will be 0 plus 1, right, for comparing the next adjacent element. So it is going to check like this: if array of j is greater than array of j minus j plus 1. So if these conditions get satisfied, so I need to just apply the swapping. Now I'm just going to tell here as a, we need to just swap. So we are going to swap. First I'm going to store one temporary variable. So I'm going to create one int temp is equals to array of j, whatever the value of the array of j is there, right? Whichever I need to swap, I'm just going to store it into one temporary variable, and I need to just swap it. So I'm going to tell whatever the element is present inside the array of j, just make it as a array of j plus 1, whatever the next adjacent element is there, right? That next adjacent element, store it into the first element. Okay, array of j. Just if I mean to say, if there is a 6 of 7, 6 store it into here, and 7 we need to store it here. So before 6 I'm just storing into the adjacent, and 7 I'm storing into the temporary. From temporary to I'm going to store it back to the next element. That is the logic we are writing it here. Then whatever the value of whatever the value that's present in temporary value, so that I'm just going to store it into the adjacent element, that is the array of j plus 1. So I'm just going to tell temp over here. Yeah, array of j plus 1 is equals to temp over here. So this is going to be your logic of it. Okay, so now let's try to execute the code by giving an inputs. I'm just going to tell here as an int of, so let's try to give the array here is equals to, so I'm just going to write this specific loop over here. So let's try to give an example here. Let's try to give the same. Let's try to give the same 764532. Okay, so I'm just going to tell here as a 7 comma 6 comma 4 comma 5 comma 3 comma 2. So these are values we are giving for the array here. The initialized, and we have initialized it. Now we are going to say syso system dot sort out dot println. I'm just going to tell here as a original array. I'm just going to tell here as a original 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 array is. I wanted to print the original array. I'm just going to tell here as a plus whatever the array concept. So I'm going to tell arrays dot toString method. Okay, so I'm just going to tell array dot toString method. Here I'm just going to pass the specific array. You can see it is imported the java.util array directly. Okay, so this is the original array, whatever the array we are seeing it here. So the toString method we are doing to get the data. So after that, I'm just going to apply the bubble sort here. So I'm just going to call the bubble sort method, whichever we have written it. So in this bubble sort, I'm just going to pass the array whatever we have initialized and declared it. So after sorting it, it would have been sorted now. So I'm just going to tell it as a sorted array using bubble sort. Okay, is should be. So in this, I'm just going to tell array dot toString method, array dot toString method. I'm just going to pass the whatever the array will be there. Okay, so basically what after for sorting it, what happens after sorting it, it is just going to change the original value of the array. That's it. Okay, now let's try to execute this specific program. When I execute the program, if I just show you in the terminal, you can see original array is 764532. After sorting using bubble sort, you can see 2 3 4 5 6 7 over there. So this is how the bubble sort algorithm works. This is algorithm, and even we saw how the working procedure of this specific algorithm of a DSA that is going to work. So when you talk about the time complexity, as I said, right, the time complexity is going to be the worst case scenario to sort this specific array in a descending order. In a case every element needs to swap, right, every element need to be swapped in each pass, hence the time complexity is big O of n square over there. Okay, this is the worst case scenario. Okay, and space complexity is going to be big O of 1. Why? Because it means it's going to take only one additional space for swapping it and for storing one temporary variable, so that's why it is taking big O of 1 over there. Okay, that is how this specific algorithm works. Thank you guys, take care, bye bye. I'll catch you with the next question. Hello guys, welcome back to the section 3, session number 10. So let's discuss about the selection sort into this session over there. So what is selection sort? Selection sort is basically finds the very smallest element in the specific iterations whenever it, and if it is small, and it is going to swap it with the next current element into the specific position over there. Imagine there are 10 numbers. In the 10 numbers, it is going to run a loop where it is going to find which is the smallest number. So after finding the smallest number, it is going to get that number at the left hand side, and it is going to swap the next all the numbers to the right over there. It's very simple from the current position. Okay, and it has a very simple implementation, but not sufficient for the large list over here because its time complexity is big O of n square here as well. So how it can be? You can see worst case scenario in the selection sort make roughly n comparison. Basically, it makes the n comparison, right, for the element n minus 1 comparisons. So for the second element, n minus 2 comparison it will do, and for the third it will be doing n minus 3, and keep on going with the. So basically we can tell the formula n into n minus 1 divided by 2 is the comparison. So when we evaluate to this formula n into n square, we are going to get it, right. So basically this is going to be the worst case scenario for the specific selection sort, and it is not a good practice to use the selection sort. So if it is small, it is fine for the very small elements, but if the elements are large, it is not a good practice to it. Okay, even if you take the average time complexity, even in this case also it is going to be big O of n square, because it is going to roughly, it will make the selections sort basically from the n square comparisons over there. Okay, in the best case scenario, if we talk of the selection sort, is also n big O of n square. Again, if we talk technically, it is also a worst itself, right. So even if the input is already sorted, okay, if the input is already sorted, again and again we need to sort this specific again and again we are going to run a loop for it, again we are going to sort it over there, right, for using the algorithm whatever it is there. Okay, so that is why this is not a good practice to use it, but for understanding we should know how this specific selection sort is going to work. So let's look up with an example over there. So coming back to my pad over here, so let's take an example over here. Let's take an example here, a very simple example. I'm just going to take it. So let's imagine we are having an element 807, and I'm going to have it as a 1 3 and 2 over here. Okay, so we are having 807 1 3 2. So if I take an indexing position, 0 index, first index, second, third, fourth, and fifth over here. So here they are going to draw one specific line here. So I'm just going to draw one specific line over here. So this is going to be the one specific line. So we're using this specific line, we are going to sort it over there. Okay, so we are going to sort it over there. So this is how these specific things will work. So first I'm just going to take one specific, if we are going to run one specific loop here. So after I'm going to compare 8 is greater than 0. Yes, it is greater than 0. So this is going to be mapped over. It is going to be swapped here, right? So it is not going to swap. Basically, it is going to point it here. So again, this specific element will check with the other element. With 0, it is going to check with 7. 0 is smaller. Again, 0, it will check with 1. 0 is smaller. Again, 0, it is going to check with 3. 0 is small. Again, it is going to check with 2. 0 is small. So now we found the which is the smallest element. So once we found the smallest element, we are going to shift that element over here. And after shifting it, we are just going to draw one specific array, like this line we are going to draw it. And after that, whatever the element we are having, we are just going to shift towards the right. 8, 7, 1, 3 and 2. Then again I am just going to map it. I am going to create one pointer. 8 is greater than 7. Yes, it will point here. 7 is greater than 1. Yes, 7 is greater than 1. So it is going to point to the next smallest element, that is 1. Okay, again 1 is going to check with 3. 1 is going to check with 3. 1 is lesser. 1 is going to check with 2. 1 is lesser than. So 1 is going to get swapped now. No, 0 will be there. So 1 is going to get swapped. Again, there will be a line. Let's take divider here. Then whatever we are having element 8, 7 and 3, 2. So again, it is going to check the next smallest element over here. So the next smallest element, if I just check here, so it is going to be 2. If I just apply the same formula, the next smallest element is going to be 2. So it will be like 0, 1, 2 and divide the specific things. Then we are having 8, 7 and 3 over here, right? So 8, 7 and 3 over here. So next same thing we need to do it over here. So in the next case, if I just take it an example for next case, so it will be having 0, 1, 2. Next we will be getting as a 3. Again we'll divide it 9. So when we'll be having a 8 and 7 over here. And for the last iteration, so we are going to get the value like this. So we are going to get the specific value like 0 we have, 1 we have, 2, 3 and 7. And we'll be having divider at the here and we'll be having 8 over here. Then this is going to be the last element. So the final array will be 0, 1, 2, 3, 7 and 8. So this is how the specific selection sort is going to work. So the time complexity is going to be big O of n square over here. So the worst for the best for the even for the average, this is going to be applicable over there. Okay, so because it is going to take the n into n minus 1 iterations, so divided by 2, if it's evaluate n square minus n divided by 2 over there. Okay, so maximum swap will be max swap is going to be n minus 1 over there. That is why selection sort is. So we can just come to this conclusion. Selection sort is not suitable over here, not stable. I'm going to tell selection sort is not going to be stable over there. Okay, so now if you take an example how this specific programmatically it is going to work, let's see with that. So coming back to my Eclipse part over here, so I'm just going to create one new class for it. So I'm just going to create a new class. I'm just going to make it as a selection sort. Okay, I'm going to create the public static void main. So from this, I'm going to copy some kind of an information. I'm going to copy the same specific numbers over there. Okay, I'm just going to copy the same stuffs. I'm going to copy this. I'll just come back to the selection sort. I'm just going to paste it over here. So in this, I'm just going to tell here as a selection sort. Okay, I'm going to tell as a selection sort is the function name, and here I'm going to just keep the same. The rest of the things is going to be same over here. Static void is going to give the same name, that's a selection sort. That takes the int of the array, and let's see very small logic, not an big over here. So I'm just going to take the again sum that is going to tell n value is going to be array dot length length. We're just going to store the length over here. Then we are going to run the loop that takes the int I is equals to 0 and I should be lesser than n minus 1 and I plus plus. It has to traverse to this specific element. Then again we are going to create something like we are going to create one min index. What is the minimum index? Okay, so int of the I'm just going to tell as a min index value. I'm just going to take it as a I value. Whatever the I value will be there, that is going to be the minimum index. Okay, that is going to be that. So once it is done, then we are going to run one inner for loop. So where we are going to check where j value, int of j value should start with the I plus 1. But basically I value 0 plus 1 start with the first indexing position, and that j value should be lesser than n and it should be j plus plus over there. Okay, then after that we are just going to check the condition. If the specific array of j, if the array j specific key equals to array of min index, whatever the min index we are storing, right? So we are checking with the every scenario, right? That's why we are storing the min index over here. We are going to tell array of j is lesser than array of the specific min index over there. If this condition is getting satisfied, what we are going to do? We are just going to change the min index value. We are just going to change the min index value to j. Okay, if it is lesser, we are just going to change it to the j value over there. Okay, this is how the things is going to do. So if this is going, we are going to change it into this way. So after this specifically, we need to just swap it. So once we found the specific smaller element, once we found the specific minimum element in from the min index, what we are going to do, we are going to swap it. That will be same. That's how we have been used for the bubble sort. So I'm going to tell int temp is equals to int array of min index. I'm just going to store the array of min index value into a temporary variable. Then I'm just going to tell array of specifically min index is there, right? So for that, I'm just going to store it as the array of I value. Then I'm just going to tell array of I, just store it as the whatever the temp we have, just store it into it over there. So once we do this, and if I execute the program, so we can able to see the specific program will be executed. Original array, if we take 7 6 4 5 3 2 1, even the sorted array using the selection sort. I'm just going to tell using selection sort here. So using this selection sort is going to be array dot toString over there. You can see this things is working same, but this will take n square iterations. As compared to the bubble sort, this is not a good suitable program for the sorting over there. Okay, so I hope you got it. So thank you guys, take care, bye bye. Hello guys, welcome to the section 3, session number 11. So let's understand the insertion sort into the session over there. So let's begin with the writing part over there. So what is basically an insertion sort is going to be that. So if I take an insertion sort, let's take an example over here. So like imagine we are having some kind of an array. So that is been sorted. So if there is a insertion sort is basically applicable for the sorted array into a good scenario. If it is already a sorted array, what we are going to do here is, if I want to insert any element into the array, imagine there are a 1 2 3 4 5 6 element, 6 specific space we are having, and we are having already 5 data here. I wanted to insert some value inside this array, and that should be an insertion sort. When I insert the value, the specific array should be sorted, right? So in that case, what happens here is, it is going to check the specific, it is going to build the final sorted array. So insertion sort is meaning like it is going to build the final sorted array one item at a time. Basically one item at a time it is going to build it. Okay, it iterates to the every input, and it's going to check, okay, if it is smaller, it is going to shift back, and it is going to insert, it is going to take the position wherever it is been required over there. Okay, that is how the specific insertion sort is going to work. So let's understand more better with the specific problem. So here, if I take an example over here, let's take an example of a human being. So let's take an example here. There is a one person standing here. Is there one person standing, and there is a persons who are been standing over here. Okay. So imagine we are having some person over here. So let's imagine this is a sorted people. So I'm saying let's take an example. So I said a people to stand with the proper heights over here. So it's just height. So imagine this is an example. Students, whatever we have as students standing in a line, standing in a line based on the specific let's imagine based on the age. Let's take an age here. Okay, let's take the age over here. Okay, so let's, for right now we'll imagine like a age. Okay, so the students are standing in the age based on the age over here. So imagine this specific person age is 10 year, and he is having 12 year, and he is having 14 year, and he is having a 15 year, and he is having a 17-year age. So basically, if we talk over here, when all the specific is in the sorted, right? This is a 10, 12, 14, 15, and all the person are standing in a queue in a sorted manner. So imagine I want to insert one specific person. I want to insert one specific person whose specific age is equals to 13 here. Whose specific age is equals to 13 over here. So what he'll be going here is, what he is going to do, he'll just come back to the first person here. He'll just come back to the first person here. He will tell, hello brother, what is your age? He will tell here as my age is 17. He'll tell, okay, my age is 13, so I need to go, I need to stand at the, I need to stand before you, right? So this person will, okay, for other he will tell, and he'll just accommodate this person. He will be just shifting towards his right. So here he will be 17th person is going to come over here, and he will be still, he will be not he won't to occupy this space. This person is there, right? He is number 13. He won't come and sit at the array number here. He is not going to come and sit over here. Just he will be pointing. Still he will be pointing. So this is an array pointer. The age who is 13, right? He will be still pointing it over here. So he will be here. Right now he will be standing it, but he won't accommodate it. So again he will check here. He will be keep on checking for the next person. Imagine we are having the next person as well, right? Where we are having the next person who is having 10 age, who is having 12 here, who is having 14, and who is having 15 here. So he will be still accommodate. Still he will not accommodate. He will just come forward and he will just again he will ask to his for this person. Okay, hey brother, what is your age? He will tell my age is 15. So then he will tell, okay, I am smaller than you. You need to come back. So what he will be doing? The age number 15 value will come here, and he will be coming 17 already is here, and 14 will be already here, and here he will be there, and here he will be there. So now this specific pointer age is equals to 13 is there, right? So he will be pointing towards here. He will be pointing here, and after that he will be pointing it over here. So now he will just come back to the next person. He will come back. He will be tell, okay, he'll just search for this specific person. Hey, what is your age? He will be again he'll be asking for this person, what is your age? He'll be telling 14. Okay, I am 13, I need to come first. So again he'll be telling, okay brother, he'll be just going back. The 14 age will be coming here, and what whoever has the 15, he will be standing here itself, and he will be 17 one will be here, and this specific person will be pointing here. So this person will be pointing here whose age is 13, right? And already here will be 12 and here will be 10. So I'm going to write it here. He will be 10 and here will be 12 here. So again he will ask this person, again he will be asking for this person, what is your age? He will be telling my age is 12. Then he will tell, okay, your age is 12, you are smaller than me, so then my position is this is my correct position. So finally what he will be doing it, so all the person will be the element also will get inserted, and whatever the sorted whatever the element will be there, that is also be sorted array over here. Okay, sorted array, that is what we are going to call it as a insertion sort. At the time of insertion only we are going to sort it. Now after sorting, the 10th age will be here, the 12th one will be here, and the newly 13 will be here, and 14 and 15 and 17. So whatever the newly sorted element was there, so this was the newly sorted element which we have inserted at the right now, right? So this is how the specific insertion sort is going to work. Insertion sort is going to be work over there. At the time of insertion only we are going to just sort an element over there. Okay, so same way, even if you try to apply the numbers, so let's take an example here. So we are having here 2, we are having 5, we are having 10, and we are having 15, and we are having suppose we are having here as a 25, and we are having 30. So basically here you need to be taken care one thing over here. So here whenever we are talking about this is basically a sorted, you can see this is a sorted array. So insertion sort goods works with the sorted array, but when it is a reverse, when if it is not sorted, and if it is not sorted, then it is going to be difficult for this one. That time it is not going to be suitable. Okay, so that's why we take the sorted array. That is why the insertion sort happens. At the time of insertion we are sorting it. Okay, imagine if there was no insertion. When I try to insert it, what I need to do here is, first I need to, when there was not a sorted array, then I need to traverse the entire array for the n into n square. So the time complexity is going to be n square for non-sorted. Okay, so the better one. So when we talk about this one, just we are comparing with the single element, right? We are just comparing with the single element. So the best case can be big O of n. Okay, the worst case can be n square over here. So the average or a best case can be big O of n square. If it is not sorted, then it is going to be the n square over there. Okay, not going to be a worst case over there. So this is how. Let's take an example for this one. So if I wanted to insert an element, let's say we have an array. So I wanted to insert an element here as let's insert something called as 12 here. Okay, so when I insert the element 12, so basically first it will just 2 will be present here, then 5 will be there, 10 will be there, 15 will be presenting over here, right? So 15 will first, he will be going to the 25, he'll check, okay, you need to sort, so 25 will shift it, and again he will go to the 15. Yeah, 15 is greater, 15 will get shifted towards it, then he has 10. Okay, I am the greater than, so he will be accommodating the place number over here. So this is how the insertion sort is going to be work over there. Okay, so now let's look up with the Java program for this. Coming back to the Eclipse over here, so I'm going to come back to the Eclipse over here. So we're going to create one new specific class for it. So I'm just going to create a new class. I'm just going to make it as a insertion sort over there. Okay, so I'm going to give it as an insertion sort public static void main over there. Okay, so once I added this specific insertion sort, so I'm just going to import the packages, that is import the package that is a java.util.array. So going to import the java.util.arrays package from here. Okay, so once it is done, so I'm just going to take the insertion sort array over here. Okay, so let's take an example. Here I'm just going to write one method. The method name, I'm just going to keep it public static void. So I'm just going to mention as an insertion sort is the function I'm creating it over there. Okay, so this takes basically an array of input. So I'm just going to tell int of the array over here. It is going to take the array of input over here. So we're going to iterate the what is the value of n. I'm just going to tell int n value is equals to whatever the array dot length length is there. So I'm just going to keep the array dot length. Then I'm just going to run this specific loop over here. So that also starts with int I value starts from 1 and I value should be lesser than n, then I plus plus. Okay, so then after that I'm just going to store one specific key here. So let's take example key. So basically this is going to be act like a key that's going to be keep on checking it over there, right? So I'm going to tell here as a int key value should be, let's take an int key value is equals to int of array of basically I'm going to take it as a I value. Okay, just take the first element for the sorted here. Then I'm just going to tell int value j, what is the value of j will be there, right? Then I'm going to tell j is equals to I minus 1 over here. J is equals to I minus 1 over here. So we are just comparing the two element, right? For comparison, we are just storing it. In key, I'm just going to store the first element. If we start with 1, so value of the first index will be stored here. Then if we take about the j, value of the 0th index will be stored here. So that is 1 minus 1 will be 0. So ij is going to store the 0th index value and key is going to store the next adjacent index value over there. Okay, so now basically we are going to write one specific condition here. So let me write one scenario here. So here I'm going to write move the element of array 0 to I minus 1. Basically I wanted to move the entire element from 0 to I minus 1 that are greater than the key. Okay, that are specifically greater than the key. But come back over here. So I need to, if I just insert this value example, I need to move every array towards its side until and unless this specific value, whatever the value we are inserting, whatever the values we are shifting it, that should be greater than the key value. If I take in this example, the key is going to be age here. The key is going to be 13 here. Okay, the same way we are saying move elements of array 0 to that are greater than the key. Okay, what all the greater than the key value, just move that to the positions from the right. So if we talk about shifting to the right, that means array of 0 to I minus 1. Okay, to the one position ahead of the current position. From the current position, we are moving all the specific elements from the array towards its right when the key is basically from the elements are greater than the key over there. Okay, so for that I'm just going to run one loop over here. So I'm going to tell while j value is greater than or equals to 0, whatever the elements are there, that should be greater than or equals to 0, and along with that I'm just going to tell array of j is there, right? Whatever the element is there, that should be greater than the key value. Okay, so if these conditions get satisfied, what we are going to do, we are just going to shift it. I'm going to tell array of j plus 1 is there, right? Just make it to array of j. Then we are going to tell j value is there, just decrement the j value. So I'm going to tell j is equals to j minus 1, decrement the j value, and it will be keep on j value will get incremented and it will be keep on running the loop. So when while loop gets fail, so I'm going to just tell here as a array of j plus 1 will be there, that is going to be your key value. So whenever after shifting all the position, imagine when it came to here, when it came to the element 12, at that case the key value is getting filled. Now the key is greater than the element, right? Before that the key was smaller, so now key is greater than the element which is getting formed. So at that case what we are doing it, we are just making the position to be state. So whatever the array of j plus 1 will be there, right? So imagine the j pointer will be at the 12. So I'm going to tell 12 plus 1 at the 30 at the specific 13 indexing position. You need to value it. You need to just for the next indexing position basically accommodate your space, accommodate the key value to it. That's what we are saying. At the array of j plus 1, we are accommodating the specific key value over here. So this is how the things is going to work. Okay, so I hope you got it. Now let's examplely I'm going to go to the selection sort here. We're going to take the same inputs here. So I'm just going to come back and it's going to be similar. Okay, so I'm initializing the array. So I'm going to tell original array is going to be the specifics here. So after applying the insertion sort, after applying the specific insertion sort, let me give it this one insertion sort, right? Let me give it as an insertion sort. So then after applying the insertion sort, that value will be inserted over there. So let's take an example whatever we have taken over here. So let's take an example for the sorted. Let's take it something like a 12, comma 15 comma 25 comma 30 comma 45 comma. Now I am inserting, imagine the last element will be something called as 30. Let's take an example of it. 13. Okay, let's take an example as a 13 here. So this is the basically, so till here it is sorted, and now it is will be 13 will be there. So in this case, we will take the big O of n here. Now you can see the original array is this. So after sorting, you can see 12, 13, 15, 25, 30 and 45. All the things has been sorted over there using the insertion sort. This is how the thing is going to be added over there. Okay. So even if you try to add after this, originally if I try to add the element again, so it will be working fine. Okay. So this is all about the insertion sort, guys. I hope you got it. So I'll catch you with the next session. So let's look on to the next divide and conquer sort algorithms like merge sort and the quick sort. Take care. Bye bye. Hello guys, welcome to the section 3, session number 12. So let's understand the merge sort into this specific session over there. So let's begin with the specific writing pad of my specific notepad. So let's take an example over here. So I'm going to add some kind of a numbers over here. That is the specific number. So I wanted to sort it over here. Okay. So I'm going to tell here as a 3, 2, 1, 9, 8, 7, 4, 5, 3. Okay. So I'm going to remove the duplicate element. So I'm going to mention here as a 7, 4, 5 and something like a 10 over here. Okay. So here we are having some kind of an element. I wanted to sort it over there. So let's apply the indexing position. Here we'll be having indexing 0, 1, 2, 3, 4, 5, 6, 7 and 8. So we are having 8 index over here. So we need to apply the concept of divide and conquer over here. So we are using the divide and conquer technique. Divide and the specific conquer technique for over here. So we are going to just split this specific array box into the two sides over here. So we are going to split it for the two types over there. Okay. So first one I am going to divide half or more than half. You can do it. Like basically just do it for the half. So if I just take the length of this array is basically length of it is going to be 9 divided by 2. If I do it here as a 4.5, you can take it as a 4 indexing at one side and next the remaining the another one over there or like that. Okay, however you feel good. So now I'm just going to divide it over there. Like I'm just going to tell here as a 3 will be coming 2, 9, 1 and then remaining element 8, 7, 4, 5, 10 is going to come over here. So again I'm just going to split this over here. I'm going to divide it. So 3 will come here, 2 will come here, 1 and 9 will be there. So again I'm just going to divide this with the next element. So I'm going to having 8 will be coming here, 7 and will be having a 4 and a 5 and I'm just going to take 10 as it is over there. Okay. So this is has to be come at the next, you can just do it in this way. Okay. So after doing this, again I'm just going to split this over into the two way. I'm just going to split it. So 3 will be coming here, 2 will be coming. Again I'm going to split this, that is a 1 and the 9. Again I'm just going to split this over here. So 8 will be coming here, 7. Again I'm going to split it 4 and again I'm going to split it with the 5. So this is going to come as it is over there. So now this is still here, whatever we have. So this is the one specific stage over here. This is the stage where we have been done with the specific splitting part of it. Okay. So after splitting the specific part, after splitting it, so now we need to start merging it. So here we are going to merge it over there. So we are going to merge. So at the time of merging it, we are going to sort it. So 3 is greater than 2, right? 3 is greater than 2. So 3 will come here. 2 is going to come over here. So again, when I try to merge with this two element, when I try to merge with this two, so 1 is will be there, 9 will be there. So again, if I try to merge with this two, so 7 is going to come here, 8 is going to come here. So again, if I try to merge, 4 is will here, 5 will be there. So it is going to come as it is over here. Okay. So this is how the specific merging we need to do it at the time of merging point. Okay. Again, I'm going to scroll it. So now again, we are going to merge with this specific 2 over here. So at the time of merging with this, it will come 1, 2, 3 and 9 will come over here. So when I try to merge with this and along with this here, so 7, 8, 4, 5, right? So first will come here as a 4, then 5, then 7, then 8, then there will be 10. So the final merge will be like this. So I'm going to merge this to specific. If I merge these two array, so it will be 1, 2, 3, 4, 5, then 7, 8, 9 and 10. Okay. So you can see this has been sorted using merge sort over here. Okay. So this is how the specific merge sort is going to be. Very, very simple. Just we need to divide it. Then after dividing into each box, then again we need to start merging it. At the time of merging, we need to make sure that we are just sorting and we are just initially after sorting, we are just inserting the values into the array boxes over there. So here we are going to divide it with the left and right things, and we are going to again will divide it with the left, right, left, right, left, right. So at the time of merging, again we are going to merge with the 2, and we are going to run loop. We are going to see what all the values from it, and we are going to start specifically merging it over there. Okay, so when we talk about the time complexity of it, right, so when we talk about the merge sort specific time complexity, it is better than as compared to the insertion sort and other sorts as well. So again we'll see with the programmatically, then we'll see what is the time complexity in the program itself. So let's come back to my Eclipse and start writing the code for it. So I'm going to come back to the Eclipse here. So I'm just going to create one new specific Java class. So I'm just going to make the class name here as a merge sort over here. merge merge sort over here. So I'm going to create one public static void main. I'm just going to finish the specific class over there. Okay. So let's see how it is going to be there now. So here, so let's begin with the specific programmatical part over there. So here I'm just going to import the specific java.util.array. So I'm just going to tell here as import java.util.star. You can import everything over here. So once we import it, so here we are having a public class merge sort, right? So here we are having some kind of a thing. So I'm going to create one more class over here. So I'm just going to create a class, that is I'm going to tell here as a public class. So public static void. So I'm just going to create something called as a merge sort, is this small letter I'm going to get. Okay, so public static merge sort over there. So that takes the basically first it's going to take the what is the array. It is going to take the entire array. Then after that it is going to take something, we are going to give it as an int of a left here. Then I'm going to tell here as an int of m value. Then I'm just going to tell int of right side. Okay, left, middle and the right. So these are the three values. I'm just going to pass it from the as an input parameter. So when I pass the input as a first parameter, so it means I'm going to tell here as we need to merge the two sub array, right? So basically we are need to just specifically tell merge two sub arrays, okay, of ARR. So this is going to be the first thing what we are passing as an input. And after that I'm just going to tell here as a specifically FIRST first sub array. First sub array is basically start from array of L, whatever we are passing length, right, from array of L to M. Okay, L to M over there. That is the second argument. Then again the second sub array is basically start from array of middle element to the right element. So that is why we are passing this argument, array, left, middle and the right. These are the arguments we need to pass it over there. Okay, this is going to be the algorithm definition. Like what I'm just explaining you the basically I'm going to do what I'm tracing the algorithm here. Okay, so how it is going to be there. Okay, these are the things is going to be there. So then what is the next thing I need to do? I need to just tell find the sizes of two substrings sub arrays. So first I need to find what is the two sizes of the two sub arrays, right? So if I come back over here, I need to find what is the size of here. If I take over here, size is 1, 2, 3, 4. Here it will be the size 5 here, right? The same way we need to tell here, find the sizes of two sub arrays to be merged, to be merged over here. Okay, so this is the fun thing we need to do it here. So for that I'm just going to tell int n1. So I'm going to tell n1 size is equal to, that is going to be mid minus left, mid value minus left value plus 1 over here. Okay, so this is going to be there. And when I talk about the int of n2, it is going to be r minus m over here. Okay, that means what is meant by m minus 1. So first I'm here m minus l. What is basically 3 minus 0 will be 0, right? So then if I just tell plus 1, that will be 4. So n value will be 4. And when we talk about the m, so r minus m, it seems r minus m is basically how it is going to be r minus m. So r value is basically right? If I take it about the 8 minus m will be 8 minus 4, it will be 4 itself. It is going to be the size of it. So basically storing the size of it. So what is the size of this and what is the size of this? We are just storing that specific size of the left and the size of the right over here in the n1 and the n2 over there. Okay, these are the things we have done. Then what we are going to do, we need to create one temporary array. So I'm just going to tell here as a creating the temporary arrays over here. So this temporary arrays is going to act very major role here. So I'm going to tell here as a int of, for the left to store the L, so I'm going to make it as a L. So I'm just going to tell as a new of int of n1. So I'm just going to store this much array size you need to create. And for the int of the right, for the creating a right thing, so again I'm just going to tell new of int of n2. So here we are just storing we are just storing the again we are just creating a empty arrays for creating a for the left and right value to get stored here. Okay, so now we need to create the same thing. I need to create another thing that for the copying purpose, right? Copying the data from temporary array to the original array. So I'm going to tell here as a copy data to temporary array. So copy data to temporary arrays. So I'm going to tell we are going to copy the data to the temporary arrays now. So in this specific temporary array, so we are going to copy. So basically simply we are going to run the loop. So I'm going to tell for int I should start with 0, then I value should be lesser than n1, then I value should be incremented. Okay, I value should be incremented. When I do this, I wanted to just tell L of I, so whichever we have created, the left of array I is equals to, here I'm just going to simply store the whatever the array of basically L plus I, whatever the L plus I value will be there, whatever the loop value will be there, I'm going to take from the specifically I'm going to take it from here, and I'm just going to whatever I'm going to take the array from here, and whatever the L value will be there, whatever the I value will be there, so that one from the N1 I'm just going to store it. I'm just going to store it into the temporary variable that is L over here. Okay, that is what we are doing it over here. Same way we need to do it for right also. So I'm just going to make it for the right. So for this I'm just going to tell here as an int specifically j is equals to 0. Then I'm just going to tell here int j is lesser than should be n2. Then I'm just going to tell here as j plus plus. Okay, then again I'm just going to here we need to pre-increment. Okay, so j plus plus or I plus plus, however you want you can give it. Okay, so then what I'll do here is I'm just going to tell here as a or of j, whatever the or of j is there. So I'm just going to store it as a array of, from here I need to start from middle element plus 1 plus j here. Okay, so this is how the things works, plus j. Okay, so one extra element we are adding it because to go till the last index over there. Okay, so that is how we are just storing the value into the right hand side. Okay, we are taking it and we are just storing it over there. Okay, this is the one thing is done. So now what we need to do, the merge the temporary array back. So we need to just merge the specific temporary array back. I'm going to tell merge the temporary array backs to ARR and L minus R. So this is the L to R. I need to just merge it back, merge the temporary array back to the array L to R over here. So left to right I need to merge it back over here. Here we have just differentiated, we have just divided. Basically with whatever we did, we have done the division like this. Okay, then again we'll apply the same formula to divide the n element. Okay, then we are going to start merging it over here in this specific fashion. So for that let's come back to the code here. So here I'm going to tell merge the specific array back to the whatever the temporary will be having it here. So for that first I'm going to initialize the I value is equals to whatever the I'm going to tell int of I is equals to 0, then comma j is equals to 0 over there. Okay, so I'm just initializing to like this. So once we have initialized I and j with 0, so now I need to initialize the index of the merged subarray. So I'm going to just tell initialize the indexes of, basically I'm going to initialize the index of the first initialize the indexes of the first. Here we are telling the initialize the indexes of the first and second sub array. So basically we are initializing the indexes of the, basically previously we saw it has been done, we have differentiated, now we are initializing the indexes with the 0 over there. So for this what we are going to do, I'm just going to cut here, I'm just going to paste it here. Okay, for your understanding. So then what we need to do, we need to merge the sub array. So I'm just going to tell here as a merge the sub array with initialized index. Okay, I'm going to initialize indexes. Okay, so now what we are going to do, I'm just going to tell int k value should be start, let's take one variable k. So I'm going to run a while loop here. So I'm going to tell while loop while I value should be lesser than n1, if I value is lesser than n1, along with that an operation if the j value is lesser than n2. I'm just traversing the entire array. If this condition is there, what I'm just going to tell, I'm traversing inside the specific next array list here. Okay, so in this I'm just going to check if the L of I, if the L of basically if the L of I is lesser than or equals to or of specific j value. Okay, or of the just comparing the adjacent boxes arrays over here. So if this condition satisfied, just what we need to do, we are going to tell store it into the array of k variable whatever we are having from the L of I over there. Okay, then once we are doing, then I'm just going to increment the value of I over there. So if this condition is not satisfied, it will come back to the else part. In the else part I'm just going to tell array of k value will be there, just make it to or of j. Okay, just matching the adjacent element, and if it is smaller we are keeping it, or else we are just shifting towards the right side. Then I'm just going to tell j plus plus over here. Okay, so this is how the specific loop is going to be there. Okay, and after that we need to increment the k value as well to just evaluate the while loop. Okay, we are just telling as a k plus plus. Okay, once it is done, now again we are going to write another function over here. So what is the next function? So the next function, we need to copy the remaining element of the L. If there is any remaining element, imagine if there is already sorted element like that. So I'm just going to tell copy the remaining elements from L and R. So I need to copy the remaining element from the L and R. After sorting it, I need whatever the remaining elements are there, I need to copy from the both. So for that, I'm just going to run two while loops for L and R. For I'm going to tell for I should be lesser than N1. Okay, if this while loop is less than 1, so I'm going to tell array of k is there, right? Just store all the remaining element of L of I. Then just increment the I plus plus and k plus plus. That's it. The same way, I'm just going to run the again I'm going to write a while loop for j should be lesser than N2 value. So in this case, I'm just going to tell array of, in this I'm going to tell array of the specifically k, array of the specific value k should be or of j over here, or of j over there. Okay, then I'm just going to tell here as a j plus plus and k plus plus. Okay, this is how the things is going to be. Okay, so this is how the things is going to be there. I hope you got it. How what we are doing, we are differentiating it, then we are just checking and we are just shifting back, then we are copying the remaining element from the R to light over there. Okay, so now what I'm just going to do, I need to just call the function, and I need to just pass it over there. So now what I'll do here is I'm just going to call a main function, so where we are going to pass it over here. So here one thing I need to do it here, right? So I need to just create another method now. So we are going to create one specific main method. So again, I'm just going to create it one main method, that is a public static void method. So in this, I'm just going to, in this specific, I'm just going to call the merge sort as your function. So what is the function we have created previously? There is a small letter merge sort. Okay, so where we are passing the original. So in this merge sort, what we are going to do here is we are just going to tell if they are passing with the merge sort. So I'm just going to tell int of I'm going to tell here as an int of specific variable, empty variable. So in this, I'm just going to create only pass the some argument like left and right. I'm just going to pass the int of L comma int of right. I'm just going to pass the two value, int of left and int of right. When I call this method, I'm just going to check one condition. If there should be one condition, the left value should be lesser than R. Okay, if the left value is lesser than R, what I need to do here is I need to find the which is the middle element. I'm just going to tell find the middle element. So this is what we are doing, find the middle element. I'm just going to tell int m value is equals to L plus R divided by 2. Even you can do like this. Okay, if you want to get the middle value directly, you can do it like this. In middle value, even you can get it. M value you can get it by m is equals to L plus R divided by 2 over here. In this way, you are able to get the middle value. Okay, then what we need to do, we need to sort the first and second halves. So I'm just going to tell sort the first and second halves over. Okay, so halves. Okay, so I is sorting the first and the second half. So I'm just going to apply the merge sort, whatever we created, that is a merge sort we created, right? In the merge sort, what I'm going to pass, I'm just going to pass the value of array, I'm just going to pass the value of L, and I'm just going to pass the value of right. So first I'm just going to call this method, whatever the method we written, I'm just going to call the main method over there. So after this, I'm just going to call the another method, that is a merge sort, the top one which we have written, the main one. In this, I'm just going to pass array, and here I'm just going to pass L and M, right? So first I'm just going to pass M plus 1, middle plus 1, I'm just going to pass comma, then I'm just going to pass the R value over there. Okay, so in this way I'm just going to call, okay, basically I need to call the same function. So first I'm just going to call what? Array left and right, then I'm just going to tell middle plus 1 plus right. In this first half and the second half I'm calling it. Okay, this is all right. This is going to call the first half and this is going to call the second half. So after that, I'm just going to call the main function merge sort function. So in this, no, I'm merging. This first what I did in this function basically divides it, and these functions does the merging over there. Okay, with the first and the half. In this, I'm going to tell here as array comma L comma m comma r. So I'm just going to pass all these four specific argument for the main function whichever we have created it. Now once we do this specific thing, now let's try to initialize the inputs and outputs over there. So now let's come back to the public static void main. So I'm going to give the inputs here. So you can say I gave an int array is equals to 64, 34, 25, 12, 22, 22 and 19. Some numbers I have given it. I'm just going to tell original array will go into this. So here I'm just going to call the merge sort function. So with the specific merge sort function, I'm just going to pass the length minus 1 over here. Length the array 0 first I'm passing as a 0 is your left, and length minus whatever the total length will be there as a second argument. Then it will divide it to the half, then it will call the merge sort algorithm, whatever we have written it, and based on that I'll be getting an output over there. So let's see if we have not done any error. I got an error here. The first error, what's the error we got? Let's check this error. Okay, so here we are getting the error. What is the error we got? So if I scroll a little bit, you can see it is getting original array is this, and here I am getting an array by saying here we are passing the merge sort, right? So here what we are getting, java.line stack overflow error we are getting it here. We are getting a stack overflow here. So what I'll do, I'm just going to mainly I'm going to, I think somewhere I did incremented, right? So first here, I guess where was that? Yeah, here first I'm just going to pre-increment. Here we have done the post increment. So let's do the pre-increment plus to I. Okay, and here also plus to j over there. Okay, now I think it should work. So let me execute it here. So again I'm just getting the same error. So let's see what is the bug we have done here. Yeah, so yeah guys, there was no mistake. So basically I did it the same thing. So now I just refactored this one. So there was error in this one, in this line. So we have just done merge sort is equals to array lmr now. Once I execute the specific program, so you can able to see the specific element are getting sorted. Original array is 64. When I give, you can see we are getting the specific sorted array over there. Okay, so the time complexity, if we talk about of this specific program here, is it is going to be big O of n log n over there. Okay, so the time complexity when we talk about the merge sort, so the time complexity is going to be big O of n log n. Okay, so I'm going to tell here as a big O of n log n over here. Okay, I'm just going to write it something over here. So I can just insert it the specific text over there. Okay, so basically when I talk about this one, so as I said, like this is going to be the big O of n over. So I'm going to write it over here. The time complexity is going to be, specifically I'm just going to write it in the comment. So the time complexity will be big O of n log n over there. Okay, so this is going to be the good case for this. And the space complexity, when we talk about this space, it is going to take the n spaces, so it is going to be big O of n over there. So as compared to the previous algorithm, this merge sort is more better than, right? So rather than getting the n square as the time complexity, getting a big O of n log n is a better, right? Therefore the best average and the worst cases over there. So why this is? Because this takes the sub array contains only one element, then merges the sub arrays while sorting, right? So that is why. So this is how the things is going to be there in the sorting. So in the next session, we are going to look on to the quick sort. Take care. Bye bye.
Hello guys, welcome to the section 3 session number 13. So let's discuss about the quick sort algorithm into this session, and we are going to look on with the example and the coding part with Java program. So what is quick sort? So it is basically a sorting algorithm known for the efficiency and performance based over there. So it basically comes under in the divide and conquer technique. So where will be work recursively with the part of an array or a list into a smaller sub arrays, and it is going to work with the specific conditions like dividing the specific entire array into the two portions. Again, if it's some conditions matches, again it is going to divide specific things. So basically a divide and conquer technique is mainly used into the quick sort algorithm over here. So basically here how it is going to work here is the other two things will be there mainly here. So there will be a pivot here. So pivot is basically select when we try to select a pivot element from the array. So that is going to be the first element which we are going to select from the pivot, and we are going to compare with the array element over there. So based on some conditions, we are going to evaluate that. So then we are going to partition this specific arrays here. So we are going to partition, I mean to say, if there are 10 element, then we are going to do partition for 5 element for the specific conditions matches. Okay, then we are going to apply the recursively, we are going to apply the same specific algorithm which we are going to be written here. So here there will be a concept of pivot, there will be a concept of partitioning, and there will be a concept of
calling the same function again and again for the specific recursion, like left and right specific part, and we are going to combine all those things, and again we are going to get the sorted array over here. So we'll understand betterly with the example over there. So when we talk about the time complexity of it, here is the big O of n log n is the good best to time complexity here. So that better than the big O of n or big O of n square, right? So big O of n log n is the better best case time complexity over here. So when you talk about the worst case, it is can be the big O of n square over there. Okay, but at the time of a partition inside that, if it is there is the first, middle, and last element strategies if we apply. So we'll see about with an example over here. So coming back to my notepad here. So let's take one example and let's solve this specific scenario. Okay, it's going to be a little bit tricky, so you guys need to be very careful for the understanding point of view here. Okay, so let me try to add some kind of an element here. So imagine I'm going to add an element 35 here, and I'm just going to add an element here as a 50. So then I can have something like a 15 here, then I'm going to add some element 25, then I'm just going to add here as a 80, 20. Okay, so I'm going to add it here as a 90. So imagine I'm going to have these many elements. Okay, 45. So imagine these are the specific array we are having it. So I'm just going to add 0, 1, 2, 3, 4, 5, 6 and 7. So these are all the indexing positions over here. So this is the array which is not sorted. So I need to sort this specific array over here using the quick sort over here. So let's try to imagine there can be a plus infinity over here as well. So if there can be larger number, there will be larger numbers over here, like some kind of a positive numbers over there over here. Okay. So here, first and foremost, we need to first choose the pivot here. So I'm just going to choose, this is going to be your P, pivot. Okay, I'm just going to tell this is going to be your pivot element here. So I'm just going to tell here the specific pivot is equals to 35 here. The element pivot here is a 35 here, right? And along with that, I'm just going to add one more specific array. So I'm just going to make this first element as an array I. The last element from the array, I'm just going to make it as a j over here. Okay, so we are going to play with pivot I and j over here. Okay, these are all the specific things we are going to play around with. Okay, so let's begin with this first condition over here. So first I'm just going to see, first I'm just going to tell how I'm going to just change it here. So first I'm just going to see. Okay, first I'm just going to check one condition, like I value is greater than pivot element. So first I'm just going to tell I value is greater than or equals to pivot element. Yes. So again I'm just going to tell j value, whatever the j value is there, right? 45, whether your 45 is greater than this or 90 is greater than this. Your 50 is lesser than 35. First I need to check this is a I value. So I'm just going to check whether here, first I'm going to check here I. So I value is lesser than or equals to pivot, and j value is greater than or equals to pivot over here. Okay, these two conditions I'm checking first here. Okay, so I'm just going to tell 50 is greater than, 50 is lesser than or equals to 35. No, stop here. Then j is greater than or equals to 35. Yes, j is greater than or equals to 35. Yes, basically 45 is greater than 35. I need to just move this specific j minus minus. Okay, I can just tell programmatically, if I tell, I'm just going to tell j minus minus over here. I need to decrement it here. Okay, so once I decrement here, so after applying this specific condition, the array element will be like this. 35 will be there, 50, and I'm going to tell here as a 15, and here 25, 80, 20, 90 and 45 here. Okay, so now p is going to be here pointing over here, I is going to be pointing over here. So I want to decrement, like, so j is going to come over here. Okay, because this condition is getting matched. So again, next I'm just going to check 90. So j is pointing at the 90 now. So I'm going to check 90 is greater than 35. Yes, again decrement the j value over here. So again I'm just going to tell 35, 50, 15, again 25 here, 80, 20, 90 and 45. So now p is going to be here pivot element, and I is going to be here itself. Now j is going to point it towards here over there. So now the conditions here, it is been stopped now. So now this condition also has been stopped because 50 is lesser than or equals to no, j is greater than or equals to no. This condition has been stopped over here till it is been stopped here. So j is equals to 20 now. So what we need to do in this condition, whenever this specific happens, you know, when I stops and j stops, we need to just swap it. So I'm going to tell when I stopped and j is stops, just swap it. Okay, we need to just swap the element now. I and j, I need to swap it. Okay, I comma j stops, swap to j comma I over here. So when I swap it, so it is going to be 35. So I going to be here, I value will go here. So I'm going to tell here in the red color. Okay, so I'm just going to tell 20 is going to come over here. Okay, so the 20 is going to come here. Remaining I'm just going to write 15, 25. Again I'll write 80. So 50 is going to come over here. So again I'm just going to tell 50 is going to come here. Then after that, again I'm just going to tell 90 will remain as it is, 45 will be remain as it is over there. Okay, so now p value will remain here, so I value is going to be here, so j value is going to be here itself. Okay, j value is going to be here itself. Now let's try to again apply the same formula. Now come back to this, first check the condition. I is lesser than or equals to p. Yes, I is lesser than or equals to p here, so I is going to increment here. So I'm just going to write step by step. So because it is kind of a confusing, so I don't want to miss any kind of a steps, so you can have a note all these things in your book and practice it. Okay, so pivot is going to be here itself, so I is going to be incremented, so I is going to be here at the this specific iteration, and j is going to remain over here. Okay, then again I'm just going to check here. 15, 25 is lesser than 35. Yes, so it is 25 is lesser than 35. Again I is going to get incremented over here. Okay, so in this condition what happens, I plus plus happen. In this condition I minus minus happens. Basically j minus minus is going to happen it here, right? So again I'm just going to write here as a 35. Again I'm just going to write it here as a 20. Again I'm going to write it as a 15. So 25, 80, 50, 90 and the 45. So I value is going to be here now, and j value is going to be here itself. Okay, so now let's try to again apply the same specific formula now. So again I'm just going to tell 25 is lesser than 35. Yes, 25 is lesser than 35. Again I is going to get incremented here. So again I'm just going to tell 35. Again I'm going to tell 15, 25, 80, 50, 90 and the 45. So what I am going to do here now, so again if I 25 is lesser than 35, true, so I value is going to be here now. Okay, now j value is going to be here itself. Okay, now again, so now I need to first, now I is been done, I stopped here. So at the 8, if I compare 8 is lesser than 35, no, this condition stops, so I will be stopped. Now again I am going to check for the j now. So when I check for the specific j now, so now again I'm just going to check for the specific j over here. Okay, so here only I'm going to write in. So again let me scroll a little bit down. Yeah, I can scroll it. So now I'm going to tell here again 35 is going to be here, 20 is going to be, 15 is going to be coming here, 25, 80, 50, 90 and the 45. So now j value was 9 and 50. So 50 is greater than 35. Yes, so j is going to get incremented to high here. So now I is also pointing at the same specific element, j is also pointing at the same specific element. So again I'm going to check here, 80 is greater than or equals to 35. Yes, 80 is greater than 35. So what I need to do here is 35 will be there, 20, 15, 25 again I'm just going to tell 80, 50, 90 and the 45. So j value is going to jump here, I value is going to be here. So the pivot will be remaining same. This is going to be your pivot itself. Okay, so whatever the first element was there, that is going to be the pivot element over here. Okay, so now what we need to do here is, if this conditions happens, again I'm just going to tell, if j is going to be like this, if this specific conditions happen in your while doing it, if j crosses the I, if j is crosses the border of I, then what we need to do here? So in this case we are going to do the partitioning. So in this case we are going to do the partitioning over there. So now how we are going to do the partitioning over here? So what I am going to do here is, so we need to replace this specific element with the pivot over there. So we need to replace the pivot with j. I'm just going to tell replace pivot with j over here. Okay, so now what I am going to do here is, the 25 is there, right? 25 is going to come over here. Okay, and 30 is going to come out of the loop over here. Okay, so when I try to do this, so if I just try to do this specific thing, so now when I try to do this specific thing, what happens, let's see here. So 35 is going to be coming over here, 35 is came outside. Okay, now we need to do the two partitioning here. So I need to do the partitioning here, and I am going to need to do the partitioning of here. So when I try to do, so what happens here, 25 is going to come here, right? So 25 came over here, right? 25 is going to come over here. Okay, so then whatever the remaining element will be there as it is, I'm going to tell 20 is all as it is here. Okay, 15 is as it is over here. Okay, so this is basically only these many stuffs is there. So I'm just going to do the partitioning till here. Okay, 15 only this much. So 35 came here, I'm going to place outside the element 35. I'm just going to place the outside over here. Then what are the remaining element we are having? We are having here 80, we are having it. So I'm going to write it into the specific black color itself. So I'm going to tell here as a 80 we are having, 50 element we have, and a 90, and we are having a 45 over here. Okay, now we have the two partitioning here. So partitioning is done. So I'm just going to tell the specific partitioning is been done over here. Okay, I'm going to tell here the partitioning is done. Okay, now partitioning is completed over here. So when I do the partitioning, so again I need to replace the concept same here. So now I'm just going to do this specifically over here. Okay, so now I'm just going to tell this is going to be your pivot element, this is going to be your I element, and this is going to be your j element over here. So when I try to do this specific partitioning, now what happens here? So now here if I just tell 20 is lesser than or equals to 25, yes, I value is going to move over here. So 25 will be here, and 20 is going to be the here, 15 is going to be here. So pivot is here, so I is going to get incremented. So again 15, so there will be always there will be a plus infinity, right? So I'm going to tell whenever we are partitioning, always there will be a plus infinity. Okay, so again if I tell 15 is greater than or equals to 25, 15 is always greater than or equals to 25. Yes, 15 is 15 is lesser than or equals to 25. Yes. So now what happens if I have an infinity? Let's try to do it here again. Next step. Okay, so there will be a 25, and we have a 20, and we have a 15, and we have having. So I is going to replace here. So again there will be always j. So previously j was pointing here itself, right? So when in this case j will be here itself. So j is here. So again whenever this conditions happens, I need to do here what I need to do. I'm just going to tell replace j with pivot here. That's it, right? I need to replace the j with pivot over here. So when I do this, so it is going to come over here. So I'm just going to replace with this pivot element and the j element over here. When I do this, the final output I'm just going to write it here, right? So I'm just going to write it over here in the green color. Okay, so when it happens, so 15 is going to come over here. So 15 is going to come here. The 20 will remain as it is, and 25 will remain as it is over here. Okay, so you can see this has been sorted. So whatever the 15, 20, 25 is sorted. Already there is an element that is 35. This is also sorted. Now this specific first step is completed. Okay, this is done. Now we need to do it for same thing for the 80, 50, 90 and 45. Let's try to do this the same thing for the here itself. Okay, I'm just going to put here as one divider. So I'm just going to do it one specific. Let's try to add it. Okay, so fine. So now what I'm going to do, I'm going to take an element here 80, 50, 90, and then element that is 45, and then infinity over here. So let's try to do this for over here. Okay, this is also an very easy one. So when I try to do this specific thing, so first here if I just try to do, so this is going to be your pivot element, this is going to be your I value, and this is going to be your j value. So 50 is lesser than or equals to 80. Yes, that is true. So at that case what happens, 50 is going to get, I is going to get incremented, I is going to point at this. So 45j already is here, so infinity. And again 90 is lesser than or equals to 80. No, I will stop now. So again I need to check for the j now. So j is greater than or equals to 80. J is greater than or equals to 80. No, it is also stopped. So what happened here, it is stopped. So it is stopped. So what I did previously, whenever it is stopped, we need to swap the j I comma j with j comma I, right? So when I try to swap this one, so it is going to be like this. So I'm going to tell 80. So I'm just going to tell here as an element that is 50. So when I try to do it, so I'm just going to take it red here. So I'm just going to tell whenever this happens, so 45 is going to get swapped and 90 is going to get swapped, and it is going to be like this. Okay, now after swapping it here, so now we are having swapping. So swapping, so I will be remain here and j is going to be remain here, right? That's correct. Then again, so in this case again 45, again I'm going to check for the I now. So when I try to check for the I, 45 is lesser than or equals to 80. Yes, that's true. I need to increment the I value. So in this case 80 will remain here. So 50 is going to be here. So I'm going to raise this to write properly. I'm going to tell 50 is going to be here, and the element 45 is going to be here, 90 is going to be here. So 45 is lesser than or equals to 80. That's your pivot element. This is also your pivot element. Okay, and I'm going to tell this is going to be your pivot. So I is going to get incremented and j is going to be pointed over here. Okay, now j stops here. 90 is not lesser than or equals to 80, pivot element. Again I'm just going to check for the j. J is greater than or equals to 80. J is greater than or equals to 80. That's 90 is greater than or equals to 80. Yes, that's true. So what I'm going to do, I need to, whenever it happens, so it is going to swap it here, right? So I'm going to tell here as a j value is going to come here, 90 plus I is already remaining over here. So when this happens, what we need to do here, so whenever again basically j comma I happens, what we need to do, I need to replace pivot with j, right? I need to replace the pivot with j here. So what I am going to do, 40 is going to get replaced here. So 45 is going to replace with the pivot element. So 45 will come here and 80 is going to go here. So I'm just going to tell here, it is going to come here, it is going to go here. Okay, this is what happened. So 50 will remain as it is and 90 is going to remain as it is. So this is your final array. So you can see 45, 50, 80 and 90. So whenever it is been sorted, now you can see it is going to stop it here, right? So 45, 50, 90 is been sorted over here. So when I conclude this, I'm just going to conclude now. I'm just going to conclude. So I can see this is your first part. This is the second part which has been partitioned, and this is going to be third. So when I try to do 1 plus 2 plus 3, now what is the final? I'll be getting 15 comma 20, 25, and I'm going to match 35. Then I'll be getting here as a 45, 50. I don't know why I'm able to write the 50 here. So I'm going to tell here as a 50. Then I'm just going to write it here as a 80. Then I'm just going to write it as a 90. So it has been sorted. Okay, so this is going to be big O of n log n over there. Okay, this is going to be a big O of n log n. Okay, this is going to be the best time complexity for it. Okay, this is going to be the happen over there. Okay, so again, even when you need to replace, I hope you got it. So whenever we are j crosses I, whenever j crosses I, we need to replace this element. We need to replace the pivot with the j value. Okay, so whenever you are replacing pivot with the j value, you need to just cross it over here. In this case, what happens, right? Whenever j comma I happens, so 90 will already remain here. So in this case, how it will be there? Actual, if I tell you, in this case, after swapping it, how happens? So it is going 90 is going to be separate. So 90 is going to be separate. Okay, so when it's scrap, what happens? So 80 is going to come out. 80 is going to come here. So in this case, 80 is going to come out. Here there will be only two elements, that is 45 and the 50. So in this case, even if you apply the same algorithm, the things will remain as it is over there. Okay, so this is how the specific quick sort algorithm is going to work over there. Okay, so in the next session, we are going to see the Java program for the quick sort. Take care. Bye bye.
Hello guys, welcome back to the section 13.2. So in the previous session, we looked on to the quick sort algorithm and the working example with that. So in this session, we are going to see the Java program for quick sort code over there. So let's begin with the coding part of it. Okay, so coming back to my Eclipse over here. So I'm just going to create one new file. So I'm just going to create one new Java class in this GUVI DSA. So I'm going to create new Java class here. So I'm just going to name it as the specific quick sort here. Quick sort public static void main. So I'm just going to click onto the finish over here. So now here I need to write the specific algorithm, right? So let's see how the specific things. So basically here also same thing we need to do it. So first I need to write one quick sort algorithm where the array length should not be equal to 0. Then next we need to write one sort function which takes the low value, high value, and specifically works with that. So okay, so let's write the specific coding part for it. So coming back to the coding here, so I'm just going to create write one specific public class. Already we have, right? So let's try to add one specific methods inside it. Okay, so before that I'm just going to tell here as java dot. So I need to import specifically java dot util dot star over here. Okay, so let's try to write this first specific method here. So I'm just going to write it here as a public. So I'm going to write it as a public static specific void here. So I'm going to write one specific function called as a quick sort function over here. Okay, so this specific quick sort function takes the int of an array and it is going to take the int of the array basically. Okay, so what I am going to do now, so I'm just going to check first one condition. If the specific array is equals to null value, okay, or array dot length length is equals to 0. Okay, array dot length is equals to 0. If this specific condition satisfied, so I just wanted to stop it. So I'm just going to tell the return over here. Okay, so if not, I'm just going to write one function called as a sort. Inside that I'm just going to pass the array value, then I'm just going to pass the first index value, then I'm just going to pass the length. What is the array length? I'm just going to tell array dot length length value, then I'm length minus 1. Basically I'm going to pass 3 argument, so to entire array and the 0 first index, then the what is the last index of the array over there. Okay, this is what I'm going to do it here. So let's try to write the specific function here. So let's try to write the specific function. I'm going to tell it as a public static void and a sort here. Void sort. I'm just going to write the public static void function. So it takes the specific array, right? So I'm just going to tell here as the int of array, take the array, then just take int of, treat the first value as a low, then I need to treat the second value as
high here. Okay, that is a low and high, that is basically I comma j, whatever we have solved with the example previously. So in this, what I'm going to check here, either I'm going to check one condition. If the low value, if the low is greater than or equals to high, okay, again if there is a low is greater than or equals to h I g h h high, so it should, this condition should not happen, right? So I'm going to just return the specific array. So or else what I'm going to do, I'm just going to point which is your pivot value. Okay, so I'm just going to find which is your pivot value. I'm going to tell int of pivot is equals to, so I'm going to create something called as partition. I'm just going to create something called as a function called as a partition. That partition takes the same argument. It is going to take the array, it is going to take the array whatever we are getting it, and again we are going to pass low, and again I'm just going to pass the high value for it. So after passing, again I'm just going to call the same, I'm going to apply the concept of recursion. Okay, so I'm going to tell here as again in the same function, call the array, pass the low value, and just pass the specific pivot minus 1 value here. Okay, so just pass the pivot minus first index, whichever it is. Then again I'm just going to call the another one more time method. So here I'm going to call array comma, I'm just going to tell here as a pivot plus 1, then I'm just going to pass here as a high value. Okay, this is what I'm going to do. So this is how the specific things for. So let me write the again one more function for the partitioning over here. So again I'm just going to write the same thing. I'm going to copy this, I'm going to paste it here. So here I'm just going to tell public static, here it is going to return the value. So I'm going to tell public static int partitioning. Okay, I'm going to tell here as a int partition, that takes the array, again it takes the low value, and it is going to take the high value over here. Okay, so in this what I'm going to do, I'm going to store the pivot. So int pivot is equals to, basically from the specific array of high, whenever we are doing a partition we are going to replace j value with pivot, right? So in this case high is basically aj, low is basically I. So I'm just replacing the j with pivot. So that's why I'm telling int pivot is equals to array of 5, whatever the j value will be there, just paste it to the, just replace with the pivot here. So once you do, so I'm going to tell int I value whatever it is there, just decrement the with the 1, I value should get decremented. So then again I'm just going to run one specific loop that's holds the just for making j is equals to low here. Then I'm just going to tell j is lesser than high value. After that I'm just going to tell j plus plus. Okay, so how many values of j will be there, I need to apply one specific for loop, right, for sorting purpose. So for basically for swapping here. Okay, so I'm going to tell here if the specific, again I'm just going to tell here if the specific array of j value, if the specific array of j value is lesser than the pivot, if the array of j value is lesser than the pivot, what I'm going to do, I'm just going to tell here as a I plus plus over here. Okay, so I'm going to tell here as a array. Okay, I'm going to just make it as a I plus plus. After that I'm just going to write another, create one more function called as a swap. So whenever I swap it, it should replace, it should take I comma j. This is the argument that is going to take it over here. Okay, so again after the completion of this I'm going to write another same swapping concept of recursion I plus 1 comma I. Okay, this is all the specific code is going to be there. So once after swapping it, so what we need to do after swapping it, we need to return, right, we need to return that specific value. That's why I'm going to tell return that specific value that is going to be stored at the specific height position, and I need to increment with 1 over there. Okay, so this is how the things going to be there. This is the function for the specific partitioning. So now I'm just going to write another function for swapping it, the last function. So this is going to be a private, I'm going to tell it as a private static void, that's a function called as a swap. This swap takes the same thing, that is the int of array, then it takes the values of int I comma, again I'm just going to tell it as a int j here. Okay, this is going to be taken like this. So in this, whenever I am swapping, just I need to just store the values into one temporary variable, whatever the in the specific array of I, whatever the value will be there, that will be stored in a temporary variable. Then what I am going to tell here is whatever the value that's present in array of I is going to just, whatever the array of j is there, make it as a array of I. Okay, then whatever the value we have stored it into the temporary variable, just store that value into the array of j here. Okay, and that is what we are doing it. So that's it. Okay, this is going to be a temp variable over here. Okay, that's it. Now let's try to write the specific let's try to print write one more function to print the original array. Okay, so let's try to write one specific function, same as it is. I'm just going to take, it takes the element this much, so I'm going to write a function that's going to just spell here as a print array. Okay, so I have to print the specific array, and it's going to take this as array as an argument. And here I'm just going to run one for loop for each loop. So I'm going to take int. I wanted to just print number from this specific array. So it has to tell so I want to just print the whatever the num values there. Okay, so I wanted to just print num. After that, I wanted to just create one space like this. I wanted to just print it. Once it is done, so I'm just going to tell here as so. So just let it print one empty line over here. Okay, so I'm using as a print array here. Okay, so now I'm just going to call the specific method. Now I'm going to write the specific method. So let's try to give the same example over here. So I'm going to just try to give the specific same example here, whatever we have used it into it. I'm going to tell it as an int of array, sorry, int of array. So here I'm just going to give some kind of an example, whatever we had earlier, whatever, let's take it something other. Okay, no worries, whichever you give, that's works same. So that give 12 comma 4 comma 7 comma 8 comma 9 comma 2 comma 6 comma 5. Okay, so let's give this is an array, so where we have some element that is in an unsorted manner. Now I'm just going to tell here as a so system dot print dot element array. So I'm just going to tell here as a first I'm just going to print the original array. So I'm going to tell here as a original array is going to be like this. So whenever the original array works, I'm just going to call the print array function here. So I'm just going to call the print array function. Then I'm just going to pass the whatever the array we have created. Okay, that's what. So once I do this, then again I wanted to apply a quick sort algorithm. So I'm going to tell here as a quick sort. So I'm going to call the quick sort, the function which we have written onto the top. Here I'm just going to pass the array element, whatever the array is there. So after that, I'm just going to tell so I'm going to tell here as a sorted array. So I'm going to tell in the new line, the sorted array is basically, so then after sorting it, basically I'm just going to tell here as a print the specific array, whatever the array is there, that is going to get printed here. I hope there is no errors. So I don't know whether there are errors or not. Let's try to execute the program. Let's see if there is any error, we can debug it. So once I execute the program, we can able to see, guys, it is sorted. You can see 12 4 8 9 2 6 5 is the original. After sorting 2 4 5 6 7 8 9 12, that's great, right? That's amazing. So this is going to be the Java program for sorting it. The logic which we have written here, exactly the logic is been matching, and the same way we have implemented the specific functions, and that is been used based on the values over there. Okay, thank you guys. I'll catch you with the next session. Take care. Bye bye.
Hey guys, welcome to the section 3, session number 14. So let's understand the searching algorithm from the session 14 and 15. So first we are going to see the linear search into the specific session over there. So what is meant by linear search here? So linear search is basically a simple searching algorithm that sequentially search the specific element one by one until it's matched based on the indexing positions over there. So it is suitable for unsorted or a small sized list, but become inefficient for the large list over there. Because if you are having some small values, like imagine if you are having 100 elements into a list, so at that time it is specifically it is suitable. So if it is having like more than like 1000 1000 or lakhs of element, at that time this specific linear search algorithm is not going to be much efficient, because its time complexity is going to become as a big O of n over that. Okay, so then we are having a binary search algorithm as well. So binary search algorithm basically uses the divide and conquer technique. So basically it divides the entire array into the two different part. Again it is going to check some conditions, again it is going to divide it. So based on a specific values, it is going to divide into two parts. Then we are going to check the values from the element for the search element from the indexing positions. Then we are going to find the specific element from the binary search. So it is going to be very faster and as compared to the linear search for the large sorted arrays over there. Okay, so let's understand how it is going to be working. So first we are going to search for the linear search. So if we take an example of this specific here, so we are having n1 2 3 4 5 6 7 6 elements here, right, with the indexing position 0 to 5. So we are having 12 45 77 98 23 and 7. It is basically a unsorted array, and inside that I wanted to search for an element that is 7. Imagine I wanted to search for an element 7 here. Okay, so in this case what happens, so I need to start from the indexing position 0. First I'll check, okay, first index I'll match with the 7 target element with the specific first index. It is not getting matched, so increment the I value. Again 45 will match, not matching. 77 I will match, not matching. 98 I will match, not matching it. Again 27 value I will match, 7 it is not getting matched. So when the pointer comes over here, 7 is equals to 7, so here the specific element will get found. So if we talk about the specific time complexity over here, if I talk about the specific time complexity here, it is going to be big O of n here, right? It is going to be the big O of n. So because I am searching for the n element are there, n time I am searching it here. Okay, this is going to be the worst case time complexity for this. Okay, and what is the space complexity? It will be space complexity will be big O of 1 itself, because it is only occupying a single specific space here. Okay, that is why it is going to be big O of n. And in the same case, imagine I am finding a specific target element, right? I'm saying finding for a 12. If I imagine the search is equals to 12, if the target element is found in the starting iteration itself, or between 1 to 3 iteration, at that time the specific time complexity is going to be reduced. That is going to be big O of n. So it can be happen or it cannot be happen. So it is just like a specific like a luck. Okay, but when we use this specific approach, it is going to be okay for the small kind of an elements for the small list. But when we talk about the large element where we are having thousand lakhs of elements in an array, so in that case this specific methodology is not going to be useful over there. Okay, so let's look off with the Java program over here. So I'm going to open the specific Eclipse here. So if I open the Eclipse, I'm going to create one new Java class for it. I'm going to tell it here as a linear search. Okay, linear search, and I'm just going to create a public static void main, and I'm going to finish it over here. Once I finish this one, so let's see how the specific program is going to be there. So in this specific, I'm just going to write one specific method, that is a public static. So I'm going to write it as an int that is going to return a function. So I'm going to tell as a linear SEA or CH search function. Okay, so linear search. So basically it is going to take the int of array element, and it is going to take the which is the target element I need to find it. Okay, that is basically which I need to search for the element. So in this specific function, I'm just going to write what all the stuff I can do it here. Okay. So here I'm just going to import a Java package here. So I'm just going to tell here as a import Java dot util dot star over there. Okay. So once I import this one, so now let's try to write the code here. So I'm just going to check first condition here. If the specific array value, so whatever the AR or AY array, okay, is equals to null. If there is an empty array, so what I'm going to do, I'm just going to return -1. Okay, so I'm just going to return this specific -1 over here, or etu or in return -1. So if this is not the condition, I'm just going to run a loop, and I'm going to iterate the every element from the array. So I'm going to start from the int I value is equals to 0, from the indexing position 0, then I value should be lesser than array dot length length. Then I'm just going to increment the I value over there. After incrementing it, I'm just going to check if the specific array of I is equals to target element. I'm just going to check if a specific indexing position finds the value that's equals to target element. So I'm just going to simply return the value of I over there. Okay, so this is going to be happen. So if it not the condition, if this for loop runs, if the value will get found, definitely the value will get returned. When it is written, it is not going to go for the further lines of code, right? Imagine if it is this is the condition getting satisfied, here it won't go. If this condition gets satisfied, after the line number 17 it won't go. If there is an element, there can be a scenario where an element cannot be found as well, right? If there can be a scenario where element also cannot be found. If I try to search for 17, 17 is not present into the list. So even this can also happen, right? To handle that, I'm just going to return, okay, if it is nothing is getting passed, so just return -1 over there. If the target element is not found, I just wanted to return the -1 over here. So I am giving use the int function because this function returns something. Okay, so it is going to return the value. So now what I'm going to do here is I'm just going to create one int of an array. So let's try to search for it. So I'm going to tell int of array is equals to, let's tell 3, 4, 5, some 10. I'm going to tell 23, 42, 12, and 13. Okay, some values we are having it from here. Okay, so I'm just creating one int of array. We have added some kind of a value. So let's try to add some kind of a target element here. I'm just going to tell here as a int target. So I wanted to search for an element that is 12. So this is going to be the target element. So I'm just going to tell the index also. I'm going to tell till index is equals to, I want to tell int of index is equals to, so I'm just going to call the linear search function. Here I'm just going to pass the array value and the target element, okay, for the function which we have wrote. So if whenever we call this, it is going to return some value for us. Either it may return some value, or else it will return -1 if it is not found or if it is null. Okay, so I'm just going to check one condition. If the specific index value
should be not equals to -1. If these conditions get satisfied, that means the element is not found, right? I'm just going to tell SYSO. I'm just going to tell target element is not found. Basically, I'm going to tell here as a target element is not FOUND found. Okay, so I'm just going to tell target element is not found here. So I'm going to pass the specific target element also. I'm just going to pass the value of target here. I'm going to pass it as a target here as well. Okay, so else, basically else part. So if these conditions get filled, I'm just going to tell same thing, the target element is found here. Okay, I'm going to tell target element is found, whatever the found element is going to be there. So now we are given as a target is equals to 12. So it should be, if I run the specific program, I should get the program like the target element is been found over there. Okay, so when I execute the program, you can see target element is not found. Okay, 12. So it is telling not found. Okay, so what might be the reason? So let me give a little bit spacing over here. Once I save it here, so what I'm checking here in the condition, target, okay, if the condition is not, okay, if it's equals to -1, right? So this my bad. Okay, so whenever we are using it is equals to, if the index is returning -1, then it will be not found. If it is not equals to -1, it will be found, right? So if I execute it now, I will be getting a correct output. You can able to see it is going to the target element is found here. Same way, if I try to search for 102, if I just change the target to 102, if I execute, you can see the target element is not found, that is 102. Okay, so this is basically, this program is working fine over here. So this is how the specific linear search is going to be there. So I hope you got it. So in the next session, we are going to look onto the binary search. Take care. Bye bye.
Hey guys, welcome to the section 3, session number 15, a last session into the section 3. So let's look on to the binary search algorithm and how it is going to be there. So let's first look up with the example of a binary search, how it is going to be there and what is the formulas we are going to apply. Then we are going to look onto the Java program for it. So let's begin with the code. So sorry, first an example. So I'm going to come back to the notepad over here. So let me insert one specific symbol, like let's try to insert the value for us. So we'll have an array here. Okay, so let's imagine we have some kind of an array. So let's take some examples over here. Okay, so in this specific example, let's imagine we are having some elements. So let me write some kind of an element over there. So for this, I'm just going to little bit, I'll zoom it. So let's zoom this one. Okay, so imagine I have some kind of an element array. So basically binary search algorithm work for the sorted array. Okay, so I'm just going to mention this is going to be your sorted array. Okay, so I'm just going to tell this is your going to be the sorted array over here. Okay, so I'm going to tell some element here. We are having some 10, we are having some 20, 35 and 42. Let me add some 53. So let's add some 77 and 90. Okay, this is going to be your sorted array. So we are having some indexing position here, right? So I'm going to tell this is going to be 0, 1, 2, 3, 4, 5 and 6. We are having this 6 over here. So when we are having an element 6, so I wanted to search for an element here. So let's imagine I wanted to apply this search for 20. First I wanted to search for an element that is 20 over here. Okay, let's imagine this is your going to be here. So in this, basically we are going to, first I'm going to tell this is going to be your low value and this is going to be your high value over here. Let's imagine this is going to be your low and this is going to be your high value here. Okay, so here I wanted to first find out the what is the middle element here. So I wanted to search for the middle element. I'm going to apply the mid value. Mid is equals to low plus high divided by 2 over here. Low plus high divided by 2 here. Okay, so when I apply this specific low plus high divided by 2, so when if it tells here what is the low value here, so low value is going to be 0 and high value is going to be 6. Here I'm going to divide it with the 2 here. So 0 plus 6 this is going to be 3. So I'm going to get the mid is equals to 3 over here. So I'm going to tell this is going to be your mid value. Okay, this is going to be mid value. So imagine if I suppose if I get here as a 4.5, you can treat it as a 4 itself. Okay, if you're getting 5.5, you can treat it as a 5. Like this also you can treat it. If you imagine there are a 7 array and there is a 7 divided by 2, it will be 3.5, right? You can treat it as a 3 itself. Okay, so this is also one kind of a scenario it might occur. So what I need to do next? So next I wanted to first I need to use one condition here. Okay, so first I'm just going to tell if the search element is 20, right? The search element is 20. So what is the value of the middle element? So mid of 3, basically if in the middle value that is a 3, we got 3, right? In 3 we are having as a 42 here. Okay, we are having mid is equals to 42, search is equals to 20 now. So
if the search element is lesser than the mid element, I'm just going to tell here one condition. If the specific search is lesser than mid value, if it is lesser than mid value, look onto the left side. Okay, look onto the left side. Okay, else if the specific search is greater than the mid value, if the search value is greater than the mid value, look onto the right side. So what is meant by left and right over here? So whatever I am seeing here, right? So if I just tell here, this is going to be your left. Okay, and from here, the right side, the middle value element, from here to here, it is going to be your right side. Okay, that is what I am saying it here. Okay, so what I said, so whenever if the search is lesser than or equals to mid value, look onto the left side or else look onto the right side. So there can be another scenario as well, right? If the mid value is equals to search element, imagine I am trying to search for 42. If the search was 42, when the mid value I got it, at the search itself I got the element, so there will be a search will be found. Here no need to apply the formulas, this one if else condition. Okay, there can be this specific scenario as well. So now let's take this example now. So now I need to look onto a left side here. So let me create one box over here. So again, I'm just going to create one specific box. So now we are having an 10 here, then we are having a 20 here, then we are having an element 35 here. We are having an element that is 35. So again, I need to apply the same formula. This is going to be a low, and this is going to be your mid value, and this is going to be your right value. Now I'm searching for an element here. Search was what? Search is equals to, search was 20. Now search is equals to mid, right? You can see, first I need to check condition. If the search value is equals to mid value, yes, it is mid. So you can see I was searching for 20. When I search for the 20, I got the 20 in the middle itself. So here I can just tell here as a search is FOUND found over here. This is how the search algorithm is going to work. Okay, then next, like this is the one example. So let's take the second example. So in this search example, I'm just going to tell, in this search I wanted to do it for the 90 here. So I wanted to search for an element that is 90 here. Okay, so when I want to search for an element 90, so now I need to basically, if I apply the formula, the 90 is what? 90 is greater than or equals to mid value, right? 42, 90 is greater than or equals to, greater than 42. So I need to search for the, I need to look onto the right side. So I'm just going to tell 53, 77 and 90. So I'm going to take an example here. So I'm just going to tell here something again, that is I'm going to apply the formula, that is what is the data we are having here from the box. I'm going to take it 53, 77, 90. So I'll just take it here as a 53, 77 and 90. So again I need to apply the same formula. So I'm just going to mark this as a low, and I'm just going to mark this as a high mid, and I'm just going to mark this as a high value here. So in this case I wanted to search for the 90, right? So again I'm just going to tell, so 77 is lesser than 77 is lesser than mid value. The search element is 90. 90 is basically greater than 77, right? That is your mid. So I need to look onto the right side. So after looking onto the right side, so I have an only element that is a 90. Then I am just going to match with this. So here 90 is equals to mid, what 90 is equals to target, whatever I was searching for. Here also I can just tell here as a search is found over here. So imagine if their element was not present, then there will be search will be not found over here. So this is a very simple, that we will apply mid, low plus high divided by 2. We are just applying the divide and conquer technique, and we are just searching for the algorithm. So just you need to remember, first apply the formula, check if the target element is equals to middle value. If it is correct, then the element is found. If it is not, if the search element is lesser than the specific middle element, then look on to the left side of the box. Then if the search is greater than or equals to mid, look on to the right of the box array over there. Okay, so you can see in the single step itself, you can ignore the left half of the arrays from the list. Imagine if you are having 1,000 elements, we are trying to search for a specific element. In a specific first iteration itself, we are going to ignore 500 elements, and in the next iteration 250, in the next iteration some specific 125 something. So like that you will be applying it. So here the half of the time will get reduced, right? So that is why we are going to use this specific approach. So if you take this specific thing, so let's see the specific algorithm for this using Java, and we are going to solve it over there, writing the specific program. So the program is going to be something like this. Okay, so let's try to see how the program is going to be there. I'm just going to come back to the Eclipse here. So in the Eclipse, I'm going to create one new Java program. I'm going to tell here as this is going to be your binary search. Okay, and I'm going to create a public static void main function to it, execute it here. Okay, so let's try to see how it is going to be the program of the binary search. So in the binary search, I'm just going to write the logic for a specific thing. Let's try to create one method here that is going to be returning some value, same like a linear search. I'm going to tell here as public static is going to return your data. So I'm going to tell as a binary search. This method takes an array. So I'm just going to tell int of array, basically int of a or int of array, and it is going to take the specific target element as well. So target target element. So when this is the specific condition, so here I'm going to mark it here. So left, basically I'm going to tell as a low plus high. You can tell low or you can tell as a left, whatever you want. Okay, so if I just tell you what you have said here, we have said as a low, mid and high. You can treat low is equals to left and high is equals to right side. Okay, so let's use the low or high, whatever you want, you can use it. Okay, so I'm going to use it as a left. So left value I'm going to initialize this indexing position with 0 starting, and what is going to be your right? So what is going to be your right? So right is going to be the array length, right? Basically it is going to be array dot length length minus 1 here, right? This is going to be your right side. Basically we are just mentioning low is going to be 0, high value should be indexing position 6. If you want to get 6, the total array size is 7. So 1 2 3 4 5 6 7, right? 7 minus 1, 6 we will be getting as an indexing position. So that is what we have given as a right here. Okay, so I'm going to tell here, you can just tell this is also, you can make it as low. Whenever you are talking about this you can just tell as this is going to be your high value. Okay, then next, so next I am going to run one while loop here. So first and foremost I'm just going to check one condition, if the left is lesser than or equals to right value. So basically this condition should get matched, right? If the left is lesser than or equals to right, whatever the 0 should be lesser than or equals to right. Okay, if it is not there, then only it is going to have a single element. We are having an elements in the array, then only we need to apply the loop, then only we can apply the formula. So first I'm just going to find what is the middle element. So mid value is going to be basically left plus right divided by 2 here. Okay, left plus RIGHT right divided by 2 over here. Okay, so I'm just going to tell mid is equals to left plus right divided by 2 over here. Okay, so whenever we apply this specific formula, then I'm just going to check if this specific element array is present or not. I'm going to tell if the array of mid value, if the specific array of middle value, we found the mid value, right? If the array of specific mid value is equals to specific target element, target element. Okay, if it is equals to target element, I wanted to just return that is mid value here. I wanted to return the mid element here. Okay, if not, if this specific if it is condition is not fine, let's try to see another condition as well. So if the specific target element, okay, I'm going to tell if the array of mid value, if the specific array of mid value is equals to is lesser than target. First let's say this, so lesser than the target element. Okay, what are the mid values there? If it is lesser than target element, obviously I need to look onto the left side, right? So I'm just going to tell look onto the left, then make it left is equals to whatever the left will be there, right? For the left I'm just going to increment mid plus 1 over here. Okay, mid value was there, right? I'm just going to make it as a 1 here. So else, so I'm just going to tell else look onto the right side. So right is going to be what? Mid minus 1 over there. So I'm just going to tell right is equals to mid minus 1. So if it's the condition, I'm going to look onto the left side, or else I'm just going to look onto the right side over there. So after doing this specific thing, so if it's all the thing is working fine, so whatever the value we are getting return, so I'm just going to return that one. So I'm going to tell return minus 1 over there. If it is not present, I'll be returning the minus 1 over here. That's it. Okay, so this is going to be there over there. So now let's try to write this specific program for let's pass the input over here. I'm going to tell int of basically I'm going to tell int of array is equals to, let's try to add some sorted array 2 3 4 5 45 and 55 67 89 90 100. So imagine we are just giving the sorted array. This is basically sorted array. This works only for the sorted array. Okay, so we are given some sorted array element over here. So in this specific thing, I'm going to tell the what is the target element you wanted to find. I'm just going to tell I want to find that specific target element, that is 89. Let's imagine I wanted to search for the target element 89. So I'm just going to tell here as an int of index, it should return that is going to apply, that is going to call the binary search algorithm. Okay, in this I'm passing the int array and the target element for this. So once I pass this, I'm just going to check if the specific index value is equals to -1. Okay, if it is returning -1, then basically I can just tell here as a element is not found. I'm just going to tell here as something like target element is not found. Okay, I'm just going to pass the specific target here also, target target. So if it is not the condition, then I'm just going to come back to the else part. So I'm going to tell here as a SYSOC. So I'm going to tell target element is found. I'm just going to tell target element is found. So I'm going to just pass the specific target to it. Okay, just save it. So once I execute the specific program, let's see what is going to be the output here. So I'm searching for an element that is n89. So it is present. So I need to get the target element found and I need to get the output here. Okay, where is the output? So if I execute again, so I need to just see for the target. So it is, where is the declaration, coverage, console? Yeah, console is here, right? So here if I try to again run it again, so if I try to execute it again here, so basically, so it is taking a little bit time. So let's see what is happening here. So you can see I got this specific output. The element is found, that is 89 here. So I did one mistake here. So basically whenever we are finding a mid here, right? So I need to tell left plus right minus left divided by 2. So to get an accurate mid value. So we are using this, change this formula to this. Okay. This is how the things it is going to be work for the binary search. So let's try to imagine I wanted to search for an element that is 189. So if I execute this one, so I should get an output that is this specific element is not found, that is 189. So this is how this specific binary search is going to work. I hope you got it. So take care guys. Thank you. I'll catch you with the next session. Hey guys, welcome to the section 4. Let's begin with the graphs concepts. So in the previous sessions, we have seen about the linear data structures. We have seen about arrays. We have seen about linked list, W linked list, circular linked list, and even we saw depth on the stacks, queues, circular queues, and so on. So from this specific session, we are going to begin with the non-linear data structures like graphs, trees, and so on. We are going to look onto it. So first we are going to complete the graphs concept and we are going to see in the depth what all the algorithms are present in graph, how we are going to represent the specific graphs and how it is useful and what exactly is graph over here. So the previous linear or all will be having one sequential manner and will be having kind of an order. But when you talk about the graph, non-linear structures doesn't have any kind of an order. We can traverse in any way we want. So that's why we have named it as a non-linear data structures concept. So beginning with the what is graphs over here. A graph is basically a data structure algorithm concept is used to represent the relationship and connections between the nodes. Okay. So in graphs, it's basically consist of two major things, that is vertex and the edges here. So vertex, you can call it as nodes as well, or you can call it as a specific nodes or vertex. Okay, and we'll be having the edges. So the connection between the two vertexes, we are going to call it as edges over there. So if you see the representation of in the right side, so you can see the 1, 2, 3, 4, 5 is your vertexes, or you can call it as a nodes, and the connection between the 1 to 2 and the connection between 1 to 3, 3 to 5, 4 to 5, 2 to 5. So this all we can name it as the edges over there. So basically a graph is equals to vertex plus edges over there. Okay, that is vertices or nodes, or you can call it as the vertices or the nodes plus edges. So this is basically we are going to call it as the graphs over there. So coming back to the more nodes about the nodes, edges and adjacency stuff here. So when we talk about the nodes, nodes or vertices are fundamental units of graph basically. It represents the objects or entity in many applications. So whenever we deal with the whatever we are having in nodes, right, like 1, 2, 3, whatever we saw. So these things we can treat it as kind of an objects or the main entities for the traversal stuffs. Okay, and we can treat it these things as an attributes or the properties are associated with them. Okay, so imagine if we have an India map, there is a Karnataka, Tamil Nadu, Andhra Pradesh, Goa, Maharashtra, and all those things. So these things we can treat it as the vertices. Okay, these things we can treat it as a vertices, and the path. If you want to travel from Karnataka to Tamil Nadu, so there will be one roads, right? So those roads you can treat it as the edges. Okay, so you can take it as this as an example. And edges is, as I said, the connection between the vertices, with the two vertices, okay, and they represent the what is the relationship between. So whether it is having a one-to-one or it is having a direct relationship or undirected edges, there are two types of an edges basically, like directed and undirected edges. So we'll see with an example. If we talk about the undirected edges, it is having a two-way connection basically. Direct edge is having only a one-way connection, okay. So this is all about the edges, and which represent the relationship between the two vertices. And adjacency basically represent kind of a matrix data here. The two vertices are said to be an adjacent, okay, if there are edges connected with them. So if the two vertices are said to be adjacency when we are having a connection between the two specific vertices, that is nothing but your edges connected with that, okay, in an undirected graph. So undirected graph basically which is having a two-way connection, right? In an undirected graph, adjacency is symmetric. If the A is adjacent to vertex B, then the vertex B also is adjacent to the vertex A. I mean, if there is a path to reach from 1 to 2, and there should be also be a path to reach from 2 to 1 as well. So that is a bidirectional, right? So that is, we are going to call it as a adjacency, okay. If a vertex A is adjacent, if the vertex B is then connect with the vertex A, and vertex B is also called as a adjacent if the vertex B is connect with the vertex A as well, okay. This is what about the adjacency stuffs over that. So we are having a lot of types of graphs over here. As I said about the undirected graph, directed graph, and thing. So as I said, directed graph is basically is having a two-way connection. The undirected graph, in the undirected graph, it just have no direction, and the relationship between the two vertices is symmetric. I mean to say, there will be a two-way connections here. In the undirected edges graph, there will be having a two-way connections over there, okay. But it is not only like symmetric to the one thing, it is symmetric to the two-way. So when we talk about a directed graph, edges have only a direction. Then a relationship between two vertices can be only one way. I mean to say, there can be only one way to go from one node to another node, or to go to one vertex to the another vertex. So we have a weighted graph. So weighted graph is something like where we'll be adding some kind of a weights to it. So imagine I have created if you take an example of an India map. So imagine there is a from Karnataka to Tamil Nadu, there is a 300 kilometer. Okay, this 300 kilometer you can treat it as a weight here. Okay, if I wanted to traverse from from Karnataka to Goa, imagine this is 500 kilometer. If I wanted to traverse from Tamil Nadu to Andhra Pradesh, it is having 400 kilometer. So these 4 kilometers you can treat it as this as kind of a weights over here. The weights is basically for the edges we are going to give the weightage over there. So there is going to be called as a weighted graphs over there. So we'll see along everything with an examples over there. Okay, you can treat it in the professional way. If we talk about what is weighted graph, the edges has a numerical weight. So we'll be defining the what is the cost of it. What is the cost of the specific edges? Okay, between the two vertices. Then we are having a cyclic graph. So cyclic graph is basically a graph that contains at least one cycle. So a cyclic graph means if you start from the node 1, it should again you can come back to the same node. So that is having a cyclic graph. A cyclic graph means a cycle does not contain the cycle over there. Okay, we'll see all these things with an example over here. And a connected graph. Connected graph is basically is what? A graph that is having a path between every pair of vertices. Okay, a graph which there is a path between every pair of vertices. So that is going to be a connected. Disconnected graph is basically a graph which some vertices are not connected to others. Okay, so a vertices, if you have 6 vertices, all 6 vertices are connected. So that graph you can call it as a connected graph. If a vertices which is not having connection, there we can suppose there is a 6 vertices, for 2 vertices there is no idea, there is no connection. So those kind of graphs you can call it as a disconnected graph. We'll see everything with an example over there. Okay, this is a theoretical part. So let's coming back with the example part over there. So let's see about the one specific graph over here. Okay. So in this case, so if I just take it here, let me write the specific thing. Yeah. So let me tell here, let's take an example over here. Okay. So I'm just going to take the color as red color over here. Okay. So let's check what is graphs over here. So we know, right, what is graphs. So graph is basically a connection of vertices plus edges over here. The graph is basically connection between the vertices plus the edges over there. So this specific graph has the vertices and the edges, the collection of vertices and the edges that we have seen. So let's take an example. We have a vertex 1 here, and we'll be having a vertex 2 here, and let me do it as a 3 here. Let's create a vertex 4, and let's create it as a vertex 5 over here. Okay, so this is basically a what? It is a undirected graph, right? So I can just tell this is basically we can treat it at this is going to be your undirected graph, because we are having a two-way connections over here. So 1 to 2 also we can go, and we can go from 2 to 1 as well. So 1 to 3 also I can go, 3 to 1 also, 1 to 4, 4 to 1 also I can reach, 4 to 5, 5 to 1 also I can reach it over there. Okay, so this is the undirected graph over there. Okay, so let's take an example. Let's see what all the vertices here. Let's try to write what all the vertices over here. So I'm just going to write the specific vertexes. Vertexes is equals to vertices or nodes, whatever you want, you can call it. So here the vertexes are 1 comma 2 comma 3 comma 4 comma 5. These are all going to be your vertexes. Okay, and let's take in the what is going to be the edges. Okay, edges comma. So there is a edge between. I can just tell there is a edge between 1 to 2. Yes, there is a edge between 1 to 2. That is correct. And again I can just tell there is a edge between 1 to 3, and there is a edge between 1 to 4. Okay, these are all the edges. So again I can just tell there is a edge between 2 to 1. Yes, again 2 to 3 also we are having, and 2 to 5. This also specific vertex we are having. When we talk about the 3, so we are having a connection between 3 to 1, and we are having a connection between 3 to 2 over here. This is the another specific connection over there. Okay, so then let's take an example of again. So again, let's take an example. We have an example. Let's take it here also. It is having a connection. So let's try to draw another. So we are having this specific vertex as well. Okay, you can draw a straight line. So I can just draw like this. Okay, so let's we are having like this. So this connection I have a 3 to 1, 3 to 2. Again, let me have 3 to 4 also we are having. Again, we are having 3 to 5 as well. So if we take an example of 4, we are having a connection between 4 to 1, and have a connection between 4 to 3 here, and have a connection between 4 to 5. Right? These are all the connections we are having it. Again, if I take an example of the 5, so connection between 5 to 2 we are having. Again, we are having from 5 to 3. Again, we are having from 5 to 4 over here. So these are the possible edges from this specific graph. So we have a vertexes, and these are the specific possible vertex which we are getting from the specific things over here. So this I can just tell here, edge is usually defined by the two endpoints. So what is edge? Edge is something that is a connection between the two specific endpoints or two specific nodes over here. So when we talk about the undirected graph, so one is having a two-way connection. Basically, this is having a two-way connection because it is having the two-way connection. So I'm just going to write as it is. It is having a specifically a two-way connections over there. Okay, so this is going to be your two-way connections over here. This is all about the graphs, and this is about the vertices and the connection between the edges over there. So we saw about something like a cyclic graph. Even you can call this as a cyclic graph. So if I have a 1 here, we have a 2 here, then we are having a 3. If this is the case, basically I can tell this is going to be your cyclic graph because it is forming one specific cycle over here. And if I take an example, this is another one. So let's take an example. Let's take here as a 1. So let's take an example. Let's take an 1 here. So again we are having a 2 here. Then we are having something like a 3 here. Okay. So if I just draw the connection between here, this here to here, so you can see this is not having any connections over here. You can see this is not having any kind of a connection between. Again, if I start from 1, I cannot go back to again 1. So this we can treat it as a acyclic graph. This is not your cycle graph. This is going to be your acyclic graphs over there. This is going to be the acyclic graph over there. Okay. So this is how the things is going to be there. So again, I am just going to do a little bit thickness over there. So let's see it over here. So let's see, this is the basically this is a cyclic, and this we can say it as a acyclic graph over there. Okay, let's take an example of this specific nodes over here. So we are having something, and let's take an example. Here we are having a 1, and here we are having a 2, and here we are having a something called as a 3 over here. Okay, so in this specific connection, we are having this specific node over here. What all the vertices here? We are having the vertex 1 comma 2 comma 3. So and the edges. So basically this is going to be your as a directed graph because it is basically having the connections here. They are saying particularly you need to go from, if I tell 1 to 2, I can go only from 1 to 2. I cannot go from 2 to 1 over here because it is having something like a directed graph. It's basically a directed graph, right? So I can just tell it is having a directed graphs which is having some kind of a connections over there. So in this edges can be, that is a 1 to 2 can be one edge. Okay, we are having an edge, and basically we are having an edge from 1 to 3 as well. This is another edge. Again we have from 2 to 3. So again we are having 2 to 3 we are having it. So 3 to 2 is not there. Again 2 to 1 is also is not there. Again if I just come back to 3, so only there is an edge for that we are having a 3 to 1 we are having it. So these are all the 4 possible way of edges for this specific example. Okay, there is a connection 1 to 2 and 2 to 3, 3 to 1, again from 1 to 3. Only the 4 possible way of this is going to be a directed graph over here. Okay, so in this case we can have an in degree and out degree. So there is something called as a in degree, and we are having something called as a out degree over here. So what is meant by in degree and what is meant by out degree? So in degree is basically number of edges going out of the node. Okay, I'm going to tell here as a number of edges basically going out of the nodes. This is going to be the in degree, and what is going to be the out degree? It is a number of edges coming into the node. Okay, I'm going to tell coming into the specific node. So that is going to be the in degree, out degree over there. Okay, the number of edges having the in degree over here. So let's take an example for a 1 here. So let's take an example here as a 1. So in this specific example, I'm just going to tell here as in this specific box, let's try to tell here. So let's take an example for the specific one here. So what is the specific in degree and out degree? So let me write it here like this. So let me add something like this box again. So we're going to tell in degree for 1 and in degree for 2 and what is the out degree for specific one over here. So let me right click like this. So we are having a 3 over here. So let's tell what is the in degree and what is the specific out degree over here. So specifically for 1, what is the in degree? Number of edges, what? Going out of the node, right? Out degree means number of edges coming to the node here. So what is number of edges going out? So for the 1, what is going to be the in degree? So in degree is going to be 1, right? Basically, if I talk about the in degree of 1, in degree of basically stuffs, it is having 0, right? So what is the in degree of 1 here? So in degree of 1 is basically a 0 here, because okay, 0, because you can see it is 1, because from the 3 we are getting one specific node, right? So it is going to be 1 over here. So what is the out degree? Number of edges coming to the node, right? Some of it coming to the node over there. Okay, so basically if in this specific case, so let me erase it. Okay, let me write the again. So the number of in degree is basically number of incoming edges. So I'm just going to tell it as a 1. What is the number of going? So just I'm just going to tell in the next going is 1 and 2. To 2 is going, basically this is the 2. For the 2, in degree is 1, out degree is also 1. So I'm just going to 1 like this. For the 3, basically incoming nodes are 2 here and outgoing node is 1 here. So I'm going to tell incoming nodes is 2 and outgoing node is only 1 over here. That is going to be there. So in degree is number of edges basically coming towards it. So here I have done one specific mistake. So I want to just replace this one. Okay, so let's replace this thing. Basically I wanted to tell here it is basically in degree and out degree. I have just made it one specific thing here. It is going to be your out degree. This is going to be the in degree. In degree, number of edges coming to the node, and out degree is basically number of edges going outside the specific node. Okay, that is going to be there. So for the 3, if I talk about the number of outgoing nodes is only 1 over here. Okay, so you can see it is only going one way. So that is going to be about the in degree and the out degree nodes over there. So along with that, we saw something in this specific thing called as a weighted graph something. So if I have here as a 3, 4, if I have as a 4, so like this, I'm just going to tell here as a like this. I wanted to have this one. Let's imagine there is a cost from 2 to 3 and we have some 3 to 4, cost is 30. So this we are going to call it as the specific weighted graph. So these things we are going to call it as a weighted graph, because why? We are having some weight. You can see from 2 to 3 we are having some kind of a weight that is 10. From 3 to 4 we are having something called as a weight 30. From 3 to 4 we are having something weight called as a 20 over here. This kind of graph we are going to call it as a weighted graphs. So we saw about the lot of graphs over here. This is undirected graph and a directed graph we saw, and we saw about the cyclic graph, acyclic graphs, and even we saw about the weighted graph, and we understood what is going to be the in degree and what is going to be the out degree. So number of in degrees is basically the incoming edges from the specific other nodes, and out degree is number of edges going outside for the specific nodes over there. These all the things is going to be in under the graphs over there. The graph is a collection of edges and vertices. So in the next session, we are going to discuss briefly about the representations of the graph. Take care. Bye-bye. Hey guys, welcome to the section 4, session number 16.2. So let's understand the graph representations into this session over there. So let's begin with an example. So coming back to my notepad over here. So in the previous session, we understood about the graphs and its specific types over there. So now let's come back to the representations of the graphs over here. So in this specific representation of the graph, let's try to imagine. So there are 3 ways of representations of the graphs over here. So let me write those specific things over there. So the first one here is graph representation is basically we are going to call it as a adjacency matrix. So I'm just going to tell adjacency list over here. Okay. So adjacency list is the one, and the second one is going to be the adjacency matrix. Adjacency matrix is the next way, and the third one is going to be the cost adjacency matrix. I'm just going to tell cost adjacency matrix. So these are all the 3 possible ways of representations of the graphs: adjacency list, adjacency matrix, and cost adjacency specific matrix over there. Okay. So now coming back to this concept over here, let's imagine we are having this specific graph. Let's try to give it here as a node 0. Let's try it here as a 1. And here I'm just going to give it as a 2 here. Let's give it this as a 3 over here. Okay. So this is going to be an undirected graphs having the 2-way connections. Let's imagine is a graph which is having the two-way connections over here. So if I talk about the what is the adjacency list of it, I'm just going to tell here as a what is the adjacency list of this specific graph. Adjacency, let me erase this. So let me tell what is the specific adjacency list here. Adjacency list. So as the word it's saying, there is a list over there. So if we talk about take an vertex 0 here, so for the vertex 0, the specific adjacency list, basically it is having the connection for 0 to 1 and 0 to 2. So it is can be 1 comma 2 can be the specific thing. And if we talk a specific vertex is 1, so for the vertex is 1, we have a connection for 0 and 3 here, right? So I'm going to tell for the 0, so the specific vertex is 1, we are having the specific thing that is a 0, and I am having this specific thing that is a 3 over here. So I'm going to tell it as a 3. And for if we take an example for the 2, we will be having a 0 and specific 3 here. So for the vertex 1, we have a 0 and 3 here. So I'm going to tell as a 0 and 3. For the specific vertices 2, we are having the 0 and 3 here as well, right? So 0 and 3 for this as well. And when we take a vertices 3, so it is having the connection for 1 to 2 over here. So this is going to be the adjacency list over there, okay? So for the specific vertex, what all the specific next two edges or next two specific vertices are connected. So it can be 2 or it can be 3 in number. So you should see how many outgoing edges are connected with these specific vertices. So those specific vertices, the next vertices will be the adjacency list for it, okay? 0, 1 and 0, 2, 1, 0, 1, 3 and 2, 0, 2, 3. Again for 3, 1 and 2 over here. This is going to be the adjacency list over here. So let's see the specific adjacency matrix for this one. So if we take it here, a of I comma j, a of I comma j over here. So let's take a tell. So we are having the 4 nodes, right? I'm just going to maintain the 4 boxes, adjacency 0, 1, 2, 3. Again, I'm just going to tell 0, 1, 2 and 3 over here. So in this specific, we are having 0, 1, 2, 3. So let's imagine there is a connection between 0 to 0. So there is a connection between 0 to 0. So I wanted to check whether there is a connection between 0 to 0 or we have a connection between 0 to 1. Yes, we are having it, right? So is there a connection between 0 to 0? No. There is a connection between 0 to 1. Yes. If it is there, just give it as a 1. There is a connection between 0 to 2. There is a connection between 0 to 2. Yes, I'm going to give it. There is a connection between 0 to 3. No, there is no direct connection, right? So I'm just going to give it as a 0 for this. So let's imagine again for the 1 to 0. For the 1 to 0, we are having a connection. Yes, we are having it. Give it 1. So for the 1 to specific 1 to 1 is not there, give it as a 0 here, okay? And 1 to 2 we are having, yes, 1 to 2 we don't have direct, so it is giving to 0 here. So for the 1 to 3, so 1 to 3 we have it, so 1 to 3, yes, we are having, so give it as a 1 over here, okay? Same, just try to do it for other as well. So if you have it for the 2 to 0, we don't have, we have it, 2 to 0 we have, right? Yes, 2 to 0 we have, just I'm going to give it as a 1. Again 2 to 1, not there, give it as 0. Again 2 to 2 is not there, give it as 0. 2 to 3 we are having, give it as 1 here. So again for the 3 to 0 we don't have direct connection, give it as a 0. Again 3 to 1, yes, we are having, give it 1. Again 3 to 2, yes, we are having, give it. Again we have a 3 to 3, we don't have, just give it as a 0. So this is going to be what? This is going to be your adjacency matrix. So I can just tell this is going to be your adjacency matrix for this specific graph representation of it, okay? Then next, let's understand the last one, that is the cost adjacency matrix. So this is going to be your cost adjacency matrix over there, okay? So I'm just going to reduce little bit thickness of it. So I'm going to tell this is going to be the cost adjacency matrix, so cost AM. So let's take an example for the cost adjacency matrix here, okay? So you can have any example for it. So whatever there is a basically cost adjacency matrix here is, let's try to, there will be a weighted graph over here. What is the specific weight for it, okay? Let's try to imagine we are having a 0, we are having something 1, we are having 2, here we are having 3, okay? This is a specific, okay? Let's not give the element name 0, let's give it something else. Let's give it as 1 here, let's give it here as a 2, let's give it as a 3 and 4. Let's tell there is a cost is 5 here, and this is a cost 10, and there is a cost 30, and this is a cost is equals to 25 over here, okay? This is the specific cost over there. So can I do it like this? So it is not giving me the straight line. Sometimes it gives, sometimes it not gives. That's why let's keep it simple, okay? So let's imagine, so we add the 0, 1, 2, 3. So basically when I start with 0 to 0, so this should be not be 0, 1, 2, 3 over there, okay? So because we are having a 1, 2, 3, so on the top of it, in the top we are starting with 0. If it is like this, there is no a connection 0, right? So in this case, what we need to do here is, if it is the case, so we need to just divide it same as it is, how it is there. So let's try to tell here as there is a specific 1, and this is a 2, 3 and 4. So again I'm going to tell 1, 2, 3 and 4 over there, okay? So is there what is the cost between 1 to 1? What is the cost between 1 to 1. So there is a cost between 1 to 1 is 0 over here. The cost between 1 to 2 is 5. The cost between 1 to 3, specifically the cost between 1 to 3. So what is the cost between now 1 to 3? Direct we don't have, right? So 1 to 3 we don't have, just make it as 0 over there. Okay. And what is the cost between 1 to 4? 1 to 4 is 10. What is the cost between 2 to 1? 2 to 1 is 5. Cost between 2 to 2 is 0. Cost between 2 to 3 is 25. Just give it like this. The cost between 2 to 4 is not there. Leave it 0. The cost between 3 to 1 is not having directly. So give it 0. So the cost between 3 to 2 we are having as a 25. And the cost between 3 to 3 is 0. Cost between 3 to 4 is 30. Cost between 4 to 1 is 10. Okay, this is going to be your fourth, right? This is going to be your 4. The cost between 4 to 2 is not having direct. Let's give it 0. Cost between 4 to 3 is specifically at 30. The cost between 4 to 4 is 0 over there. Okay, so this is going to be your cost adjacency matrix. Just basically, as I said, right, it's kind of a weighted graph. For the weighted graph, whatever the cost you have declared, so just we need to put it into the specific graphs over there. Okay, if the cost is 0, then we can just fill it with basically -1 over there. Okay, so you can just tell if the specific cost is 0. Imagine for any cost, imagine there was a cost 0. Okay, if the specific cost was 0, then we fill with -1. Okay, if the cost is 0, we are going to fill with the -1 over there. Okay, so this is going to be your cost adjacency matrix, and we are using the specific adjacency list and the adjacent cost adjacency matrix and the adjacency matrix representations of it. Okay, so in the specific next session, we are going to look on to the specific spanning tree. So then we'll be looking on to the main algorithms of graph, that's crystals, primes, and Dijkstra. That I am going to take care with the coming session. Take care. Bye bye.